cooler air behind that front. So we'd be gusting in the mid to upper 20s at a couple hundred feet during the overnight hours. But as we get into the afternoon hours, should we be on the pad for an attempt on Sunday, we should watch those winds come down, and we'd be looking for winds gusting to about 20 knots or so at a couple hundred feet by the time we get to the window. Again, that's well below the liftoff constraint. So really we should be in pretty good shape Sunday as well. So we'd be looking for just scattered skies about 3,500 feet, good visibility, a little bit of breezer, as I mentioned, gusts to about 20 knots with a 20% chance of violation. And again, the principal concern there would be cumulus clouds. So that's all I have. Pending any questions, Mike, I'll turn it back to you.
All right, thank you. All right, we're ready for questions. And first off, I would like to remind you, if you're in the room, to wait for the microphone, state your name and affiliation, and to whom you're addressing your question. We have a phone bridge for those who are interested in calling in. And one thing, if you're following on social media, our NASA social media manager, John Yembrick, is here. He's tuned into the hashtag AskGoes. So if you have any questions and would like to convey them that way, please go ahead and do so, and we will be happy to start off with questions in the room. And Marcia Dunn.
Marcia Dunn, Associated Press, for either of the two NOAA gentlemen. I was hoping to get a cost on this satellite, and if this satellite had been up there for Hurricane Matthew, do you think you could have, there would have been better tracking and knowing it that it would stay off the coast here? Or I'm just wondering, how much improved would you have been able to follow that hurricane in particular?
Cost. Sure, let me start off. The cost, when we put big programs like this together, obviously there's a lot of development and implementation costs. So we sort of started off in the mid-2000s estimating its life cycle. So at that point, we estimated about $11 billion life cycle, which is buying 4 satellites, putting the entire ground system in place, and operating it for 20 years. So there's a lot of cats and dogs in that cost estimate. Is that usually people are interested in like the cost of what's riding right there, and so so the way I think it's best looked at is if I had to go buy a replacement one. So if I went to all of my vendors and said bring it back, that'd be about $500 million to replace the payload as we see it. So I'd like that. That's sort of a nominal cost of the
500 million.
500 million, yeah.
And on the modeling side of the house, then, so what would GOES-R do now if we'd had it when Hurricane Matthew was rolling through? First, it's important to remember that the satellite is a piece of a larger observing system. So the satellite is combined with ground observations, with modeling, and with other expertise that from our weather service and for others that pull together. What GOES-R then adds to that is, in its high resolution and its high repeat rate, it really brings a different, an acceleration to the knowledge of what's happening, particularly in the case of intensification of a storm. So you can see when it might move from a Category 2 to a Category 3 and 4, which right now might take a couple of hours between image suites to see, we'll be able to see in minutes as that intensification occurs. So for a steady storm that just moves normally, it won't be an obvious difference. But for something where you're looking for dynamic changes, the GOES-R capabilities will really enhance that ability. The second is the higher resolution will allow a much greater visualization of the eye wall and of the scattering of storms around the perimeter, so you'll be able to have more local observations of what might be happening on pieces as you look at the storm in different areas and different pieces. So as a part of the overall system, it'll take us a while to integrate the GOES-R capabilities into our observing system, and I think we'll still be seeing advances that we can't even anticipate right now as we do that over the next years and decades as we add GOES-R and S and T and U to the system. But those are the immediate ones we would see, both in the higher temporal resolution, so we see intensification when it occurs, and higher spatial resolution, so we can be more discriminating in what's happening in different regions in what might be a 500-kilometer wide hurricane.
James, did you have a question?
James Dean, Florida Today. I mean, really just following up on that idea, I'm just curious if, I'm not a forecaster, will I notice the difference? And still specifically with Matthew, I mean, can we say with certainty that we would have had a better model, we would have likely known where it really was going to end up rather than where we thought it was going to be, and how that would affect evacuations and so forth?
So I think it's it's fair to say, and it's that the improvements of GOES-R will improve our ability to do those tracking and forecasting. To say exactly whether it would be a 10% or a 50% increase in the resolution of a particular landfall is difficult to project specifically. But yes, you would have an improvement over time with the strength of the hurricane and the landfall probabilities. As we've seen over the last 30 years, as our projections on the landfall have narrowed down, as we have much better accuracy now than we did 20 years ago and 10 years ago. That's partially on-orbit capability, but it's also our modeling and our understanding. And that's what GOES-R. We're bringing an entire new spectrum of frequencies, of bands, of different visualizations that will improve our modeling over time. So it will be an improvement in those parameters that you mentioned. As far as what the forecaster will use was mentioned earlier today. Instead of waiting 3 hours for an imagery update, you'll be seeing it in near real time. You'll see image updates every minute or every couple of minutes with about a 5-minute latency. So there won't be a 3-hour wait for the next image of the full disk of the Earth. It will be minutes away. So you will see on a regular basis, within minutes, the increased resolution, the new imagery as the storm is changing and moving over time. So that and is direct broadcast to everybody in the United States and particularly to the regions that are experiencing severe storms. We'll be looking, I'm sure, be waiting for that and watching that in near real time.
Ken.
Hi, Ken Kramer, Universe Today and the Northeast Astronomy Forum. I got 2 quick questions for NASA NOAA people. One is you talked a little bit about the ground systems, and following up on what you just said, how have you improved those ground systems, and how will that help get this vastly increased data out to the weather forecasters more quickly? And the other question is, talk about the benefits of the partnership between NASA and NOAA as opposed to just NASA doing this or just NOAA doing this. Thanks.
I'll start with the first one. The investment in the ground system was really driven by the amount of data that's coming down from this mission. About 30 megabits a second was pouring down, and we're creating products on the fly continuously. And so you can never get behind, or the data will just stack up. So we're processing, putting products, and getting to the Weather Service on that kind of cycle, just immediately pass through these data. So very perishable stuff like the lightning data is getting to the Weather Service forecaster within seconds. I had a forecaster, we ran simulated data runs of all this to many weather forecast offices, and the best way I've heard one of the forecasters says, Greg, in the past when you've delivered the GOES satellite data, you've been showing me loops of what has happened. You are now providing me a movie of what's going on right now. So in a sense, that latency is so short that this data is getting to their hands immediately, and their excitement about how they can use it in real-time forecasting is really increasing. So there's a lot of, my friend down at the end here will be very excited to use these data sets in his everyday forecasting.
So on the NASA-NOAA, and I'll start and then I'll ask Sandra to pick it up. When I look at the NASA-NOAA partnership, I would characterize it in the way that there's breadth and depth. On the breadth side, NOAA has the breadth of the global mission, the weather mission, and we have the access to and the connections to the weather forecasters, the weather forecast offices, the users on a national scale. And we have the modeling and the capabilities to interpret the data from multiple sources, not just satellites, but others, as like ground radars, radiosondes, balloons, et cetera, to integrate that into a forecasting modeling capability and the ability to foresee what would be the next big step that we would need to improve that capability. What NASA brings is the depth. NASA has the technical and the scientific, the technical and engineering expertise to figure out how to turn that envisioned future observing system into a reality working with NOAA. So it really is a good mesh of we have the user requirements, we have the mission ownership. NASA has the capability and they have to take that and to make it a reality working with us on a day-to-day basis. And I'll turn it over to Sandra if she wants to add.
Sure, yeah, I'll just add. I think the partnership is multifaceted. So in addition to what Steve said, there's the whole concept of research to operations. So, NASA is focused on advancing research, advancing our technologies, understanding, the intricacies of how, in this case, how weather operates on Earth, the interactions between the ocean, the Earth, the atmosphere, et cetera, the sun. And so we develop our understanding or advance our understanding of those critical interactions and partner with NOAA to actually utilize it in an operational mode to support the weather forecasting. And I would say that this partnership, the scientists in both organizations and really around the world use data from both the research satellites that NASA builds as well as the weather satellites that NOAA builds. And there's even a partnership in terms of at times sharing platforms. So, for example, there's we're planning to fly RBI on the JPSS mission. So it's a case where, both in the past and in the future, sometimes we share instrumentation on common platforms, depending on whether it's a NASA platform or a NOAA platform.
Okay, we'll take a question over here.
Thank you. Sawyer Rosenstein with Talking Space. This is for anybody involved with the launch processing. I know obviously Matthew caused a bunch of the delays, but so did a problem with, I believe it was the Common Core booster. So wondering if you could go into a little bit more detail on what you guys actually did, or what problem was and what you guys did with this vehicle, and if it was the same thing that you did with the 401 that recently launched out of Vandenberg. Thanks.
So I'll go ahead and take that. So we have worked a couple of different small issues throughout the launch campaign. That's not uncommon. We have a very aggressive approach to prepare the vehicle to make sure we get to that 113th consecutive successful launch. So we had a couple of issues with a valve. We've worked an issue with a battery on the Centaur, and just a couple of minor things that we've done to make sure that we've got the best chance of being successful for the GOES mission. I wouldn't say that it's similar to what we did on OSIRIS-REx. Everyone seems to have its own separate little things that we have to deal with, but we've definitely taken a very conservative approach. We've worked it hard, and we're very confident that the launch on Saturday will be successful.
I was also wondering if that was related to the one last week out of Vandenberg.
So we did have a couple of issues that were similar to the WorldView 4 launch, which we had on Friday of last week. And so we worked those simultaneously. At one point we had a charter airplane in the air picking up new parts for both vehicles and going coast to coast to make sure that both vehicles were ready to go.
Okay, John Yembrick has been monitoring the hashtag AskGoes and has a couple of questions.
Yeah, there's quite a few good questions here, actually. One is, will there be any additional evolutionary changes to each GOES satellite in the series, or will basic instrument suites remain the same?
Yeah, we are building 4 identical spacecraft. That's one of the ways you keep the cost under control is you build that. So we will provide the same capability over the next 20 years.
The series was 2036, you said, the lifespan of the series, but what specifically this satellite itself, what is the expectation lifespan?
We expect each satellite to last about 10 years of operations, so they have enough fuel to last about 18, but the design is for about 10. So for 4 of them, that's 2, then you use 2 simultaneously in east and west, so 2 in the east and 2 in the west is what adds up to 20 years.
Thanks, and last question. For Greg, when do you expect the first images to come down?
We expect the first ABI images for about 2 months in, and we'll be having a great press release on it'll be like your baby picture, right? Yeah. First image of the ABI, so we'll let you all know when that's coming. Subsequent instruments will be a little bit longer. About 3 months in, we'll see the raw data start to flow, so the weather forecast will start to see the first flow of data about halfway through our test period. So.
I'd like to follow up on that first question about the stability of the GOES-R platform. As Greg mentioned, is we built 4 at once. That was for very consciously to make sure we retired the risk of building complex new instruments, and we built a bunch of them so that we have a consistent, reliable data set. But to take off of what Sandra Smalley had said a moment ago too, these are a piece of a larger system. NASA flies other measurements. The other nations fly other measurements in orbit, geostationary and low Earth orbit. So the GOES-R platform is a basic, very high-performing baseline, but we augment that with observations that we introduce over the period of that life cycle. So even though the GOES-R will be a flat performance over the next 20, consistent performance over the next 20 years, we will be consistently adding and mixing different measurements to increase the capability of the overall observing system as we do that.
Okay, we have a question here behind John.
Hi, Michael Phillips with Weatherboy Weather. My question is for the NOAA gentleman. In the extremely unlikely event there's an anomaly either with the launch or the deployment, how vulnerable is the U.S. to coverage from the existing GO satellite. If there is a failure with this one, can the third generation be sustained while we wait for the next GOES to be launched, I guess in 2018?
Are you the gentleman or am I the gentleman?
Nobody's ever called me a gentleman before, so.
I'll take that one. As Greg mentioned a moment ago, we have a constellation in orbit now. It's 3 satellites in orbit. We have one called GOES East and GOES West, one over each side of the continental U.S. Together, they provide observations 24/7. And we have a third, is our GOES Spare, which sits in the middle so it can pivot to either direction if we have a problem. Those 3 satellites are of different ages. They're fully meeting all observing requirements. Some of them are showing signs of age. But all of them are fully functioning. Our observing system is fully capable today, and we expect to be capable a month from now. If, in the event of an anomaly, which we don't expect, based on what Scott mentioned, the capability and the focus we did on making sure we have a good system, those satellites will continue to operate, and we expect to provide the continued service that we have. GOES S is the second of this 4-satellite series, is now targeting a spring of 2018 launch. And actually, I just heard from Tim Gasparini from Lockheed, just went through its environmental acoustics test yesterday. So it is an assembled spacecraft and system going through its environmental testing now and is well on the road to be launched in about 18 months, or a little less, about 16 months, I guess. So we have a system in orbit right now with 3 satellites. We expect those to continue to provide capable service for the foreseeable future. And in the event of a really, really bad day, we have another satellite, GOES S, coming along right behind us, and we will expect to continue to perform as expected for the nation.
Question in the back of the room.
Hi, Dave Jones with Storm Center Communications. This is questions for Greg. Greg, I know that GOES satellite doesn't happen overnight, and it took a lot of time and effort to put together the whole program. I was just wondering if you could give us a quick little description of when the vision for GOES started, and how you got the Weather Service and these other organizations to get ready to accept the GOES data once it gets up and operating.
Okay, Dave. The formulation, the ideas come out in the formulation stages where you have contractors and a government start thinking, well, what do we have today? What the scientists are saying, what could be? Those kind of ideas were floating around actually in the late 90s. Then in the early 2000s, you start formulating, well, I could do this, we could do it with multiple different satellites. Our first development production contract was let in 2004 for the Imager. So that tells you, that was the first hardware contract. So subsequent to that, by 2008, we had the rest of the systems under contract. But that's for us engineers, that's the easy part. the working with the user community is is equally challenging, because they're very much focused on today and forecasting and that. And so what we had to do is we put a number of scientists out into the Weather Service to start engaging them on what the future looked like, to start engaging them on what these data sets will start looking like, start engaging them on what they could possibly do differently and better. And so we started that about 6 years ago. We started flowing data sets. We actually simulated the GOES data by running models of the atmosphere, sampling them just like GOES would sample, take those samples and running it through our processing system to create products just like GOES would, and then streaming those products out into the Weather Service offices to start getting feedback from them and to start to get them used to the tempo and what high tempo resolution imagery would do for them, or what lightning data do for them. And over about 3 years, the excitement started to build. And so we have gotten really good engagement across the Weather Service over those years, where the enthusiasm is bigger than anything I've seen in terms of what's coming down the stream. When we first started doing this, they gave me sort of a cocked-eye look saying, well, yeah, everybody promises stuff, Greg. And after about 3 years of working with them, the feedback we started to get was, this is wonderful, I want in my office yesterday. So it's an example of how much work it takes to get the weather community used to new data sets and familiar with that. But the fact that we put all this work in for all these years means once we get the data turned on from this satellite, we're going to have a very engaged user community ready to use it from day one. So we're very excited about the success in working with users on that.
Hi, Matt Safino, KGW TV, and I guess this would be for Greg or Steve. What factors and pressure go into determining if GOES-R will become GOES-West or GOES-East? And when do you think that decision would be made?
Okay, good question, because this is a big change from existing capabilities. So we will look at several factors. One is the health of the constellation. I mentioned earlier we have 3 satellites in orbit. They have different ages and different performances on orbit. So we'll make a decision partially based on which constellation element is the most in need of replacement. Second is the checkout of GOES-R itself. We've mentioned what we expect it to be able to do. We have examples from from the Japanese of flying a similar instrument. So we have an idea, but we'll take the first 6 months to go through and really look at the performance and how well it integrates with our weather models, with our forecasters, to get a feedback on how we're utilizing it, how well we're utilizing it. And at that point, about L plus 6 months, launch plus 6 months, we'll make a determination whether it should go to east or west, with the location time to be about launch plus 1 year. So about this time next year, GOES-R will become GOES-16. It'll become GOES-16 sooner. It'll become GOES-East or GOES-West as we go through that. And as I fully expect, there'll be a lot of interest in getting it to one or to getting to both, which will be a challenge, of course, to go to both. So this will be not something that happens behind closed doors. There'll be a lot of interest, a lot of public discussion, I'm sure, from all the user communities. But about a year from now, it'll be located. About 6 months from now is our target to say where it's going to be headed.
Okay, we have a question further in the back.
Hi, I'm Mike Augustinak with CBS in Minneapolis. Kind of piggybacking off of Dave's question, we know when this new technology was starting to be developed, but remind us, how old is the technology that we're dealing with on the current GOES platform? When was that sort of being worked on?
The current GOES, the instruments on the current GOES were actually first done on GOES-I, so that was mid-'80s. So that design was really, late '70s, early '80s.
So this is a 40-year jump ahead.
And so this, and actually what we just did with those instruments, before GOES-I were spin-stabilized spacecraft, so you had a little bit different technology for the instruments, but you really took about the same from a channel perspective and just made it off of a 3-axis stabilized spacecraft. So it wasn't really dramatic from a user, a big jump at that point. So I really look back and say, since the start of the GOES program, there's been a couple of channels added, for example, to the imager, but this is a quantum leap that we haven't seen since the introduction of the geostationary program in the '70s.
Okay, we're going to take a question from the phone bridge, then we'll come back in the room with a question from Rick, and then we'll go over across the room here. I believe that we have Mark Gotch on the phone. Mark?
Yes, good afternoon. Thank you for your informative briefing. The thing of it is, we have learned, due to NASA's dedicated research, that our planet's population will be more vulnerable to extreme weather events, tornadoes, hurricanes, etc. in our future. We thank you for your dedication to this mission and what it will do to the future of forecasting. GOES-R is ready to go. We look forward to your mission success. Can you tell me, based on the future going forward, you launching 4 GOES-R satellites in the future, what will determine the spacing of those GOES-R satellites being launched? And will there be advancements, I would expect, in technologies going forward? You had mentioned they were built the same currently. Will there be changes to them at the times they are going to be launched?
Actually, Steve mentioned that GOES-S is already built and in testing. The instruments are basically built. We have 4 of our imagers completed, and Harris has finished all 4 of them. The 4 X's are finished. So in a sense, the capability is all being built in one fell swoop. And again, to reemphasize what Steve said, this is just one piece of the overall operational observational constellation. So other improvements can be done in other platforms and other capabilities that blend with it to make it a complete observing system.
Let me add a point to that as well. Greg, to what Greg just said is all true and important. But remember the contribution of GOES-R, this 40-year leap, as mentioned in the previous question, in terms of technology and capabilities, is being added to an existing system. When you introduce that level of significant enhancement, that quantum leap forward, it makes everybody else smarter too. It makes all the other pieces of that observing system more capable. So now with GOES-R's high resolution, high repeat rate and number of channels, it is comparable to our low Earth orbiters that also provide with less space, with less temporal frequency, a very high resolution image of the Earth. We fully expect that in time, as we learn GOES-R and we learn how to process the data of that plus our low Earth orbit satellites, we will find abilities and products and information sources from the combination of the different elements of the satellite, which will continue to grow over time. So even though we know right now what we expect GOES-R to do, we design the instruments, we know what it's capable of, we don't yet know what the system is capable of when we bring all these different elements together. So to put it differently, we know what GOES-R does, but we don't know what we can do with what GOES-R does yet. And that's going to evolve and increase over time, and it's going to be continually increasing as we add other instruments into the mix. So even though a piece is static, the system continuously improves as we integrate all the different elements together. And that's going to be a characteristic of this system for the next generation as well.
Okay, we have time for 2, possibly 3 more questions. Rick?
Yes, this is a question of Rick Lansby with WFIT. I guess this is a question for Sandra. Could you compare the overall capabilities of the GOES-R with the Cygnus mission, which will be launched here next month from the Cape?
So I am probably not the best person to answer that question, but I'm happy to get back to you on that one.
Okay. We have a question in the second row.
Thank you. My name is Erica Groh. I'm a meteorologist from WNBC. I had the opportunity to participate in the Hazardous Weather Testbed Experimental Warning Program back in 2014 in Norman. So I got to fiddle around with some of the, pseudo instrumentation that we're going to be getting access to in the near future. What I'm curious about, because there's been a lot of talk about how this is going to improve nowcasting. What about, as people talked about just in front of me here, what about the hurricanes? What about the mid-latitude cyclones? What about the hazardous weather events that involve snowfall, things that are more day-to-day even? How is GOES-R going to make our forecast better? Is this data going to be better because of the resolution or because we have 3 times as many channels on the infrared, or is it a combination of those? Is this data all going into the GFS model? Like, how is it going to benefit us directly as operational forecasters?
Yeah, you will have a chance with our scientists in a little bit on their press conference, so you can ask that one again. I would say that, we extrapolate from what we use GOES today, which is heavily in the warning program. So we've really worked with the Weather Service on how to do that. Once we get the data streams flowing, we have done some work with the modeling community, primarily with the rapid update models that really can take advantage of the temporal refresh capability of GOES. But until we get that data stream really flowing and fine-tuning it, that we'll start to see where those benefits will really play out. So again, where GOES is big impact today is in the warning program. We do see a lot of impact in the modeling program, but as you know, the modeling and the data assimilation is quite a significant science. And while we've started that work, when the data flows, I think we'll start seeing some major growth and impact with these data sets in the models.
Thanks, Greg. Unfortunately, we are out of time for this briefing, but as Greg mentioned, we do have a mission science briefing for GOES-R up and coming, and that one will be on NASA Television's media channel, and we invite you to stay tuned for that. Thank you very much.
Hey, you're watching NASA TV, on the air and online, every day, on this planet and beyond.
Good afternoon, and welcome to NASA's Kennedy Space Center in Florida. I'm Sean Potter from NASA's Office of Communications, and we're here today to talk to you as part of the GOES-R mission science briefing. GOES-R is NOAA's next-generation geostationary weather satellite and is scheduled to launch this Saturday. Once it becomes operational, it will revolutionize weather forecasting for years to come. Now, we've assembled a panel here of experts to talk to you about various aspects of the mission, and I'm going to introduce them now. Directly to my left is Stephen Goodman, GOES-R program scientist at NOAA, the National Oceanic and Atmospheric Administration. Directly to his left is Joe Pica. He is the director of the National Weather Service Office of Observations. Next to Joe is Sandra Kaufman, Deputy Director of NASA's Earth Science Division. And finally, Damon Penn, Assistant Administrator for Response at the Federal Emergency Management Agency, FEMA. Now, thank you all for being here, and before we take questions from the audience, each of our panelists have a few opening remarks that they'd like to make. So we'll start with you, Stephen.
All right, thank you very much. So I wanted you to know it's a big team that's put this all together. We have over 100 scientists across the country who've been working on the program for 1 or 2 decades now, developing the science products and the algorithms or the recipes for how to turn the measurements from the satellite into useful products for warning and forecasting. And you've heard earlier that GOES-R will make a tremendous difference, but I think we even underestimate what the capabilities will be. We only have about 30 new products that we make with the satellite, and we know there'll be hundreds more as we learn how to use the satellite. The main purpose of these products is to provide continuity from today's satellites into the future, but because of the advanced capabilities with 5 times as many spectral channels that lets us see different properties of the Earth and atmosphere, as well as the rapid refresh that we're able to do, which is 5 times faster than the current satellite. And then we have spatial resolution that's 4 times better. And so we see features now with GOES-R that we've never been able to see before. For example, we can see waves in the clouds, which are related to the turbulence that if you're flying on an airplane, you might encounter. And so we'll have early indication of areas to avoid, which we couldn't see before with our lower resolution. It was all smeared out. And I also put in a plug for space weather. Our new capability to image the sun will be 4 times that of our current SXI X-ray imager. And because the forecasters, when they try and diagnose the features on the sun that are going to lead to navigation problems and geomagnetic effects and communication outages, they take all the information they see, and it takes them minute to minutes to assemble that information. Well, now they have what they call a thematic map they can put together where they take all the information and within seconds now, they can see how things are evolving. So we can do it for the Earth-based high-impact weather, volcanic eruptions, to typhoons and hurricanes and severe storms. And right now we have a major fire outbreak in the southeast, and we'll be able to see the aerosols and the characteristics of the smoke and dust in that fire, as well as Matthew, which someone mentioned earlier, and I'll comment on that later. Thank you.
Great. Thank you, Stephen. I will turn it over to Joe.
Thank you, Sean. It's an honor to be here for this momentous occasion. At NOAA's National Weather Service, we're very excited about the launch of NOAA's GOES-R satellite. And most importantly, we're ready to use the information when it's available. We specifically want to recognize the NOAA GOES-R program, specifically Greg, the program manager, and Steve, my panelist to the left, for all their efforts over the past few years to ensure that there was collaboration and support for activities to make sure that we're ready to use all these revolutionary products. So thank you, Steve.
Thank you.
It's our mission at the National Weather Service to provide weather and water forecasts, warning, and watches for the protection of life and property. To do our job, we rely on a whole host of observations, a whole portfolio, a key one being geostationary satellites, not only to monitor and provide information about evolving weather systems, but also to feed into our weather models to help forecast weather for tomorrow, this weekend, next week. We're excited about GOES-R because it's going to help us to do our jobs better. You've heard the terms game changer, revolutionary. It really is. It's going to be like looking at, instead of black and white TV, HD. NOAA's GOES-R will scan the skies 5 times faster than the current GOES system, with 4 times the spatial resolution and with 3 times the spectral bands. This means we'll have better quality data at high resolution far more often than we do today. Forecasts have far more detailed views of weather systems. We'll be able to see rapidly developing events in real time. And when we see an evolving weather system, we'll be able to zoom in and use that high spatial resolution to take pictures in 16 different spectral channels every 30 seconds. This spectral imagery, combined with our Doppler radar data, for example, will improve our understanding of whether a storm is growing or decaying. It'll help us track severe storms, including tornadoes, forecast wildfire movement, track plumes from volcanic eruptions, and tell whether a hurricane is intensifying. This past year, we've seen a number of destructive heavy rainfall and flooding events. With better quality data from GOES, forecasters will be able to better see where those rain bands are actually impacting us, giving them more confidence in predicting where the flash flooding will occur. Getting this out to the public in a more timely manner, and even to our partners in FEMA so they can manage the response. Our aviation weather improved. More accurate and detailed information on the occurrence of fog and ice, wind, and lightning from GOES-R will help with aircraft flight routing, making sure that all of our family members are especially traveling well during the holiday season that comes up, like we're doing today with our current GOES network. So I mentioned the lightning mapper. We're very excited about this new capability in space because it helps forecasters identify storms that are the biggest threat. That basically, lightning is correlated to some of the most severe weather. So we can see where hazardous conditions such as damaging winds, tornadoes, large hail, and flash flooding will occur. GOES-R will also improve forecasts for space weather. Space weather instruments will monitor the sun and the environment in space, so we can provide watches and warnings that have to do with radio communication outages, navigation, and power grid impacts. NOAA's GOES-R is a major step forward in our effort to build a weather-ready nation. By advancing our observation capabilities to the next level, we will be able to offer new and improved forecasts, products, and services to help save lives and property. It's an honor to be here for this event. Thank you.
Great. Thank you, Joe. Sandra, you're up next.
Thank you so much, Sean. To me, it's a really, truly pleasure to be here today. Part of my career has touched GOES in many ways, and in a past reincarnation, I was the Deputy Systems Program Director for GOES-R. So to see this mission finally launch is truly a treat for me. So NOAA and NASA has had a long collaboration developing and launching the geostationary meteorological satellites that dates back more than 40 years, as we have heard many times before. With GOES-1, that was launched on October 16, 1975. With this latest geostationary satellite, this is a quantum leap in science and technology, and it will truly revolutionize weather forecasting. Once operational, GOES-R will become GOES-16. NOAA GOES-R will provide 3 times more spectral bands. The current GOES has 5. The new GOES is going to have 16 bands. It's going to have 4 times better spatial resolution, and it will be 5 times faster, which means more frequent and detailed information for forecasters to consider in support to the public and the aviation community. That means the GOES-R will be able to image everything in the hemisphere in the same length of time it takes the current GOES series to provide one small image of one little stormy region. So increased imagery over the short time period will provide more timely and informative data to forecasters everywhere in the Western Hemisphere. GOES East and GOES West right now do not have the capability to take those full images every 5 minutes. The current GOES satellites scan the full hemisphere every 30 minutes, or the United States every 15 minutes, or a stormy region every 5 minutes, but not all at the same time. This change in imaging is a mission requirement for GOES-R that will enable simultaneous rapid regional coverage and continuous hemispheric weather monitoring. As a result, we can expect noticeable improvements in the quality, detail, and speed of forecasts, including the prediction of severe weather events, tropical storms, and hurricanes that pose danger. GOES-R will feature 6 brand new instruments: ABI, EXIS, SICE, GLM, SUVI, and the magnetometer. Briefly, I want to highlight the GOES-R Lightning Mapper. This instrument will be the first operational space-based detection system for total lightning activity over land and water. The basis for the GLM is the lightning imaging sensor that flew on the NASA JAXA TRIM mission from November 1997 through April 2015, providing first ever tropical lightning climatologies. We are very excited about the GLM because it will tell us more about lightning activity than we have ever known, which will improve forecast and decision making. Trends in total lightning that will be available with the GLM have the promise of providing critical information to forecasters, which will allow them to focus on developing severe storms much earlier than they can currently, and before these storms produce damaging winds, hail, or even tornadoes. NOAA's GOES-R will be a game changer for weather forecasts for our nation and throughout Latin America and the Caribbean. Each day, weather forecasters throughout Latin America use data from NOAA's geostationary satellites in similar ways as their U.S. counterparts. The key difference is that data from radars, soundings, and aircraft, which are incorporated into NOAA's forecast models, are sparse throughout Latin America. That's why NOAA's geostationary satellites and the upcoming advanced GOES-R satellite are so crucial in protecting lives and property throughout Latin America and the Caribbean. We are looking forward to working with our colleagues there to help bring about forecast improvements into the future. The GOES-R satellite will significantly improve the detection and observation of environmental phenomena that directly affects public safety, protection, and property, and our nation's economic health and property, and that of Latin America and the Caribbean. I'm going to repeat this last sentence in Spanish for our Latin American friends. El satélite geoestacionario GOES mejorará significativamente la detección y observación de fenómenos ambientales que afectan directamente la seguridad pública, la protección de la propiedad y la salud económica y prosperidad de nuestra nación, América Latina y el Caribe. Back to English. NOAA and NASA's collaboration goes beyond the meteorological satellites. NASA's Earth Science Division provides near real-time data and information products from our NASA's research satellites, which are used routinely by NOAA and other operational agencies. We support NOAA's operational capability by supplying data products ranging from atmospheric dynamics, atmospheric composition, sea surface wind speed and direction, wave conditions, aerosol data, and many other products that are fed into the numerical models to help the weather forecasters. In addition, together, NOAA and NASA developed and are operating SUMI MPP, a complementary LEO mission that both advances research and serves the operational NOAA community. We are very, very proud of our partnership with NOAA, and we are looking forward to many more years of collaboration. Thank you, Sean. Back to you.
Thank you, Sandra. And finally, we'll hear from Damon Penn from FEMA.
Thank you, Sean. Thanks for having us today. I don't think it'll come as any surprise when I tell you that weather forecasting is critical to decisions that emergency managers make, not just at FEMA, but at the state and local level. And our days all begin and end with the weather forecast. And not just the traditional forecast where during hurricane season we'll talk about what the cone of uncertainty looks like, and not just during tornado season when we'll talk about what kind of conditions are favorable for tornado formation. But wildland fires, as we mentioned in the southeast, flood inundation mapping and prediction and surge products, all of those things together all turn into decisions that emergency managers have to make. And the importance of having accurate forecast is because the accuracy turns into time for us. And one thing you can't get back during a response to an emergency is time. And once you get behind, you never catch up. And there are decisions that have to be made several days in advance. For instance, if you're talking about evacuating a major metropolitan area, you may have to make that decision 4 days out just to be able to get everything going and get people out of the area. If you're talking about moving in supplies and commodities, that takes several days. If you're talking about solar weather events, that may take several seconds or several minutes. So accuracy turns into time, and time can be important from minutes for us to hours, to days. But all are important and all really impact on decisions that we make. Because really once you make a disaster decision, it's made. Once you decide to evacuate, you can't unevacuate. Once you decide to put commodities on the ground and you put them on the ground in the path of the storm, you can't pick them back up. So our relationship with NOAA and the kinds of products that NOAA provides us are critical to what it is that we do. And the more accuracy and the more information that we can get, then the better we can serve the public and the better we can help manage disasters and take care of our survivors on the ground. So thank you.
Great. Thank you, Damon, and thank you once again to all of our panelists. Now, we're going to take your questions in just a moment, but before we do, we're going to go back to Stephen Goodman, who has a video to show us demonstrating some of the capabilities of GOES-R.
Right. So I've always told people that the imagery will speak for itself, and I don't need to narrate it, so let me give that a try. What you're looking at is a developing outbreak of severe storms. This is taken with the spare satellite that was mentioned earlier today, and what you see there, that line of clouds moving south, is called an outflow boundary, and you can see the differential motion of the clouds. Over on the right-hand side, you see clouds at low levels coming into the storm, and you see the storms developing as that line comes through. So when that outflow boundary hits these developing cumulus clouds to the south, it develops into another major storm system. And it's the animation is so quick, I guess it's hard to pick up on this video. So I did narrate it a bit, but this is what the spare satellite. So what you just saw would have been the rapid scan capability of GOES-R, but at low resolution, because the current satellites in orbit only have 1/4 the spatial resolution. So a lot of the detail we can see at cloud top and with the convergence to clouds will help the forecaster, especially if there's a severe storm outbreak. It can help them to determine if they need to extend their watch area beyond the current time, because they can see the new development that's happening. Thank you.
Great. Thank you. Thank you, Steve. Some exciting changes coming with GOES-R. Now we're ready to take your questions, and we have several reporters here in the audience with us. We'll take questions from them, as well as questions from folks calling in on the phone. And if you're joining us via social media, you can ask a question using the hashtag AskGoes, and we'll get to those in just a few minutes. But we'll start with a question here in the room, and we've got one right here in the front row. Could you please identify yourself?
Sure. Ken Kramer, Universe Today and the Northeast Astronomy Forum. My question is specifically about the lightning mapper, this first lightning mapper. Can you talk a little bit more in detail How will you use this lightning data to warn about severe weather? How will you use it to warn about tornadoes and get that data, because the latency period is critical, to get that data to FEMA so they can issue tornado warnings? How will that all work?
Let me start on that one. Since I started with that instrument in 1979, we worked on it a very long time when we started development at NASA, and then it became the new instrument for GOES-R. So the idea behind the instrument is that when you have rapidly developing storms, it can give us an indirect indication of the strength of the storm updraft. And the storm updraft does all the work. And we don't have any instrument, even the radars, that directly tell us how the updrafts are intensifying. We can see the precipitation cores as they ascend. And what happens is you take the raindrops and lift them up higher in the cloud, they freeze and they form ice. And it's the collision of ice particles in a rich region of liquid water or water vapor that enhances the electrification process. So the stronger the updraft, the more collision of particles and the faster the rate of electrification, and then that's released by the lightning. And so we connect the lightning to the rapid development and intensity of the storm updraft. And if you have a rotating thunderstorm, say an incipient tornado, they take wind shear from the environment. And taking that wind shear then, and the updraft turns that rotation, we call it vorticity, up into the upper parts of the cloud, you're connecting both what's happening aloft in the cloud and what's happening down below. And that's where the lightning is giving us this additional lead time, because we see these surges, we call lightning jump, and we're able to relate that then to the intensifying storm. So imagine a sea of storms out there, you're a forecaster, you got 20 storms that you're focused on, and when you see one of these storms with a rapid increase in the lightning, you see the radar echo, as Joe was saying, intensify, and then we're looking down with the imager and we're seeing cloud tops growing. You connect all that together and it really helps the forecaster, what we call the situational awareness. And so from that, they're able to discern that, I need to pay more attention to that storm or that storm, and then they have the diagnostic information that's going to help them get a warning out earlier.
Did anyone else want to add on to that?
So I would just add a small piece, is that it's a complementary observing network, and it basically will give us advance notice to where do we focus looking at the radars? Where do we focus so that we can provide that additional time? And the lightning was one of those early contributors. I think we're going to learn a lot because it'll be the first one we have in orbit. So I don't think we know everything how we're going to use it yet as well.
Great, thank you. Okay, we got a question over here.
Dan Satterfield, WBOC in Salisbury. Steve, you and I have been down to the new GOES-R dishes. GOES-R is downlinked at Wallops Island, which is my viewing area. So two-part question. One, are the dishes now ready to go? And two, how long after launch will the data be acquired at Wallops Island and start coming down there?
Okay, well, I'll take a shot at it. It might have been a better question for the earlier panel, but my understanding is that they are ready to go. And our game plan is that once we launch the satellite, we have to do outgassing after we reach orbit, about 15 days to reach orbit, 30 days to get all the contaminants away from the satellite instruments. And then we turn it on, and then we'll start providing data to our calibration validation teams. And we'll continue doing that for about 6 months. And then NASA will hand over the satellite to NOAA, and then NOAA will continue another 6 months of validation. When we reach the validation point on the products that we determine they're fit for use by the forecasters, we'll turn on the GOES rebroadcast system, which is the downlink, and then the forecasters will have the data, and they know that we're still tweaking things and trying to get it all optimized. And so they'll take things with a grain of salt, but then by the end of a year on orbit, then we'll have validated our products and they'll be ready for everybody to use.
Great, thank you. Let's see, we have any more questions here in the audience? Second row here by the aisle.
Hi, I'm Kelly Cologna with Northwestern University, Medill. And I was wondering if you could tell us a little bit about how the satellite can or will be used in climate change research or studying climate change.
Make a couple comments in there. So one thing the satellite has that we haven't had before is has an on-orbit solar calibrator for the instrument, for the imagery. We've not had that. The low Earth orbiting NASA research satellites have such a capability, and we basically have now replicated that for geostationary orbit. So one, the data will in fact be more accurate. People have always said the weather data doesn't need to be as accurate as climate data, but the new data from GOES-R will actually be more accurate than we've had before. One of the things that GOES-R contributes is unraveling the diurnal cycle. What I mean by the diurnal cycle is we have generally the global observations are in low Earth orbit, and so you get a snapshot every maybe 12 hours. If you're lucky, maybe every 4 hours if you've got a constellation with many satellites. And yet it's still difficult to determine, say we're trying to diagnose cloud properties, and we know how do cloud properties change over decades, or how do they change even interannually. Say we have an El Nino event or an La Nina event, and we actually are going to have a La Nina event most likely this coming winter going into February. And so what the satellite would tell us is, what are we missing when we're trying to characterize the clouds by having sampling throughout the day? That's what I mean by the diurnal cycle. Instead of coming over at 1 o'clock every afternoon, the clouds aren't the same at 1 o'clock in the afternoon. Sometimes they're still developing, they're not mature. So it'll help us with that. The other way I would say is extreme weather. So right now, we don't know what the variation of extreme weather is, but we know from, as Sandra mentioned, we had a lightning mapper in low Earth orbit on the NASA Tropical Rainfall Measuring Mission for 17 years, and now we're going to have 20 years more extending that climate data set. So once you have 30 years, generally people say, I got a climate data set, and we can look for those variations. So I think GOES-R and the rest of the geostationary satellites that Europe is launching, Japan, you heard, has launched, China will launch, and so we're going to have a global constellation of geostationary satellites that have nominally the same capability as GOES-R. And so I think it'll contribute both in how do storms and clouds and the environment vary over the course of a day, and then also extreme storms, severe storms, how do they vary, say, over decades?
Great. Thank you. Over here in the second row.
I had a question about accessing the imagery afterwards. So even right now with, say, 1 minute imagery, satellite imagery, for example, it can be difficult to find. And, for a TV meteorologist, we have access to our data service providers and the data that they and images they provide us. But for the general public who are more savvy about just going to the web and looking for the data, will there be a way to get at this really cool, 30-second high spatial resolution satellite imagery?
I'm sorry, and could you just identify yourself, please?
Oh, yes. I'm sorry. Jen Carfagna from the Weather Channel.
Thank you.
So if I can start on that one. So we have a satellite analysis branch in NESDIS, in the satellite service, and they have a web page, and they're going to update their web page that we currently have to show the native temporal resolution of the data. So when we take 1 minute imagery or 30-second imagery with the imager, and we have the 20-second latency from the lightning mapper, they will have web pages that anyone will be able to access to see that. And also I should mention, we've been working with the broadcast meteorology providers and showing them the value of this data and say, don't let this rapid scan information drop on the floor. I don't know if I can mention who the providers are, but one of them was at a conference with me, and he pulled out his cell phone and he says, here's the Japanese rapid scan imagery. Isn't this amazing? And I said, you bet it's amazing. So they're attuned to that, and I've been talking with Dan here for years too, and he's helped advocate that they need to update their delivery system so that you, the users in the broadcast industry, can take full advantage of what GOES-R can offer. And I should say, we've been doing a demonstration at NOAA's Hazardous Weather Testbed to get some of the broadcasters attuned to what we might be able to offer. And one of the reasons we did that was because even though Joe and the Weather Service are putting out the weather information to the viewer and the TV stations, it's really that last mile that's going to have the big impact for warning the public. And this loop that I showed you, if we can show that kind of loop on the air, I think the viewer can personalize that the risk is real and the storm is coming at them, and they'll maybe be more likely to take action. And that's what we need, is people to take action to be safe.
Great. Next question. In the back row on the side.
Hi, Mike Augustinek with CBS in Minneapolis. I'm sorry if I missed you already answering this question. We know the new temporal resolution of the lightning mapper. What's the spatial resolution?
The spatial resolution for the visible channel is 500 meters, third of a mile or so. It's 4 times better. And then for GLM, it's 8 kilometers spatial resolution. And there's an interesting innovation in the design of the detector that allows us to keep that spatial resolution across the oceans. And so had we not done that, we would have had spatial resolution, say, of 30 kilometers, which is larger than an individual storm, and that's what we would present to aviation industry and the FAA. But because we're able to pull in the resolution as the instrument is looking further out from directly beneath it, we'll be able to have storm scale spatial resolution pretty much all the way across the field of view. And the field of view for GLM will, from both satellites combined, will be from the west coast of Africa up to Edmonton, Canada. It's about 54 degrees latitude. Same down to the South American in Chile, and then all the way over to the east coast of New Zealand. And so while the imager gives us a larger field of view, the GLM will cover most of that airspace. And we know from talking to Joe's director at the Aviation Weather Center that they're very excited because they don't have radar over the ocean. The aircraft radars are small and they don't see over the horizon, and now you can take the imager and the lightning mapper, combine it together, and effectively provide radar-like information out over the oceans where the hazardous storms would be.
Joe, do you have anything you want to add to that?
No, I think Steve covered that very well.
Great. Okay, our next caller is, we've got a question on the phone from Mark Gotch. Go ahead, Mark.
Yes, good afternoon. Thank you for this very informative science briefing this afternoon. Mark Gotch, Historical Aerospace News. Please, can you explain how the advanced baseline imager technology was developed and how will it be used going forward? And also, one other question, how will solar flares be seen differently and what will this mean to the future of forecasting? Thank you.
Thank you. Who wants to tackle that one?
Well, I'm not sure I could remember all the pieces. If I start at the beginning, Harris Corporation has developed the imagers that we've been flying on our satellites for the current series, the previous series, and back in around 2004, we did some feasibility studies with a number of vendors on the different possible architectures for the different instruments. And so we settled on the Harris design, which was able to give us 16 spectral bands. Initially, we were hoping to get even more spectral bands, but it's expensive and challenging. So we settled on 16 spectral bands, and the scientists had done studies as to what each individual spectral band might offer. For example, we have a spectral band at 1.39 microns, which allows us to see cirrus clouds, and so that was something we weren't able to see before. We have 3 water vapor bands, and so for you who watch the water vapor image on TV, that's the upper level water vapor, but now we can see deeper into the atmosphere, and that'll let us see where the atmosphere is destabilizing more. And I should mention, let me use that as a segue into tropical storms. So from the Himawari Japanese satellite, which is also purchased from Harris, the same instrument technology. The only difference really is that we're operating the satellite, taking 1 minute images, and they take them 2.5 minutes apart. But we have some data from a typhoon called Sodalor that hit Taiwan, and I asked our scientists who work with the wind, we call them atmospheric motion vectors. You can use the cloud and water vapor as wind tracers. So anyway, they took that and these water vapor channels. I said, so I know that we can see things, but what's the real impact? Is there impact on the model? So they did a process we call data assimilation, and they bring these data into a best analysis. And to my surprise, even when they did the forecast track for this typhoon, they actually reduced the forecast track error. Where I expected improvement was in the intensity. And the intensity in that case was indeterminate. So we've only done a couple of cases, and you have to give us time to collect enough samples with the actual GOES-R satellite to know what the true impact is. And if you just give me another second, let me comment on Matthew. So I figured someone would ask about Matthew, right? And so I talked to the National Hurricane Center, the folks we work with very closely, And I said, what would have been the possible impact of having GOES-R on orbit? And it turns out that where the forecast models and the forecasters missed it was down in the Caribbean when they were expecting the storm to not intensify so quickly. And it turns out that for all the information that GOES-R provides, for example, we mentioned the lightning mapper. They've been doing some work looking at how the lightning's related to rapid intensification of tropical storms and hurricanes. And it turns out that from ground-based networks that we have today, they didn't see the lightning signatures that would have told them that they would have had the strong shear. So that's the key thing. Hurricanes don't like shear, it tears them apart. And so they didn't see that signal. So I think GOES-R, because we're able to map the motions of the clouds and also to be able to map the lightning, I think both will contribute to picking up signals like that you might be missing. So that's what they say, the Hurricane Center forecasters, is a potential benefit we would have had we had GOES-R. Maybe, Joe, you have something to add on that?
I would just add, that we are very excited and we are preparing to use those atmospheric motion vectors, those derived motion winds from the imager. So we're very excited about what the possibility is for how that can improve our regional modeling. Another way we're trying to use the spectral analysis, Steve gave some examples of that, but if you're looking at fires in the southeast, we're going to be able to look at it very closely and even see, based on the spectral bands, what's burning, what is it doing, which way is it going, and so that can really inform some of the efforts that's being provided for fighting those fires. So those are, some of the new ways we'll be able to use the capabilities on GOES-R.
I just wanted to go back to the original question on how the technology came about, and it was really way early, around 2000s, and we issued completed formulation contracts working with various companies to develop, mature the approaches that we ultimately chose in 2004 to develop the ABI instrument. And as Steve pointed out, we have a long history working with Harris, developing the GOES-I through M imager and sounder, which also flew on NOP. And ultimately, Harris was also picked to develop the ABI for the GOES-R.
I know the question also asked about imaging the sun.
Right.
But before I answer that, let me make one comment so I don't forget about the numerical weather prediction forecast models. Where we're seeing the impact with these motion vectors, it's largely attributable to the higher spatial resolution. So when we calculate how the clouds are moving and the water vapor is moving and we get a wind vector from that, that depends on how well we did the clouds. And it turns out because we have 4 times the spatial resolution to get the clouds, we can more accurately assign the height of that motion vector. So if we have the right vector of the wind, but we put it at the wrong altitude, that's going to mess up the models. So the more accurate we can do that, and we've actually determined from our GOES-R algorithm, our recipe that we're using, that we can reduce the speed bias by 1 meter per second based on experiments with the Himawari, which is a huge benefit to the global models. So the question earlier about how the mid-latitude's going to benefit from GOES-R, it's the fact that we're able to put these motion vectors into the numerical models, and that's going to have the biggest impact, say, on the extratropics by making those model forecasts more accurate. On the sun, so I don't forget SUVI and the sun I mentioned earlier, so we'll have 4 times the spatial resolution. You'll have crisp imagery to better see, for example, solar flares. If we have a solar flare, we'll be able to determine more accurately its extent, so where its source is and where it's extended to. And we're also going to be able to diagnose that more rapidly because we have the higher resolution. And actually, SUVI is a bit faster than the current satellite as well. So everything's faster, everything's got more resolution, and it's going to be amazing.
Great. Thank you very much. We have, I believe, one question on social media. So John Yembrick from our social media team, please tell us that question.
Thanks, Sean. This question is, once in orbit, what potential hazards or fail points are there where it maybe prohibit you from getting accurate data? Or are there any?
Well, I can speak mostly to the lightning mapper. It's got a charge coupled device detector, And so high energy particles can penetrate the spacecraft skin and they can get to the instrument. And so in that case, we could lose pixels if we had high energy that would impact the detectors. So right now, the mission that Sandra mentioned that had been on orbit for 17 years, we never lost any pixels over that time. It's a solid state device. So if something like that could happen and it degraded over time, then maybe we would lose a piece of our field of view if that were to happen. In the case of the SUVI instrument, it's got an ultraviolet filter. Ultraviolet filters are very touchy and very difficult to manufacture. In fact, I believe we're replacing the UV filters right before we launch. Maybe we've done that already. They don't like water. Water is an enemy of ultraviolet filters. So if something were to happen in contamination, then that could affect the full field of view that we would get from the instruments. And of course, hopefully there's be no issues with the telecommunication aspects of the satellite, because we got to get the data down to Earth to use it.
And more basic than that, with the launch, there is dangers. Deployment of appendages, there is danger, and we have to still achieve geostationary orbit. It's going to take 9 days to get there, so the thrusters have to be able to get us ultimately to where we want to go. So, that's why we test and test and test until, we know that things are going to work. Mm-hmm.
Okay, other questions here in the room? We've got one right here near the back.
So, Matt Safino, KGW TV. Back to the GLM. If I heard correctly, the technology of the Lightning technology on trim was based on 1997 technology. So, is the new GLM instrument similar to that, or have we advanced beyond that, and how much?
The biggest advancement over what we had with the Lightning imaging sensor, it had 128 by 128 pixel array. Now we're talking 1360 by 1320, so we got a much bigger array that we're detecting near the full disk of the Earth. And the thing that's going to really change things is we had a transponder bandwidth for that mission of 8 kilobits per second. And what would happen is when we would fly over a very intense storm or over the South Atlantic anomaly, which is a high radiation area off of the South American East Coast, we would saturate the instrument, and so we couldn't take any data. So now on GOES-R, thanks to all the developers, we have 7.7 megabits per second. What does that mean? That's a huge difference. That means that we can lower our detection threshold and see more of the lightning, even the weaker lightning, than we could before. We're predicting a greater than 80% detection probability of all types of lightning, even if it goes to ground, because a ground strike has channels up into the cloud, and the light that's emitted makes its way to cloud top, and we see it. And so we have a number of filtering algorithms. We have 8 right now that take the raw data that's sent to the ground from GLM and remove things like glint that you get from the sun reflecting off the ocean surface. We also have radiation effects, as I mentioned earlier. And so actually, after all that filtering's done, we really see the lightning very well. That's a huge advantage over what we had with the original instrument. We still operate at the same wavelength in the near infrared, because that's where we get about 10% of the total energy from lightning. So there's no reason to change that. So it's the bandwidth is really the big innovation since the earlier instrument.
Great. I think we have time for 1 or 2 more questions. The audience, do we have any more? If not, in the back we have one more. Okay.
Hi, Nick Stewart, KHQA, Quincy, Illinois. Question for FEMA. We talk obviously very well about how this is going to, predict disasters, how you might be able to prepare for that. How about post-disaster? How are you looking to use this technology to kind of look at recovery efforts?
Yeah, that's a great question, because people tend to think that disasters end once response ends, and it really does not. Recovery goes on for several years. But immediately following a response, as you know, you have quite a vulnerable population. You've got people that have been displaced. You've got people that have damaged homes. You have limited transportability because you have debris in the roads. You have all those kinds of things. So having accurate weather forecasting then is as important as it is prior to the event, because that will determine how we can actually get commodities moved and distributed throughout, how we can actually evacuate the our vulnerable populations, how we can get people back into the areas that they came from, all of those things. So we pay as much attention post-event as we do pre-event. So again, the better forecast, the better decisions we can make and more timely our decisions.
Great. Thank you, Damon. And thank you once again to all of our panelists. That's all the time we have today for this briefing. But I want to remind you that you can find out much more about the GOES-R mission by going to the website that you'll see on your screen. And you can also follow us online and on social media in the days leading up to launch this Saturday. And be sure to tune back for more NASA TV activities then. Thank you for joining us.
Hey, you're watching NASA TV, on the air and online every day, on this planet and beyond.
Vers la gauche. Super, merci. Parfait.
Дорогие друзья, Божий благословен вам на ваше
Dear
служение.
friends, may
Хочу
God
пожелать,
bless
чтобы
you on your
Богородица
journey.
покрывала вас своим амофором, и ангел-хранитель помогал вам в всех ваших
May He help you in all of your efforts and all of your work.
Бога.
May God bless you. May God bless you.
Так, налево, Олег. Молодцы.
Выставили, Саня зашел, увидел и сразу.
Сказать, что широкий, ну нормально было. Поменяли. Что такое? Что такое? Потом, да? So are we on mic as well? Can you hear us? You can hear us? C'est une affaire
How's it feel? You look good. You look damn good. You look good. You look except for when you're full of hair.
Take care of us. I've had
You'll be our eyes and our ears, and you'll be experiencing everybody else wants to hear. So hopefully you'll have just an incredible time.
Thank you, Shirley, and we'll do our best. I know we're going to do great here, and we're going to work really hard and just show for the top.
I know you're stoked and ready to go. I guess you must be the first person from Normandy to go into space. So that makes you the first Norman to conquer space. Thank you.
Are you all ready? Ready to go? Okay, may everything go as planned.
чуть-чуть.
1, 2, 3, 4. Come forward, turn around.
Order sequence initiated. Oxygen. Sedative umbilical tower separates. Engine turbo pumps at flight speed. Engine at maximum thrust. Fuel tower separation. Confirmed. All 10 seconds, everything's nominal, and the thrusters are working nominally. Copy. And we can hear you 5 by 5. Copy.
NASA Administrator Charles Bolden. Charlie, a thunderous start to this flight for Whitson, Pesquet, and Novitsky. Your thoughts on all of this that has come about over the past few weeks, 2 launches and a landing, and the whole theme of international cooperation at this point?
I think this was a perfect evening. When we talk about the journey to Mars and the way we're bringing nations of the world together, this is the epitome of that. As you have said, it shows how we, through cooperation, international cooperation, we're able to do things that sometimes people might think is next to impossible to get done. So it's a great night. A great victory for the International Space Station in getting 3 more crew members up there, and they're ready to go. They're pumped.
This docking of this crew will occur on the 18th anniversary of the first Element launch of the station. How far has this complex come from fledgling modules to where it is today?
Well, I think if you look back, and you and I were there, so you were in the media at the time, but you will remember people said this couldn't be done, that it was too EVA intensive, it was just too much work. And over the 10 years that it took us to complete station, I think it says what again, an international team that's set on a mission can do when they focus on that mission, and when they get the kind of support that we've gotten through the years. This is the 16th year now for people living and working off this planet. No matter what's going on down here, the crews and the flight control teams manage to focus on their tasks and get everything done, and we live in a totally different world when we're on the International Space Station.
Kirk Shireman, ISS Program Manager. Kirk, quite a start to the expansion of the station crew, back to 6 people. Your thoughts on the significance of this launch and what has been accomplished in support of station operations over the past 4 weeks?
First of all, it's a beautiful launch tonight, very, very clear skies. We could see the vehicle all the way through into the 3rd stage. It's one of the best I've ever seen, so very exciting. We're looking forward to having Peggy, Thomas, and Oleg back up on the space station. Lots of work to be done. We'll be undocking a Cygnus here just in a few days, and then a Progress will launch from the same Cosmodrome here on December 1st. So lots of work to be done. And the amazing thing is all the work that's been done just in the past few days. We've had a landing, we've had Shane and his crew went up to ISS. So a tremendous number of vehicles coming and going to the ISS, and lots of work for this crew to do.
How about the significance of the pace of the work and what is being accomplished up on station during this busy time?
What's amazing to me is that in the midst of all these vehicles coming and going, doing some major repairs on the space station. We just had an oxygen system that was recovered by Shane on orbit. We're still doing a tremendous amount of research. This last crew averaged over 45 hours a week of research, and this crew has over 304 investigations to do, 89 of which have never been done on space station. So in the midst of vehicles coming and going, a tremendous amount of research still going on.
This is the 6th astronaut of the class of 2009 now in space. What does it mean for you as a ESA Director for Human Spaceflight?
Well, the first thing is we've just witnessed an amazing night launch taking Thomas Pesquet up towards the International Space Station. We'll dock very shortly. But it's really important because it's the end of the first set of flights for this set of 6 astronauts, but the beginning of the next period of science and technology aboard the space station that will really bring knowledge and skills back to planet Earth, but also prepare us for going back into deep space, taking us on a journey towards the planets. And that combination of science and technology is what's so exciting about human spaceflight.
With Thomas now in space and Paolo Nespoli, also of ESA, going to space in 6 months, that's the beginning of 1 year of presence of ESA on board the International Space Station. What does it mean for ESA and its ambitious exploration program?
It's really important to develop all the skills and knowledge to prepare us for our long-term vision of space exploration. We're going to stay in low Earth orbit doing science and technology, but the preparation that we need to go further out. So it's the skills we'll gain, it's the experience, and also the excitement I think we'll bring back to Europe.
À la gauche. Oui.
Ça marche?
Bien, merci. Parfait.
Today is the
Дорогие друзья, Божий благословен вам на ваше
Dear
труды.
friends, may
Хочу
God
пожелать, чтобы
bless
Христос,
you on your
говорится,
journey.
покрывал вас своим амофором, и ангел-хранитель помогал вам в всех ваших
May He help you in all of your efforts and all of your work.
Богом.
May God bless you. May God bless you.
Так, налево, Олег. Молодцы.
Там выставили, Саня зашел, увидел и сразу это.
Сказать, что широкий, ну нормально было. Понятно.
Что такое? Что такое? Подольше, да?
So are we on as well? Can you hear us?
You can hear us?
C'est tout à fait
How's it feel? You look good. You look damn good. You look good. You look except for when you're full of
Take care of us. I've had
Make yourself kind of a place that we'd like for everybody to be able to do it. you'll be our eyes and our ears and you'll be everyone else wants to hear. So hopefully you'll have just an incredible time.
Thank you, Sally, and we'll do our best. I know that we're going to be great here, and we're going to work really hard and just show folks how to do it.
I know you're stoked and ready to go. I guess you must be the first person from Normandy to go into space. So that makes you the first Norman to conquer space. Thank you.
Are you all ready? Ready to go? Okay, may everything go as planned.
чуть-чуть.
1, 2, 3, 4. Come forward, turn around.
Initiated. Oxygen. Center umbilical tower separates. Engine turbopumps at flight speed. Engine at maximum thrust. Fuel in tower separation. Confirmed. Everything's nominal, and the thrusters are working nominally. Copy, and we can hear you 5 by 5. Copy.
NASA Administrator Charles Bolden. Charlie, a thunderous start to this flight for Whitson, Pesquet, and Novitsky. Your thoughts on all of this that has come about over the past few weeks, 2 launches and a landing, and the whole theme of international cooperation at this point?
I think this was a perfect evening. When we talk about the journey to Mars and the way we're bringing nations of the world together, this is the epitome of that. As you have said, it shows how we, through cooperation, international cooperation, we're able to do things that sometimes people might think is next to impossible to get done. So it's a great night, a great victory for the International Space Station in getting 3 more crew members up there, and they're ready to go. They're pumped.
This docking of this crew will occur on the 18th anniversary of the first Element launch of the station. How far has this complex come from fledgling modules to where it is today?
Well, I think if you look back, and you and I were there, so you were in the media at the time, but you will remember people said this couldn't be done, that it was too EVA intensive, it was just too much work. And over the 10 years that it took us to complete station, I think it says what again, an international team that's set on a mission can do when they focus on that mission and when they get the kind of support that we've gotten through the years. This is the 16th year now for people living and working off this planet. No matter what's going on down here, the crews and the flight control teams manage to focus on their task and get everything done, and we live in a totally different world when we're on the International Space Station.
Kirk Shireman, ISS Program Manager. Kirk, quite a start to the expansion of the station crew back to 6 people. Your thoughts on the significance of this launch and what has been accomplished in support of station operations over the past 4 weeks?
First of all, it's a beautiful launch tonight, very, very clear skies. We could see the vehicle all the way through into the 3rd stage. It's one of the best I've ever seen. So very exciting. We're looking forward to having Peggy, Thomas, and Oleg back up on the space station. Lots of work to be done. We'll be undocking a Cygnus here just in a few days, and then a Progress will launch from the same Cosmodrome here on December 1st. So lots of work to be done. And the amazing thing is all the work that's been done just in the past few days. We've had a landing. We've had Shane and his crew went up to ISS. So a tremendous number of vehicles coming and going to the ISS, and lots of work for this crew to do.
How about the significance of the pace of the work and what is being accomplished up on station during this busy time?
What's amazing to me is that in the midst of all these vehicles coming and going, doing some major repairs on the space station. We just had an oxygen system that was recovered by Shane on orbit. We're still doing a tremendous amount of research. This last crew averaged over 45 hours a week of research, and this crew has over 304 investigations to do, 89 of which have never been done on space station. So in the midst of vehicles coming and going, a tremendous amount of research still going on.
This is the 6th astronaut of the class of 2009 now in space. What does it mean for you as a ESA Director for Human Spaceflight?
Well, the first thing is we've just witnessed an amazing night launch taking Thomas Pesquet up towards the International Space Station. We'll dock very shortly. But it's really important because it's the end of the first set of flights for this set of 6 astronauts, but the beginning of the next period of science and technology aboard the space station that will really bring knowledge and skills back to planet Earth, but also prepare us for going back into deep space, taking us on a journey towards the planets. And that combination of science and technology is what's so exciting about human spaceflight.
With Thomas now in space and Paolo Nespoli, also of ESA, going to space in 6 months, that's the beginning of 1 year of presence of ESA on board the International Space Station. What does it mean for ESA and its ambitious exploration program?
It's really important to develop all the skills and knowledge to prepare us for our long-term vision of space exploration. We're going to stay in low Earth orbit doing science and technology, but the preparation that we need to go further out. So it's the skills we'll gain, it's the experience, and also the excitement I think we'll bring back to Europe.
Vers la gauche. Super, merci. Top.
Today is the
Дорогие друзья, Божье благословение вам на ваше служение. Хочу сказать, что Христос Богородица покрывал вас своим амофором, и ангел-хранитель помогал вам в всех ваших...
May He help you in all of your efforts and all of your work. May God bless you. May God bless you.
Так, налево, Олег. Молодцы.
Выставили, Саня зашел, увидел и сразу.
Сказать, что широкий, ну нормально было. Понятно.
Что такое? Подольше, да?
So are we hot mic as well? Can you hear us?
You can hear us?
C'est toute la famille.
How's it feel? You look good. You look dancy. You look good. Except for when you're full of beer.
Take care of myself.
You'll be our eyes and our ears, and you'll be everyone else wants to hear. So hopefully you'll have just an incredible time.
Thank you, Charlie, and we'll do our best. I know that we're great here and we're going to work really hard and just show folks how
I know you're stoked and ready to go. I guess you must be the first person from Normandy to go into space. So that makes you the first Norman to conquer space. Thank you.
Are you all ready? Ready to go? Okay, may everything go as planned. Миш, чуть-чуть. 1, 2, 3, 4. Come forward, turn around.
On my mark, the time will be T-minus 2 hours and counting. 3, 2, 1, mark.
Pressurize Centaur LO2 storage tank to chill down level.
Roger.
Start Atlas LO2 ground chill down.
Roger.
Start Centaur bottle pressurization to flight level.
Roger.
Start Atlas AHB pressurization to flight level.
Roger.
Pressurize Atlas RP1 tank to step 2.
Roger.
Adjust CISA temperature to 110 degrees Fahrenheit.
Roger. T-minus 1 hour, 59 minutes.
Initiate CEC safing purge.
Roger.
Start CEP to high flow.
Roger.
Start CFA purge in displacement mode.
Roger.
Perform vulnerable data transfer to backup CCLS.
Roger.
Configure Davis system cameras for launch.
Roger.
Of this crew will occur on the 18th.
T-minus 1 hour, 55 minutes.
Centaur LO2 storage tank, it's chill down level.
Roger. Start Centaur LO2 transfer line chill down.
Roger.
LCRC, Net 1.
Go ahead.
Yes, sir. Command transmitters are secured for FTS cycle test.
Roger. FTS, perform FTS cycle test.
Roger.
And RC, verify solar radiation monitoring is active with LWO.
Roger.
This is the LC on channel 1 with a comm check. SMD.
This is SMD, I hear you 5 by. This is SMD, I hear you 5 by.
And I have you loud and clear also. CTC.
CTC reads you loud and clear.
And I have you loud and clear. NLM.
LC, NLM. How do I read?
I have you loud and clear. NASA CE.
You are loud and clear.
I have you loud and clear. NSC.
Loud and clear.
And I have you loud and clear. Comm checks out.
LCRC, Net 1.
Go ahead.
Yeah, the range has reported no safety cola closures for this operation throughout the window.
Roger.
T-minus 1 hour, 50 minutes.
CFA purge and displacement mode.
Roger.
LCECS.
Go ahead.
For Op 50, Step 290. ECS has been on GN2 a minimum of 30 minutes.
Roger.
Centaur LO2 transfer line shield down is complete.
Roger. PNE2, LC.
This is PNE2.
Roger. Can you provide your verifications in Step 290?
Roger. CEC safety purge is active.
Roger.
DEP on high flow.
Roger.
Centaur lock tank pressure is less than or equal to 13.15 psig.
Roger. LOX 2, start Centaur LO2 tanking.
Roger.
PNE2, perform Centaur LH2 SVV cycle test.
Roger.
T-minus 1 hour, 45 minutes.
LC, FTS.
Go ahead.
Step 17 launch.
Roger.
Also, we can add step 310. The FTS cycle test is complete and the receivers are secured.
Roger.
T-minus 1 hour, 43 minutes.
Step 370, Centaur LH2 SVV cycle test is complete.
Roger.
LC, ECS.
Go ahead.
Are up 50, step 360. ECS has been on GN2 for a minimum of 30 minutes.
Roger.
And let me go ahead and give you the step 370. Payload and CEM, ECS have been on GN2 for a minimum of 40 minutes.
Roger.
Centaur LO2 at 10%.
Roger.
T-minus 1 hour, 40 minutes.
Com check channel 1.
Loud and clear.
Centaur LO2 at 20%.
Roger.
Centaur LO2 at 30%.
Roger.
SYS on 1.
Go ahead.
Step 450. L2 balloon cycle task is complete.
Roger.
Centaur LO2 at 40%.
Roger.
T-minus 1 hour, 33 minutes.
Pressurized Centaur LH2 storage tank to chill down level.
Roger.
Step 370, CFA purge has been in displacement mode for over 25 minutes.
Roger.
Goes R, S, T, and U. Why letters? Why not numbers? What's the motivation behind the alpha system?
That's a good question. I don't know that history. It's alpha in development, and then it goes numeric on orbit. And that has been, somebody a long time ago decided that's the way it needed to be.
Okay, so well, yeah, it seems like maybe I need more of an education in that arena as well. In that arena as well. From your perspective, awesome. Now, where are you going forward? From your perspective, you and your team, obviously, you said Lockheed's still already doing the development. But in terms of still already doing the development. But in terms of the same team moving forward to assemble this, the same team moving forward to assemble this, will you be working on that as well?
The same team for ST&U and the same team for ST&U. A lot of the real hard work is just beginning. A lot of the real hard work is just beginning. It is a system of systems. With this system, it's not just a system of systems. There's a huge ground satellite. There's a infrastructure ground built and prepared. Infrastructure that was many years and preparing the users out there. Many years to preparing the users out there this data to accept.
Now you mentioned users. That would be forecasters and things. That would be forecasters and things like that.
You know, we have not only forecasters, but you know, we have these are we calibrated them to the same quality. We calibrated them to NASA calibrates all of its scientific instruments, and that data all of its scientific is going to be available to universities and anybody. Is going to be available to universities and anybody. Free data. Can be freely distributed. It's free data. They're going to be able to use that data. They're going to be able to use that data for new discoveries. Just giant. So you're going to see over the next just 10, 20 years from the GOES-R system. 10, 20 years.
That's awesome. It's free data, folks. So don't miss out.
That's right.
It's free data, folks. Thanks so much for being on the show.
That's right. My pleasure.
Thanks so much for being on the show. Earlier, Franklin had an opportunity to talk to satellite operations director at NOAA, satellite operations director at NOAA. Let's check it out. About the benefits of GOES-R. Let's check it out.
You are the director of the NOAA. You are the satellite operations NOAA.
That's right.
Satellite operations facility.
That's right. So I lead a very large team that is responsible for operating all of the nation's responsible for operating all of the nation's. So we operate in environmental NOAA has built and operated. So we operate satellites that NOAA has built and operated. We operate satellites the Department of Defense, the GOES satellites, the POE satellites, all the GOES satellites, 16 in total right now. And we collaborate with international partners in helping to operate with international partners and helping to operate their satellites and environmental data. Collect meteorological and environmental data.
Now, when I drove up this building, very interesting looking building. It's very modern. Very interesting looking building. It's very modern.
So this building was designed in early 2000s. Actually opened in early 2000s. It was very unique because for the first time we got to take a clean sheet of paper and say, if we're building a facility just to operate, if we're building a facility just to operate data processing for the satellites, how would you design data processing. And so we designed it from ground up to be a good building. And so we designed it from ground up to be a good building for doing this function. So where we're in here is our operations facility floor. So all of our data goes on here in this big room. Operations. And then behind us we have our launch control room. So we built this building. And then behind us we have our launch control room. So we built this building. We can start getting ready to launch 2 satellites at the same time. We can start getting ready to launch 2 satellites. We would be launching a GOES-R satellite and a JPSS satellite. Pretty much satellite and a JPSS satellite. It takes about 2 years for the launch team to practice. It takes about 2 years for the launch team to practice and go through all their simulations. We created 2 launch control rooms next door. We created 2 launch control rooms downstairs where everybody's has their office. Floor downstairs where everybody's has their day-to-day work and their desks do their day-to-day work. So design a building just for the purposes. Good opportunity to design a building just for the purposes for which we needed.
Facility. So in this operation have facility. Search and rescue. You also have
okay. So we have what's called SARSAT.
Tell me about that.
Which is search and rescue satellite aided tracking. Which is search and rescue satellite aided tracking. So and not only basically all of our international partners and not only ours carry instrumentation on board as well. To carry instrumentation on board that can mariners, beacons, boaters, hikers, mariners, pilots, boaters. They carry these beacons with aircraft pilots. If they get in trouble, they carry these beacons. They can turn the beacon on. If they get in trouble, signal out. They can turn the beacon on. It sends that signal out. Picked up by our satellites, and it gets sent back to picked up by our mission control center back to here. And then we basically detect that signal. We have a database of all those beacons that you buy. We have a database of all those beacons that you buy. You go down to your local REI store, your local store, and you buy a REI store, your local store, and you buy a beacon. And you register with us. You register with our database. And you register with us. Your address, your phone number. And then if you get in trouble on a hike, if you fall down and then if you get in trouble on a hike, if you need help, you just push a button. Something happens. Next time a satellite comes over, we find the signal. Next time a satellite comes over, we find 2 satellites to triangulate where you are. 2 satellites to triangulate where you are, and we find out where you are. And then we will then verify that the signal is real. And then we will then verify that the signal is real. That beacon is registered. Then we contact the local rescue authority, whoever that is. So if you're offshore in a boat, sailboat, we're going to call it. So if you're offshore in a boat, sailboat, we're going to call it. It has a beacon that if your aircraft crash. It has a beacon that the aircraft is responsible for aircraft kind of incidents. Who's responsible for aircraft kind of incidents. We rescue about 300 people a year. We rescue about based on our satellite data is contributed. Based on our satellite data, say that rescue happened because you can basically say that rescue happened. And since the beginning of time, if you look at the whole and since the beginning of time, if you look at the whole globe, it's been like around the globe because of this international SARSAT. Around the globe because of this international SARSAT system.
The chances are hung out here something would happen over there. The chances are
it's probably if you were here for an hour, we might get an alert. We get alerts for an hour. We might get an alert. We get alerts quite often.
I saw on the sign where it said. When I came in, I saw on the sign where it said. What ice facility?
Okay, so it's a collaboration between the Navy, it's a collaboration between the Navy. They use satellite data to look at the ice. They use satellite data to look at the ice over the Arctic. They also do snow mapping and snow depth analysis. They also do snow mapping and snow depth analysis. But their predominant thing is ice. So they're looking at ice in the Arctic and in the Antarctic. They're looking at ice in the Arctic and in the Antarctic. Who are trying to get through the ice. They're trying to take their ships. Who are trying to get through the ice. They're trying to get through the ice. Cargo ships, container ships, get through the icebreakers. They're helping icebreakers things or help icebreakers go out and rescue things or where the ice is, and also where the ice isn't. Where the ice is, and also where the ice isn't. Through an ice-infested waters that allow them to transit through an ice-infested waters that allow them to transit without getting stuck. Any ship getting stuck in the ice anywhere. We're trying to avoid any ship getting stuck in the ice anywhere.
Fairly new. Now, even though this you actually had fairly new, the infrastructure had to change the actually manage the satellite operations. Actually manage the satellite.
Yeah. So when we designed this building back in the early 2000s, so when we designed this building, we had made assumptions about technology that we would need to fly the next generation satellites, that we would need to fly the technology made a major change. Unfortunately, the technology made a major change. So over that time, when we actually got in and we didn't design for GOES-R, when we actually got in and we realized that the technology had changed so dramatically that we needed a whole lot more power and a lot more cooling because we've gone to radar architectures and servers, gone to radar desks that generate tremendous amounts of spinning desks that generate tremendous amounts of power. So the power we had in the building, lots of power. So the power we had in the building, so insufficient. We could not even just like it was so insufficient. We could not even change it or beef it up. We had to change it or beef it up. We had very carefully over a period of years. We had to take out all the generators and replace them with new generators. To take out all the generators and replace them with new generators. All the water cooling systems. We had to chillers. All the water cooling systems. Maximize the amount of power we can ever get into this building. Maximize the amount of county can ever get into this building. That the utility county can ever provide. Basically maxed out everything we can take from them. We've basically maxed out everything we can take from them. generations, the two big flagship satellites together. They each have very large ground systems together. They each have very large ground systems with lots of floor of this building. Matter of fact, the third floor had to be double the size. Matter of fact, the third floor had to be double the size. When the design was for computers, the other half was for different rooms, the other half was spaces and classrooms, different rooms and spaces and classrooms. The whole thing one huge computer. We basically had to make sure we had the good reliability and redundancy that we need to make sure we have the good reliability and redundancy that we need all these new satellites and to be able to operate flying all these new satellites that are going to start flying next year with GOES-R.
Right now, we're going to go to Mike Carey with a preview of NASA Television's coverage of the GOES-R launch coming up at 4:45.
Thank you, Franklin. I'm here in the Atlas Spaceflight Operations Center on Cape Canaveral Air Force Station, where on Cape Canaveral Air Force Station, where the launch control team the Atlas 5 rocket, all the folks are getting ready to launch the Atlas 5 rocket. With NOAA's GOES through a very large countdown procedure book, through a very large countdown procedure book. Everything's going well. We just had a weather briefing from launch weather officer. Just had a weather briefing from launch weather officer Clay Flynn, and we're now 100%, so everything's going well. No launch constraints. We're getting ready to kick off our coverage at 4:45, and we'll have a lot more details for you then. And we'll have a lot more details for you then.
NASA Television will switch over to coverage of the Soyuz ISS docking, coverage of the Soyuz ISS docking, and then we will be going continue our broadcast on our social networks, continue our broadcast on our social networks, and YouTube. And when we come back, I'll be here with the National Weather Service. And when we come back, I'll be here with the National Weather Services, Joe Pica. You're watching NASA Edge.
From the Russian Mission Control Center in the town of Korolyov, outside of Moscow. Welcome to our outside of Moscow. The arrival of three new residents to the International Space Station. To the International Space Station. From a balcony camera overlooking the International Space Station, overlooking the International Space Station for a huge crowd here in Korolyov. NASA, European Space Agency, and Russian European Space Agency, and Russian Federal Space Agency officials. VIPs are on hand, and guests and VIPs are on hand. Time from now, the arrival of the three new residents time aboard the International Space Station later aboard the International Space Station a bit later this morning. That trio consisting the Soyuz commander who was strapped into the Soyuz commander who was strapped into the center seat of the Soyuz MS-3 vehicle. Engineer number 1 from the European Space Agency, Tomas from the European Space Agency, NASA flight engineer Peggy Whitson, who was about to arrive for her third long-duration mission aboard the International Space Station, mission which should be ultimately a record-breaking tour for Whitson on board the International Outpost. On board the International Outpost will be joining later this morning. Will be joining current residents on board the International Space Station. Residents on board the International Space Station. NASA Commander Russian colleague Sergei Ryzhikov and Andrei Borisenko will arrive aboard the International Space Station just a month ago on October 21st aboard the Soyuz MS-02 vehicle, aboard the Soyuz MS-02 vehicle, which is docked segment of the International Space Station, the Russian segment of the International Space Station, the Poise module. Novitsky and Tesgay is the Earth-facing port on the Russian segment of the International Space Station, that being the International Space Station, that is being attached to the Zarya module of the International Space Station, which was launched 18 years ago, Moscow time, on November 20th, 1998. So an anniversary being celebrated with the arrival of three new residents to the International Space Station that will bring Expedition to a full complement of crew members.
Some interference. Not stable. Not stable.
At the tower, the International Space Station is flying 250 miles above the Earth, moving from southeast to southeast, in an orbit inclined 51.6 degrees to either side of the equator, flying over the Pacific Ocean. Soon the complex will be making a swing across the southern Atlantic Ocean, where docking is expected within the hour. The docking time is 2 p.m. Central Time, scheduled at 4:02 p.m. Central Time. If everything goes as planned, so far so good. If everything goes automated rendezvous system on the Soyuz automated rendezvous system on the Soyuz corresponding hardware on the service module, as well as the corresponding hardware on the International Space Station. Those two systems have locked on to one another as we continue a steady approach for an on-time docking to the Rossviet module for an on-time docking to the Rossviet module of the International Space Station.
Дальность 9,5, скорость минус 14,8, некий метр захват. Минус 14,8, некий метр захват.
Just 2 days ago from the Baikonur Cosmodrome in Kazakhstan, engine ignition occurred on the Soyuz MS-03 vehicle, as engine ignition occurred on the Soyuz MS-03 vehicle, which was 2:20 a.m. Baikonur time in the wee hours of Friday morning, which was 2:20 a.m. Baikonur time in the wee hours of Friday morning. Second ascent for the Soyuz booster and its 8-minute 45-second ascent for the Soyuz booster and its shutdown and spacecraft separation, followed a few seconds later by the deployment of the navigational antennas and the solar arrays, a few seconds later by the deployment of the navigational antennas and automated approach and all of the engine firings in this rendezvous that brought the Soyuz virtually now into the neighborhood of the International Space Station, virtually now into the neighborhood of the International Space Station this afternoon within the hour. Scheduled at 4:02 p.m. Central Time this afternoon within the hour. At what is known as a ballistic targeting point. Will arrive at what is known as a ballistic targeting point. It will begin a fly around of the International Space Station at a fly around angle of just 56 degrees. The International Space Station at a fly around angle of 56 degrees at the forward end of the Soyuz, the docking probe, orbital module, the upper stage, if you will, of the 3 sections of the Soyuz vehicle. Orbital module, the upper stage, if you will, of the 3 sections of the Soyuz vehicle. And the Russian Mission Control Center, station precisely calculate flight controllers here in the Russian Mission Control Center, Soyuz, and precisely calculate and assess the alignment of the Soyuz given to begin the final approach for contact and capture, which again is given to begin the final approach Central contact and capture, which again should occur just after 1 a.m. here in Moscow Central Time on a Sunday morning. Eastern Time, just after 1 a.m. here in Moscow on a Sunday morning.
Камеры GoPro включили вовремя, подтвердите. Камеры GoPro включили вовремя, подтвердите. Хорошо, я понял. Подтверждаем, камеры включили вовремя.
Half a world away at the Johnson Space Center in Houston. At the International Space Center in Houston, the Orbit 2 team of flight controllers, the International Space Station Flight Control Room, the Orbit 2 team of flight controllers over all of the systems of the International Space Station. On console, they are watching over all of the systems of the International Space Station. Is Flight Director Tony Sakaki, second from your right, this flight control team, is astronaut and now Flight Director T.J. Kramer from your right, joined on console by former astronaut and now Flight Director T.J. Kramer, astronauts Jessica Meir, just at the top of your screen, from the top of your screen, who will be Jessica Meir talking to Shane Kimbrough and his crewmates aboard the International Space Station in the terminal phase of this rendezvous, and his crewmates aboard the International Space Station in the terminal phase of this rendezvous, at the very top of your screen, veteran astronaut and now a member of the commercial crew Soyuz systems expert, should her expertise be required during the course of the final phase of today's rendezvous for docking. Be required during the course of the final phase of today's rendezvous for docking.
Дальность 6300, скорость минус 10. Дальность 6300, скорость минус 10. While the Soyuz is in the terminal phase of its approach for docking to the International Space Station, while the Soyuz is in the terminal phase of its approach for docking to the International Air Force Station in Florida, space news being made down at the Cape Canaveral Air Force Station in Florida at 5:42 p.m. Eastern Time to carry the geostationary operational environmental satellite R series to carry the geostationary operational environmental satellite in a cadre of the next generation of geostationary weather satellite. In a cadre of the generation of geostationary weather satellite phenomena that significantly improves the detection and observation of environmental phenomena that directly affect public safety. The launch coverage for the GOES R satellite will begin first on the NASA TV media channel at 4:45 p.m. first on the NASA TV media complete our docking coverage, then we will be joined Eastern Time. Once we complete our docking coverage, and media will be joined and co-anchored both on the public and media channels of NASA television. Получаем хорошее телевизионное изображение, видим станцию в центре. Получаем хорошее телевизионное изображение, видим станцию в центре. Мы тоже наблюдаем войска. Мы тоже наблюдаем скорость минус 9,1, есть единица, есть захват. Дальность 5300, скорость минус 9,1. The Soyuz MS-03 vehicle is less than 5.5 kilometers away from its destination for docking to the Rossbian module of the International Space Station. Away from its destination, closing at a rate of about 9 meters per second. The International Space Station continues to go closing at a rate of about 9 meters per second. Very precision-like approach by the Soyuz. You're looking for at a view from very precision-like approach by the Soyuz. You're looking as it view from an external camera on the Soyuz vehicle in the lower left-hand corner of this engineering overlay. You see the distance and the rate of closure of this engineering overlay. You see the distance and the rate of closure to the International Space Station. Under 5 kilometers away from contact and capture to the International Space Station. Есть давление освещения депо. Да, наблюдаем. Есть давление освещения депо. Да, наблюдаем.
Данных 4400. Данных 4400. Скорость минус 8,6, есть единица, есть захват. Скорость минус 8,6, есть единица, есть захват.
Принято. Принято.
If everything goes as planned, with docking scheduled within the hour. If everything goes as planned, with docking scheduled 1:02 a.m. Moscow within the hour, at the 4:02 p.m. post-docking scenario 1:02 a.m. Moscow time, the relative motion post-docking scenario would call and the International Space Station to dampen out the Soyuz vehicle and the International Space Station to dampen out contact, if you will, of the Soyuz against the docking mechanism on the Rossby vehicle. Soyuz against the docking mechanism on the Rossby vehicle. Relative motion of about zero between the two vehicles. Enable a relative motion of docking zero begins to retract on the Soyuz before the docking interface begins to retract one another and enable two docking interfaces to form a hard mate between the Soyuz and the Rossby module of the International Space Station. The Soyuz and the Rossby module of the International Space Station. About a 2.5-hour period that will checks and other systems checks on both sides of the docking interface and other systems checks on both sides of the docking interface between the Soyuz and the Rossby module that will lead to the opening of the Soyuz and the Rossby module that will lead to the opening of the hatches between the two vehicles that is scheduled at 5 a.m. Moscow time or 6:35 a.m. Moscow time, 2.5 hours 6:35 p.m. Houston time, 2.5 hours after docking.
Дальность 3,4, скорость минус 8,4. Дальность 3,4, скорость минус 8,4. Дальность 300, скорость 8,5, знак минус. Дальность 300, скорость 8,5, знак минус.
Принято.
Идем выше
Принято.
Идем выше
Я вас понял. Сейчас процесс должен нормализоваться. Сейчас процесс должен нормализоваться.
We can hardly radio.
Я говорю, пока все идет нормально, процесс должен нормализоваться. Я говорю, пока все идет нормально, процесс должен нормализоваться.
Everything is going nominally and everything should, as expected, become. We do have, as expected, some jumps in the range. Some jumps in the range.
Дальность 2, есть единица захват 8,3. Есть единица захват.
Range rate minus 8.3. We have expedition. Range rate minus 8.3. We have expedition.
Range
is 2.5 and range rate is 8. Range is 2.5 and range rate is 8. We copy.
This is Mission Control Korolyov, just 32 minutes away from the anticipated Control Korolyov, just 32 minutes away from the anticipated module of the International Space Station. Everything to the Rossby module of the International Space Station with the Soyuz on track in pursuit of the International Space Station 251 statute miles over the South Pacific. 251 statute miles over the South Pacific degrees to either side of the equator. Everything continuing to either side of the equator. Soyuz, everything currently executing a series of what are known as impulse burns, executing a series of what are known as impulse burns, precisely fine-tune the Soyuz path to the International Space Station. The Soyuz is currently looking at the International Space Station's external camera, looking at aboard the Soyuz, again in the center seat, flying over the call sign aboard the Soyuz, again in the center seat, flying over the call sign of Alexei is veteran Russian cosmonaut Alexei astronaut Tomov to his left. European Space Agency astronaut Tomas veteran and NASA flight engineer Peggy Whitson, veteran who will surpass a variety of records during who will stay on board the station, a variety of records during the all-time record on most days in space by an American astronaut. The all-time record that currently held by an American astronaut recently set. That currently held by Jeff Williams. Record recently set in space by a U.S. astronaut on April. Record for most days in space by a U.S. astronaut on April 24th.
We see that the station is at the center of the
The International Space Station growing ever larger in the field of view. The International Space Station now growing ever larger in the field of view. With the Soyuz now at a rate of 1.4 meters per second. At the time at a rate of final approach contact to capture the Soyuz will be traveling final approach glacial rate of about 1/10 of a meter per second. At a glacial rate of about 1/10 of a meter per second. The rate proposed contact on the International Space Station at the rate of docking on the International Space Station. Will be reporting everything through the closure. Of course, will be reporting everything to make sure that everything is in place for a hard mate. To make sure that everything is in place for a hard mate between the Soyuz and the Rossby. A couple of hours of leak check will set the stage for a couple of hours preceding the opening of the pressurization that will enable Nowitzki preceding the opening of the hatch that will enable Nowitzki to join the current International Space trio, to join the current Commander Shane Kimbrough trio and his two Russian station commander colleagues, Sergei Ryzhikov and Andrei cosmonaut colleagues. This will complete and Andrei Borisenko and a Soyuz landing within a 4-week period. Very impressive by anybody's yardstick. Within a 4-week period, very impressive by anybody's yardstick. For the next several months, 6-person crew for the next several months.
It didn't come as a surprise, so everything should be going fine. It didn't come as a surprise, so everything should be going fine.
Go ahead.
Okay, I want you guys to tell me where the red camera, battery chargers were there.
Stand by, facing ground 2. Station is talking on facing ground 2.
Business.
Range is 1,200 and range rate is 1,800 and if it's range rate to work with no AGC, that for you to work with get deactivated. We actually see that adjusted it and deactivated. Now we actually adjusted it and copy. For now it's the best option. Copy.
1200
is the range. And range rate is the range. And range rate is minus. We are slightly above the corridor. And we are slightly above the corridor. We are standing by for the thrusters. We are standing by for the range rate adjustments. Thrusters. We copy. Range rate adjustments. We copy. 1,000 is the range. Range rate is 1,000 is the range. Range rate is 3.6.
Есть работа
We confirm depot thrust activation.
Есть работа
We confirm depot thrust activation. We confirm that the retrograde burn.
Есть падение скорости.
We confirm that the retrograde successful with decelerating. Range has been successful with decelerating. Range is 2.5 and range rate is decreasing. Minus 2.8 is the range rate. Copy. Minus 2.8 is the range rate.
All of the Soyuz thruster firing, so-called impulse burns, Soyuz thruster firing, so-called impulse burns, continue to be executed. This is all an automated approach by the Soyuz, which will begin a 50-60-degree fly-around of the International Space Station in about 5-degree fly-around of the International Space Station about 5 minutes from now of the Soyuz craft with the Earth-facing Rossviet module docking port, with the Earth-facing Rossviet module docking port.
Is moving you're moving to the left and to the right. We see the movement to the left and to the right. To the left and to the right. We see the movement to the left and to the right. Range is 800 and range is 800 and range rate is 2 meters per second. Meters per second.
Есть обобщенная
We confirm combined gas. So
Есть обобщенная
we confirm combined gas. Confirm thruster activation. Range is 740 and range rate is 2.3 meters per second. And range rate is 2.3 meters per second.
This view now of the Soyuz MSO-3. This view now of the Soyuz MSO-3 for its docking to the Rossviet module of the International Space Station. Now just 700 module of the International Space Station. Now just soon to begin its fly around of the International Space Station. Closing at a rate of begin its fly around of the International Space Station. Closing at a rate of 2.2 meters per second. Everything tripping along nicely on the timeline that will lead everything tripping along nicely on the timeline that will lead to an expected docking to the Rossviet 1:02 a.m. at 4:02 p.m. Central Time, 1:02 a.m. Moscow time.
We confirm activation of the dipole thrusters. We confirm activation of the dipole thrusters. We are within the corridor, so everything is nominal. We are within the corridor, so everything is nominal. Range is 590 and range is 1.5 meters per second is the range rate minus 1.5 meters per second is the range rate. We copy. We are standing by till the final approach part. We are standing by till the final approach part. The range is 560. Standing by. Range rate is 1.4 meters per second. Range rate is 1.4 meters per second.
Once again, you're looking at the Soyuz MSO-3. Once again, you're looking at the Soyuz MSO-3, which just 2 days ago lifted off from the Baikonur Cosmodrome and Kazakhstan on the International Space Station. 34 orbit 2-day rendezvous to the International Space Station. All of the approach burns and engine firings pre-programmed into the Soyuz computer. No issues as the International Space Station had no issues as the International Space Station and the Soyuz to northeasterly track that will carry it across southwest to northeasterly track that will carry it across we are Chile a short time just about 22 minutes away from docking. And we'll begin the fly around of the International Space Station about we'll begin the fly around of the International Space Station about a minute or so from now.
For range, for range. Range is 450, and the range rate is minus 50, 1 meters per second. And the range rate is minus 1 meters per second. Copy. We copy.
Range is 412
and range rate is 0.9 and range rate is 0.9. Where the minus? And copy. Where the minus?
And copy.
Yes, sir.
We confirm the roll maneuver. Confirm the
This is Mission Control Koryov, the fly-around of the International Space Station. The fly-around of the International Space Station. Once again, you're looking at the vehicle has begun with, once again, you're looking at the vehicle strapped into the center seat of the descent module, the center section of the center seat of the descent module, to his left of the board engineer number 1, Thomas Pesquet, to his left is board engineer number 1, Thomas Pesquet, to his right, the European Space Agency, the veteran NASA flight engineer, soon to be a veteran NASA flight engineer, she begins her to be a record long-duration stay on board the International Space Station. All of the Soyuz systems continue to function flawlessly. All of the Soyuz is now at a distance of just 340 meters, now at a distance of a rate of 340 meters, closing at a rate of 8/10 of a meter per second. And once this short fly-around 3 minutes ends, we will have a period of 2.5 to 3 minutes, just a few minutes, a period where the brakes will be put on, the Soyuz will be stationary, where the brakes will be put on, the Soyuz will be stationary, knocking probe begins, final assessment of the alignment of the forward knocking probe begins, final approach commanding controllers here in Koryov, before final approach begins, its closure of the final several hundred feet, begin its prior to contact of the final several hundred feet prior to contact and capture.
See that? We just see the insertion module now. We just see the insertion module now. Docking. Let's wait for the docking coming back. And the range is 2 coming back. And the range is 230. I think it's 290. 390. 290. I think it's 290. Continue monitoring the 290. Continue monitoring on the sizes. Monitor on the monitor. Well, based on the data that we are receiving, you're continuing with the fly around that we are receiving. You're continuing with the fly around and everything is looking good. Range per course is 280. Range per course is 280. And range is minus 45. And range is minus 45.
Go ahead.
Okay, I'll just breathe you on.
Where did Jessica go ahead?
Okay, I'll just breathe you on.
We see the donkey board. We see the donkey board.
260 meters away, closing at a rate of less than a half a meter per second. 260 meters away, closing at a rate of less than a half a meter per second. Ramp up its fly around and begin a short period of station keeping. Everything fly around and begin a short period of station keeping. Everything docking scheduled to proceed on track. 2 p.m. Central Time, 1:02 a.m. Moscow time, 2 p.m. Central Time, 1:02 a.m. Moscow time. For Oleg Novitsky, Peggy Whitson and Thomas Pesquet. For Oleg Novitsky, Peggy Whitson and Thomas Pesquet.
SM diameter is a little bit more than.
And as we continue our coverage of the Soyuz docking here on the public channel of NASA television, we're about to switch the media channel of NASA television. We're about to switch the media channel over to the Kennedy Space rocket and the GOES R environmental launch of the Apollo 5 rocket and the GOES R environmental with our coverage of Soyuz and its arrival at the International Space Station. Soyuz and its arrival at the International Space Station.
Copy. We copy and confirm. Copy.
Мы не получаем
We're not getting any video image. We're not getting any video imaging, guys. Please report in detail what you're seeing on your side.
Soyuz currently executing a pre-planned roll maneuver. Currently executing a pre-planned roll maneuver arrays that will precisely align orientation arrays for its final approach and orientation to the Rossviet final approach for contact and capture to the Rossviet module.
read us? We do not have any comm on our side, and we do not have any image. We copy you loud and clear. Have any image? Because we're not getting any video image. Please report. Because we're not getting any video image. Please report. We continue with the roll maneuver. Copy. We are on the axis of the maneuver. We are on the axis of the docking range. Per course data is 213. Range per course data is 213. Visually. That's what it is. What about what it is? Angular rate. What about therefore angular rate? It was pretty shaky before. It was pretty shaky before. Wait for the station keeping, and then for the final approach. Station keeping, and then please confirm that approach. Please confirm that Sky 15 command illuminated Sky 15 commands. Illuminated. That is not illuminated. Retreat. It is not. Copy. Great, and we're seeing the image now. Copy. Great, and we're seeing the image now. Perfect. You have a go. You have a go. One control panel. Send the final approach command. Copy in work. Send the final approach command. Copy in work.
Having completed its fly around of the International Space Station and now completed its fly around of the International Space Station and now away, we are about to receive the final command. We are about to receive the final command to the International Space Station. Good view of that Soyuz to the International Space Station cameras on the International Space Station from external cameras on the International Space Station. Currently flying along the east coast of South America, currently flying along the western northeast South America, currently over Argentina, about to cross the border to Uruguay. Currently over Argentina, about to cross the border to Uruguay.
You're still not at the 40-meter mark. You're still not at the 40-meter mark. We're sending the final approach command. Alright, we're sending the final approach command. We see the depot activation. We see the depot and the change in the range rate. And the change in the range rate.
Через 7 минут ожидается вход в тень. Через 7 минут ожидается вход в тень.
And you will hit the sunset in about 7 minutes. Copy in about 7 minutes. We will be in the 7 minutes. Copy in about 7 minutes. We will be in the sunset.
Так, у нас ЛСК. Где сегодня?
So 1, 2, 3, 4. And we have 1, 2, 3, 4 message, and we have message, and our range is 68. Range is 68. And range is 85. And
launched in a Delta rocket October 16th, 1975.
The approach of the Soyuz toward the Rosviet module
NASA turns to the engineers and analysts in its launch services program to send robotic spacecraft on their way for some of the most exciting and notable missions in the agency's history. The Launch Services Program, which is known as LSP, is based at NASA's Kennedy Space Center here in Florida and has a roster of engineers and technicians who specialize in all aspects of rocketry and spacecraft integration. LSP selects the appropriate launcher for a mission spacecraft, in this case, the United Launch Alliance Atlas V for NOAA's GOES-R. The selection process takes place years before the first launch opportunity. The program then provides oversight as the designs of the rocket and spacecraft are integrated with each other. And as liftoff nears, teams oversee the launch vehicle's engineering and manufacture and its integration with the spacecraft. LSP conducts the countdowns for NASA's missions here and provides additional quality assurance along with other controls to ensure a successful mission. LSP managers are here, right next door to us in the Mission Director Center, overseeing today's activities. Our NASA LSP launch mission manager today is Omar Baez, seated in the center of the screen. GOES-R will be boosted to space atop the United Launch Alliance Atlas V rocket in the 541 configuration. One of the most powerful rockets in the Atlas V fleet, the 541 configuration with 4 Block C solid rocket boosters provides the optimum performance to precisely deliver GOES-R to its desired place in space. In addition to completing 2 national security missions, an Atlas V 541 configuration rocket launched NASA's Curiosity rover on its 10-month, 354 million-mile journey to the surface of Mars.
Out of the window.
Today will be the 67th Atlas V launch and the 113th United Launch Alliance launch.
Axis of the docking port.
The launch team here in the Atlas Spacecraft Operations Center, comprised of managers from NOAA, NASA, and United Launch Alliance, has been on console since about 1 o'clock this afternoon. Operations began about an hour ago to fill the Atlas booster and Centaur upper stage with liquid oxygen. The tanks will reach flight level at about T-minus 5 minutes. Liquid hydrogen is loaded into the Centaur tank, while the Atlas was fueled with RP-1, a rocket-grade kerosene, on Friday afternoon. All fueling operations are proceeding normally. They got started a little bit late as the teams worked through a couple of minor issues. And the offset from that is that our hold that occurs at the T-minus 4 minute mark, normally a planned 15-minute hold, now will be a 6-minute hold, as launch managers borrowed 9 minutes from the T-minus 4 minute hold and added it to the hold that was in place prior to the start of fueling. So we'll enter that hold at 5:32 p.m. Eastern Time, 10 minutes away from launch. Then everything is proceeding normally. Weather is 100% go. And we're at T-minus 43 minutes, 28 seconds, and counting. This is Atlas Launch Control.
The docking port is 1.5 squares away, and the range is 47 meters. Copy.
Yes, SVP, все транспаранты загорелись.
And we confirm the SVP D7 or D7.
T-minus 43 minutes.
We copy.
And LC2. Go ahead.
Data shows range of 39 and range rate of minus 2. Copy all.
Roger. Perform Centaur fill and drain valve, SRV, and LH2 SVV cycling test.
Slowly but surely, the Soyuz closing in, just 40 meters away now from docking to the Rosviet module, as both the International Space Station and the Soyuz fly in tandem over Rio de Janeiro. At a speed of 5 miles per second over Rio de Janeiro.
From the green crosshairs, from the crosshairs, we copy.
Линия куда себя выбери. Линия куда себя выбери.
Could you select the ruler here?
T-minus 42 minutes.
Мишень ниже 1 градус.
The target is lower by 1 degree. The crosshairs are almost aligned.
Принято.
We copy.
Дальность 25 метров.
Range is 25 meters.
Понял вас.
Copy.
Мишень практически
The target is almost in the center and the crosshairs are aligned.
Принято.
We copy. We are approaching the 30-meter mark.
Есть готовность СВП.
And we confirm we got the message that the SSVP mechanism is primed. We see that. And range is 20, and the target is in the center. Range, the crosshairs are aligned. Are you getting the image, Moscow? We are.
This is Atlas Launch Control at T-minus 40 minutes, 24 seconds and counting. And I'm pleased to be joined by Diana Calero, who is the Launch Services Program Mission Manager for the GOES-R mission. Hi, Diana.
Hi, Mike.
Thank you for joining us.
Thank you for having me.
We wanted to talk a little bit about the activities that have led up to today's launch, and we have a tape that we're going to roll for you to give us some background on.
Sure. Well, here you see the booster that is being transported once it arrived here at Cape Canaveral. It actually arrived a week later than scheduled due to the hurricane that came by, Hurricane Matthew. So it came by through the Antonov, and it arrived a week later. And here you see it being transported into the ASOC, the Atlas Space Flight Operations Center. And once it gets transported, here it goes through a series of tests in its horizontal position. And once these series of tests are completed, it'll be transported very early in the morning, as you see here, over to the vertical integration facility. And there at the VIF, it'll be placed in the vertical position and lifted and set on top of the mobile launch platform that is inside the VIF right now. And once it gets placed there, it'll wait for the rest of the components that go on the rocket to be hoisted and made it to the top of the booster. Here you see a nice view of the booster. It's about 100 feet long, and you see the two nozzles coming out the end, and that's the RD-180 engine. That's inside the booster. The next component that'll come over and be mated to the booster are the solid rocket motors. This is GOES-R is launching in a 541 configuration. So what that means, it's a 5-meter payload fairing, and it has 4 solid rocket boosters attached to the main common booster. So here you see one of the solid rocket boosters being placed in a vertical position, then being hoisted, and it'll be mated to the bottom portion of the main booster. It takes about 1 day for each of the boosters to be attached to the main booster. So now you see the second stage, the Centaur, attached to the interstage adapter and being hoisted and placed on top of the booster at the VIF. That'll be, so you see it slowly being placed on top, and then it'll get bolted down and await the payload fairing, which you see now being transported over from Astrotech. So inside the payload fairing is the GOES-R spacecraft that was encapsulated back at Astrotech, and it takes its 25-mile journey over the road, and it gets hoisted again, rocket. And once it's placed there, there'll be a series of tests that test all the connections and the functionality between the spacecraft and the rocket. So we have our series of integrated tests there, and once that's accomplished at L-1 day, which occurred yesterday, it was rolled out to the pad and is now awaiting launch.
Excellent. Well, we're glad everything is on target, and we really appreciate you taking your time.
Great, thank you very much.
Thank you.
Okay, on the SSVP display, that's what we're seeing. All right, we'll be monitoring the SSVP docking mechanism operation. 003855. Okay, copy for capture. 003855. The KDU parameters are nominal. All right, at 145.
This is Mission Control Koryoff. Once again, docking was flawless every step of the way from the launch pad of the Baikonur Cosmodrome 2 days ago to the Soyuz's arrival moments ago, with docking occurring at 3:58 p.m. Central Time, 4:58 p.m. Eastern Time, as the Soyuz and the International Space Station flew 251 statute miles over the northeast coast of Brazil.
We're now waiting for relative motion between the two vehicles to dampen out. The docking probe on the Soyuz will begin to retract to initiate the closing of the hooks and a hard mate between the two vehicles. We'll stand by for that call.
Wait for confirmation.
Олег, выдайте, пожалуйста, Г4. Надо выключать на передатчик.
Now to deactivate the transmitter.
Что выдать?
What did you say?
Г4. Отключение дисплея трансляции.
Deactivate the transmitter.
Г4, принял.
Copy that.
Station Moscow on Space to Ground 1 for Andre.
Г4 выдано.
Careful command has been sent.
Ну тогда работаем по 81-й страничке.
For page 81.
Station Moscow on Space to Ground 1 for Andre. Regarding MPEG recording termination.
Otherwise, the blue screen will bother you.
Москве, Кэшбэк 2, первый замер, герметичная сальсейка, время 01:02, давление ВСА 854, давление ВБО 835, давление ВБО.
The crew aboard the Soyuz MS-03, Oleg Novitsky, Thomas Pesquet, and Peggy Whitson, in the process of deactivating some of the Soyuz systems that were used during the terminal phase of the rendezvous as we stand by for the retraction of the docking probe and the closing of the hooks that will form a hard mate between Soyuz and the Rosviet module on the Earth-facing side of the Russian segment of the International Space Station, to which the Soyuz arrived just a few minutes ago, with docking occurring at 3:58 p.m. Central Time, 4:58 p.m. Eastern Time.
Go ahead. Andre, you can close the application, terminate recording, and downlink the file for us.
With the video preparation, please.
Okay, and work?
Downlink it to us via OCA.
Фара выключена. Как приняли?
We deactivated the floodlight.
Я вас понял.
Copy.
Как проходит режим стягивания? Крюки закрыты?
Station Moscow, Space to Ground 1 for Sergey, regarding Moving MRM-1 Soyuz PEV to electrical control mode.
This is Mission Control Korolyov. We can confirm now that the Soyuz hooks are closed at the docking port of the Rassvet module. That hook closure occurring at 4:04 p.m. Central Time, just 6 minutes after the Soyuz docking to the Rassvet module. So we have a hard mate now between the Soyuz and the International Space Station that will set the stage for a couple of hours of leak checks to make sure we have an airtight seal at the docking interface, followed by the pressurization of the vestibule or passageway between the Soyuz and the Rassvet module itself. That will be the precursor to the opening of the hatches between the two vehicles.
Space to ground 1 for Sergey regarding switching MRM-1 Soyuz PEV to electrical control position.
Так, есть загорание Г-17, защелки втянуты. Понял вас. Ждем втягивания штанги. Загорание.
This is entry on Space to Ground 1. Yes, go ahead. All right, so we got 4 files.
Yes, concur.
And the total size of the 4 files is 1.29 gigabytes. Copy. Thank you for that information. And I was trying to get a hold of Sergey regarding the MRM-1 Soyuz PEV valve transition.
Service module probe retracted.
Okay, I'll hand over the headset to him.
Go to deactivate.
How would you like me to call the folder with the video files that we recorded during final approach and docking? You can call it TK733 and Moscow Station on Space to Ground 1. This is Sergey. Go ahead. Yeah, we'd like you to move MRM-1 Soyuz PEV to electrical control position. Copy. And for the final approach and docking timeline, everything was nominal, and I was looking at all the times, and all the times matched the predicts. Thank you. That sounds great, Sergey.
This is Mission Control Korolyov. Just to recap, a flawless approach and docking by the Soyuz MSO-3 spacecraft with Oleg Novitsky, Peggy Whitson, and Thomas Pesquet on board, wrapping up a textbook 2-day rendezvous after the launch from the Baikonur Cosmodrome in Kazakhstan in the afternoon hours U.S. time on Thursday, the early morning hours on Friday at the Central Asian launch site. Novitsky, Pesquet, and Whitson arriving just a few minutes ago, with docking occurring at 3:58 p.m. Central Time, 4:58 p.m. Eastern Time. Just 6 minutes later, hooks closed between the Soyuz and the Rassvet module of the International Space Station that was the docking port for the Soyuz spacecraft. So we have a hard mate now. We will be switching the public channel of NASA television now to the Kennedy Space Center for launch coverage
from the Cape Canaveral Air Force Station of the Atlas V rocket and the GOES-R environmental and weather satellite atop the Atlas V. That launch scheduled at 5:42 p.m. Eastern Time. On the media channel of NASA TV, we will continue our coverage with a post-docking news conference that will feature NASA Administrator Charles Bolden and the head of the Russian Federal Space Agency, Igor Komarov, who will be offering their thoughts on today's docking of the latest trio of residents to the International Space Station. Again, we will stay on the media channel for this post-docking news conference that will be coming up shortly. The public channel now going over to the Kennedy Space Center for coverage of the Atlas V launch and the GOES-R environmental satellite. For now, this is Mission Control Corridor.
Thank you, Rob. We're back live at the Atlas Space Flight Operations Center on
feet. No echoes on the radar, not expecting any through the balance of the count in the window. Taking a look at the winds out of Complex 41, should have light and variable winds really for the next hour, and then I believe they
is 21 minutes, 13 seconds and counting. Again, good news on the weather. Everything looks go. No major technical issues at work. As we mentioned a few moments ago, TV meteorologists from all over are here to watch this launch of the NOAA GOES-R satellite, which will contribute greatly to their ability to forecast in the future. One of those here today, Al Roker, host and weatherman of NBC.
Not just a hurricane.
maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 35 seconds. At 46 seconds, the vehicle experiences maximum dynamic pressure. The first two solid rocket boosters, or SRBs, are jettisoned at 1 minute 50 seconds, followed a second and a half later by the third and fourth SRBs.
Friend is here today. We worked with him at Baikonur and in Moscow, and it is very important for us that together we work on our key programs and events that deal with joint operations on the ISS. We discussed the future of the ISS.
Tour the outer planets, the New Horizons probe that flew by Pluto, and the Curiosity rover on Mars, as well as previous GOES satellites. Setting the stage for today's launch at 5:42 p.m. We have a 1-hour launch window should that be needed. At this time, everything continues to be go. And once again, weather will not be a concern for us. We're counting down to our planned built-in hold at the T-minus 4-minute mark. We're at T-minus 12 minutes, 15 seconds and counting. This is Atlas Launch Control.
T-minus 12 minutes.
Cargo suppressor charge is complete. Roger. This is the LC on 1. All steps are complete through step number 710.
This is Atlas Launch Control at T-minus 10 minutes, 4 seconds, and counting. NOAA's GOES satellite ready to begin its journey today at 5:42 p.m. Eastern Time and provide a wealth of real-time data for weather forecasters around the Western Hemisphere. Let's learn a little bit more about the GOES satellite.
GOES satellite is really a game changer. It's going to transform how we do our forecasting and the quality that we can deliver.
Harnessing state-of-the-art technology and engineering, GOES will scan the Earth 5 times faster than our current geostationary satellites, with 4 times greater image resolution and triple the number of channels for scientists to observe global weather and climate. This means much higher quality images of severe weather, from floods to hurricanes, delivered to forecasters much more rapidly, every 30 seconds, instead of the current rate of every 5 minutes.
For our forecasters, it's going to be like jumping from black and white TV to high def. They're going to have more channels of information, they're going to have finer detail, they're going to get the information at a faster update rate, they're going to be able to see lightning in storms for the first time, all of which is going to really jump forward how well they can monitor and produce forecasts about severe weather.
Beyond weather forecasting, GOES-R will also improve our ability to monitor and predict solar activity, which can potentially degrade critical technology on Earth, such as power grids, aviation, and GPS communications. It will also provide search and rescue assistance to people in life-threatening situations on land and at sea. Equipped with a transponder that detects distress signals from emergency beacons, GOES-R will relay the location of activated beacons to NOAA, which will notify the Coast Guard or Air Force.
NOAA's core mission in many ways is to provide the country with environmental intelligence, reliable, actionable information that people from heads of households to head of state can factor into the decisions that they're making every single day. And GOES-R now elevates the quality of the data that go into that environmental intelligence to a whole new plane.
Taking the GOES-R project from initial design to launch was a highly coordinated, collaborative process. Teams of experts from NOAA, NASA, and their partners worked together to determine the technology needed to meet the needs of the National Weather Service, and then to engineer and build what has emerged as the most advanced weather satellite the United States has ever produced.
It's really a team effort by a tremendously large, multidisciplinary team of people who work remarkably long hours and make tremendous personal sacrifices over many years. One of NOAA's primary commitments is to do everything we can to help ensure the United States becomes a weather-ready nation. And first and foremost, sort of the foundational underpinning of that commitment is to make sure our observing infrastructure is state-of-the-art, truly second to none. And with GOES-R, we've made a major stride in that direction.
Back live at Space Launch Complex 41 at Cape Canaveral Air Force Station in Florida. T-minus 6 minutes, 34 seconds and counting. Looking at the Atlas V rocket, standing 197 feet tall, or about 20 stories. It weighs more than 700,000 pounds now that it's fully fueled. To lift the Atlas V away from the pad, more than 2.2 million pounds of thrust is produced by the RD-180 engine and 4 Block C strap-on solid rocket boosters.
I'm going to hold off on doing our poll for now.
Roger.
T-minus 6 minutes.
Our next planned built-in hold at T-minus 4 minutes, a little bit more than a minute and a half from now. It's planned to be a 6-minute hold, leading to a liftoff at 5:42 p.m. Eastern Time.
T-minus 5 minutes, 20 seconds.
LC, LD, channel 1.
Go ahead, LD.
We are working a technical issue relative to the launch vehicle, and based on that, we're not going to make the opening of the window. So I want you to delay the call to the spacecraft to go on internal power that's planned for L-10.
Copy. Prop 1, LC.
This is Prop 1.
Roger. Status of fuel fill?
Approximately 25 seconds.
Copy.
Atlas LO2 at flight level.
Roger.
Centaur LO2 at flight level.
Roger.
Centaur LH2 at flight level.
Roger. SYS, start RADAS data acquisition.
Roger.
We're just a couple of seconds away from entering our built-in hold at T-minus 4 minutes.
T-minus 4 minutes in holding. This is a program 6-minute hold.
As you heard, teams are working an anomaly issue. We will not be launching at the beginning of the launch window. We'll stand by for further information.
NSC copies.
Teams have been advised to hold off transferring the GOES-R spacecraft to internal power, an activity that is normally planned for 10 minutes prior to launch.
Timer, go ahead.
Roger, do not release the hold. Initiate the standard protocol of adding 5 minutes as required.
Roger.
And Prop 1, LC?
Yes, we're ready to make that call. Fuel fill sequence is complete.
Roger.
This is Atlas Launch Control. We're in our T-minus 4 minute hold, and as is standard protocol, whenever an anomaly is being worked, the appropriate teams are discussing the issue, and when they've come to a resolution or a recommendation, then they will bring that to the countdown net, at which point we will all learn what the resolution is. At this point, we know we will not be launching at the beginning of the launch window at 5:42 p.m. Eastern Time. We have a 1-hour launch window today that runs to 6:42 p.m., and we'll stand by for further details.
It's configured for launch.
Roger. Davis system camera configured for launch.
Roger.
LC, LD.
Go ahead.
Let's see, based on the time to resolve this potential issue, please use our standard con-op of adjusting the clock in 5-minute increments until we get a good closure plan and pick a T0.
Roger, understand. Timer LC, did you copy? Do not
Roger.
release the hold.
Launch Director Bill Cullen instructing Launch Conductor Doug Lebo to extend the clock. They will be advancing the clock in 5-minute increments as they discuss the issue today. So our next possible launch opportunity is at 5:47 p.m.
All right, this is the LC on Channel 1. All communication switch to Channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC. This is the LC with a terminal count briefing. If a condition exceeds a launch constraint anytime after the terminal count status check, the observer shall announce hold, hold, hold on Channel 1, identify their station, and briefly state the reason for the hold. Team, at this time, we're extending the hold and awaiting a new T0, and we will hold off on performing the terminal count poll until we get a new T0.
Once again, teams are working a launch vehicle issue at this time. We will not be launching at the opening of the launch window, but we do have a 1-hour launch window today that expires at 6:42 p.m. Launch managers will be advancing the new target launch time in 5-minute increments as they talk through the issue. Once again, we remain in our T-minus 4-minute hold, awaiting resolution of a launch vehicle issue. We have about an hour left in the hold. In order to make today's launch window, we must launch by 6:42 p.m. Eastern Time. This is Atlas Launch Control. This is Atlas Launch Control. If you're just joining us, we remain in our T-minus 4-minute hold, awaiting resolution of a launch vehicle issue. So the Atlas V rocket with the GOES-R spacecraft will not be launching as expected at 5:42 p.m. There is a 1-hour launch window today that expires at 6:42 p.m. The launch team is resetting the clock in 5-minute increments as they work through the issue. Our current no earlier than launch time is 5:52 p.m. Eastern. Once again, an issue is being worked on the launch vehicle, and we'll stand by for further details. This is Atlas Launch Control. We remain in our T-minus 4-minute hold as you are watching the Atlas V rocket at Space Launch Complex 41 at Cape Canaveral Air Force Station. Once again, we are in an extended hold because of a technical issue on the launch vehicle. Managers continue to work the issue and reset to the countdown clock for the T0 time in 5-minute increments. Our new no earlier than launch time is 5:57 p.m. Eastern Time. This is Atlas Launch Control. This is Atlas Launch Control. We remain in our hold at T-minus 4 minutes as managers and engineers resolve a launch vehicle issue. The new no earlier than time for liftoff has just been set for 6:02 p.m. Eastern Time, which will leave us with 40 minutes remaining in our launch window. Discussions continue to resolve the issue. Teams from NOAA, NASA, and United Launch Alliance all working toward liftoff today of the Atlas V rocket and NOAA's GOES-R spacecraft. Once again, we are standing by for the resolution of a launch vehicle issue and remain in our hold at T-minus 4 minutes. This is Atlas Launch Control. This is Atlas Launch Control. We remain in our hold at T-minus 4 minutes as launch managers continue to reset the potential T0 time in 5-minute increments as we move through our launch window this evening. They wish to allow at least 10 minutes for the GOES-R spacecraft team to power up the spacecraft and also to accomplish other launch tasks in the remaining time of the hold. This all as they continue to work resolution to a launch vehicle issue that continues to persist. And the new possible earliest T0 time would be 6:07 p.m. Eastern Time. That would leave us with 35 minutes remaining in the hold. We'll continue to provide information as it's available. Once again, though, we are at T-minus 4 minutes and holding. This is Atlas Launch Control.
LOX 2, LC.
LOX 2.
Roger. Have you had to run a reconditioning sequence yet?
Yes, we've done this once.
Roger. Just FYI, we're hoping to get resolution to the issue here shortly, and so keep advised if you come up on a requirement to have to run that again.
Yeah.
This is Atlas Launch Control. Our new no earlier than T0 would be 6:12 p.m. Eastern Time. We remain in our hold at T-minus 4 minutes as the launch team continues to discuss a launch vehicle issue. There are 30 minutes remaining in the launch window today if we were to launch at 6:12 p.m. This is Atlas Launch Control. We continue to await the resolution of a launch vehicle issue and remain in our T-minus 4-minute hold. Launch managers have now chosen the next possible no earlier than T0 time of 6:17 p.m. Eastern Time, which would allow 25 minutes remaining in our launch window, which closes at 6:42 p.m. tonight.
Check channel 1.
Loud and clear.
This is Atlas Launch Control. We remain in our hold at T-minus 4 minutes, and we expect to hear some words here shortly on discussion on the launch vehicle issue.
7 had confirmed that it was a false positive indication. We are fully confident in the Murata valves as installed, and we recommend proceed.
LC copies and concurs. LD?
LD concurs.
And NLM?
NLM concurs.
Roger.
Meanwhile, launch managers have targeted no earlier than T0 of 6:22 p.m. Eastern Time. This is Atlas Launch Control. We remain in our hold at T-minus 4 minutes, but it appears that the team has resolved the technical issue that they've been working and continue to discuss a possible new T0 time, which currently is set up for 6:22 p.m. Eastern Time. Managers are polling their teams to assure that they're ready to pick up the count, and we'll stand by for more information. Should we launch at 6:22 p.m.? That's about 10.5 minutes from now.
LCLD.
Go ahead.
Let's see, do not instruct the spacecraft to go internal. The range is working an issue and needs a little bit more time.
Roger. We will continue to stay in the hold.
Copy that.
And Launch Director Bill Cullen instructing Launch Conductor Doug Lebo to stay in the hold as the Eastern Range works an issue. At our current T0 time of 6:22, we would have 20 minutes remaining in the launch window, which expires at 6:42 p.m. Eastern. This is Atlas Launch Control as we look at various views of the Atlas Centaur configuration on Space Launch Complex 41 at Cape Canaveral Air Force Station in Florida, fueled up and ready for its launch. After a period of time while managers were assessing a possible launch vehicle issue, that appears to have been resolved, and we remain in our hold because of an issue being worked by the Eastern Range, and a new no earlier than T0 time has been set for 6:27 p.m. Eastern Time. This is Atlas Launch Control. T-minus 4 minutes and holding, counting toward a possible T0 time of 6:27 p.m. Teams worked through a launch vehicle issue and appear to have resolved that, and we remain in our hold while the Eastern Range works an issue. Our window expires at 6:42 p.m. this evening.
NSC, LC.
Go ahead, LC.
Roger. Understand spacecraft's been given direction to go to internal power?
That is correct, sir.
Roger.
As managers talk through the remaining time in our launch window this evening, the GOES-R program has been given a go to put the spacecraft on internal power. The new no earlier than liftoff time has been moved 5 minutes additionally, and now is 6:32 p.m. Eastern Time.
LR6, load release. Please put that in work.
Roger. Flight control, LC.
Flight control.
Roger. Load contingency file adjust _06.
Copy. In work.
We're standing by for the resolution by the Eastern Range of an issue that they are working before we can pick up the countdown of this evening's Atlas V rocket with the NASA GOES-R spacecraft.
LC, LD.
Go ahead.
Let's see, based on our situation with the range and giving them the maximum time to resolve their issue, please coordinate a new T0 time of 23:42 Zulu.
Roger. Range coordinator, LC.
RCN1.
Please coordinate a new T0 of 23:42 Zulu.
Copy. 23:42 in work.
And timer, LC.
Go ahead.
Please update the countdown clock for a new T0 of 23:42 Zulu.
Roger, 23:42 in work.
This is Atlas Launch Control, and as you've heard, managers have determined that they will target the end of today's launch window with a projected T0 of 6:42 p.m. to enable the U.S. Air Force Eastern Range time to work through the issue that it has been working. The GOES-R spacecraft has been configured to internal power, and teams are standing by to see if we will be able to lift off yet this evening. But once again, we're now targeting the end of the launch window at 6:42 p.m. Eastern Time. This is Atlas Launch Control.
RC1.
Go ahead.
Roger, this time the T0 of 23:42 is coordinated approved by the range.
Roger. Is the range still not proceeding at this time?
And the range is proceeding. They are go.
Roger. All stations, this is the LC. We have a new T0 of 23:42 Zulu. As indicated on the countdown clock, intent is to perform the poll at L-7 minutes. Go ahead.
Step 1060, a contingency file address to AV069_06 with SGL-CRC of 8923. It has been verified and loaded into the FTINU.
Can you please repeat the CRC?
8923.
Copy 8923. Roger.
This is Atlas Launch Control. The new T0 time of 6:42 p.m. We continue to count down toward that. Teams are conducting polls. Managers are validating that their teams are ready. Our next major milestone will be at L-7 minutes when launch conductor Doug Lebo will poll the final team for the final go to pick up the countdown. That's about 10 minutes away from now as we continue to target the end of today's launch window at 6:42 p.m. Eastern Time.
OSM, LC.
OSM.
Place the SRB ignition S&A switch in the enable position.
SRB ignition enabled.
And OSM, verify the FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
Redline monitor and event table are in the correct configuration for terminal counts.
Roger. Flight control, perform launch on time verification.
Roger. LC flight control.
Go ahead.
Launch on time verified.
Roger. Range coordinator, verify solar radiation acceptable for launch.
Verified.
This is Atlas Launch Control. At T-minus 4 minutes and holding, we are expecting to come out of the hold in 13 minutes, 45 seconds, and counting from now. 9 minutes and 38 seconds remaining in the hold and 13 minutes, 34 seconds remaining until the time of launch. Issues seem to be resolved. Managers are conducting their polls. The launch vehicle is ready to fly, and the GOES-R spacecraft has gone to internal power. This is Atlas Launch Control. About 7.5 minutes remaining in our hold at the T-minus 4-minute mark, as the countdown would proceed to a liftoff at 6:42 p.m. Eastern Time, the end of today's launch window. We're about 4 minutes away from the final poll conducted by launch conductor Doug Lebo, polling the team to pick up the count. This is Atlas Launch Control. We're standing by to pick up the count a little more than 5 minutes from now, leading toward an expected liftoff at 6:42 p.m., pending the final poll that will occur in about 2 minutes. Weather remains go, and the team stand by for the liftoff of the Atlas V and GOES-R satellite.
All steps are complete prior to the status check.
All technical steps are complete prior to the status check, coming up in about 1 minute and 40 seconds. This is Atlas Launch Control. In just a few moments, Launch Conductor Doug Lebo will pull the team for the final go to pick up the countdown. 27 engineers and managers will be pulled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, the NOAA GOES-R spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Standing by for the poll, we'll listen in as Launch Conductor Doug Lebo performs the final polling of his team.
Status checks proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
COM.
Go.
Timer.
Go.
GCQ.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
Launch director is go, and you have permission to launch.
Proceeding with the count. Timer T0 is planned for 23:42 Zulu. Set count to start at 23:38 Zulu.
Roger. T0 is set for 23:42 Zulu. Count will start at 23:38 Zulu. So the polling is complete, and we have a go for launch at 6:42 p.m. Eastern Time. The count will resume in about a minute 35 seconds. And once resumed, from T-minus 4 minutes until launch, you'll be listening to Launch Conductor Doug Lebo and his team performing the final steps in the countdown procedure.
Count.
You'll hear the team confirm securing of Atlas liquid oxygen topping, followed by the call to transfer the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the ground launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activity. Then at T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, the Atlas tanks will be verified at flight pressure, followed with verification of the Centaur tank pressures. A final status check of Atlas, Centaur, and GOES-R readiness will be conducted at T-minus 25 seconds. And then seconds before liftoff, the RD-180 engine ignites, performs a health check, followed by ignition to lift the Atlas V and GOES-R off the launch pad. After liftoff, you'll be hearing the voice of United Launch Alliance's Marty Malinowski providing launch vehicle ascent data. We're standing by to pick up the count.
Counting. 3, 2, 1, mark.
And we're at T-minus 4 minutes and counting.
Was enabled.
We're proceeding toward a 6:42 p.m. liftoff. NOAA's GOES-R satellite is confirmed on internal power. The Atlas will be heading nearly due east, 100.7 degrees, and will reach Mach 1, or the speed of sound, about 35 seconds after liftoff. T-minus 3 minutes, 16 seconds and counting.
Three minutes.
Securing LO2 topping.
Atlas tanks to flight pressure.
2 minutes, 50 seconds.
Just internal.
Two minutes, 35 seconds and counting. Everything is go. Just a few seconds away from transferring Atlas and Centaur power to internal.
One minute, 59.
Vehicle internal.
1:55.
Launch sequencer start.
1:50.
Securing Centaur LO2.
1:40.
Launch enabled.
1:37.
FTS armed.
T-minus 1 minute, 30 seconds and counting.
$120.
OCUs armed.
FCS count started.
1:15.
Reduce ECS for launch.
Roger.
1:10.
Standing by for the final range status report.
1 minute.
Rock, report range status.
Range green.
Range is green and we are go for launch at 6:42 p.m. 50 seconds away from liftoff.
$40 seconds.
Stable at step 3.
T-minus 30 seconds and counting.
28.
ECS reduced for launch.
Roger.
25.
Status check.
Go Atlas. Go Centaur.
Go goes R.
15 seconds and counting. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of NOAA's GOES-R, America's most advanced weather eye in the sky, elevating environmental intelligence to new heights and saving lives.
Has gone to close-up control. Engine response looks good. Now flying the zero angle attack phase of flight. Body rates look good. Booster has throttled down as scheduled. Response looks good. Roll program is complete. Body rates controlling down the middle.
Listening to the voice of Marty Malinowski.
Mach 1.
Standing by to pass
Max
through
Q.
Max Q. This is the maximum aerodynamic pressure area. When mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by the atmosphere. NASA's Atlas V
Booster has begun throttling back up. Right on
and
engine response looks good.
GOES-R spacecraft continue into flight. The United Launch Alliance Atlas booster doing its job. One minute, 50 seconds into flight, the first two solid rocket boosters will be jettisoned, followed about a second and a half later by boosters 3 and 4.
Coming up on SRB jettison, and we have the first pair and the second pair. Looks like a good separation. Now flying. now pressurizing the flight level. Signatures look good.
Three minutes into flight, about 30 seconds away from jettison of the payload fairing, which has protected NOAA's GOES-R during its flight through the atmosphere.
And we have begun throttling to 2.5 Gs in preparation for payload fairing jettison. Booster engine signatures look good. And we have payload fairing jettison. Looks like a good jettison.
3 minutes, 42 seconds into flight.
And we have throttled back up. Next, approaching our 4.6 G constant throttle. And we have begun to throttle. Boost phase cooldown is underway.
About 30 seconds away from booster engine cutoff. Standing by for booster engine cutoff.
And we have BICO. Engine shutdown looks good.
Standing by in about 6 seconds for the Centaur's second stage to separate from the booster.
We have indication of AC sep.
Good separation.
And LOX pre-start underway. GN2 purge firing is as well. And we have ignition and full thrust on the RL-10.
This Centaur single RL-10C engine burn, producing 22,900 pounds of thrust, will burn for just under 8 minutes.
OSM. Beginning to see our RCS thermal conditioning firings.
OSM, go ahead. Adjust security roadblocks for pad access control. Roger. Readiness poll for pad.
RL-10 performance looks good. Chamber pressures, fuel injectors, fuel venturi pressure, box pump discharge, all within band.
Ready. Atlas pneumatics. Ready. Centaur propulsion.
Ready.
Centaur pneumatics. Ready. OSM. Ready.
Centaur PU is now in closed loop operation, except it is still requesting a slightly oxidizer-rich condition. We do have indication of the booster stage performance at this point, slightly above nominal. RCS line temperatures continue to warm towards bottle temperatures. RL-10 performance continues to look good. Tank pressures are stable. Sport bottle pressures look good. Our body rates continue to look good, controlling down the middle. Current altitude 139 miles, downrange distance 888 miles, current velocity 14,209 miles per hour. Coming up on the format change. And we did have a slight drop out in data, but data has resumed. All signatures look good. Centaur continues to look like it's making good progress down the middle of the range track. Current altitude 147 miles, downrange distance 1,133, current velocity 14,715.
Looking at a live track of the Atlas Centaur GOES-R rocket as they transit across the Atlantic Ocean. The Centaur is powering the GOES-R satellite.
Controlling near nominal MR.
This flight will continue on for more than 3 hours as the Centaur engine will have a total of 3 burns before spacecraft separation later tonight.
Looks good. Body rates are still controlling down the middle. Centaur currently is flying at an altitude of 150 miles, downrange distance 1,389, current velocity 15,290 miles per hour.
Just a little more than 3 minutes remaining in this first of 3 Centaur burns.
Hydrazine line temperatures have warmed to bottle temperatures. That system looks very good. Still seeing our normal thermal conditioning firings. And Centaur PU is now controlling near nominal, having worked off the excess oxidizer.
Ten minutes after liftoff, you're listening to the voice of Marty Malinowski describe the progress of Centaur.
All systems are operating well. Approximately 2 minutes remaining in this first burn. Centaur PU continues to control near nominal. Engine response looks good. Chamber pressures, LOX pump discharge, and fuel venturi all within band. Body rates controlling down the middle. LOX and fuel tank pressures are stable. Storage bottle pressures look good. Batteries are as well.
Managers overseeing the launch and flight, keeping track of the progress, standing by for the first main engine cutoff of Centaur in a little bit under a minute.
Continues to make good progress downrange. And we have IAP vanish. Centaur is now orbital. And we have MECO. Looks like a good shutdown. 4S motors around. CRDs have been safed.
"12 minutes, 39 seconds after launch, a good main engine cutoff. Another Centaur burn will follow after about a 9.5-minute coast period. That burn is scheduled for about 22 minutes mission elapsed time.
Centaur fuel tank has been vented down and pressures are now stable. Storage bottle pressures look good. Batteries are stable.
Everything is off to a good start to deliver NOAA's GOES-R satellite to its planned place in space with a successful first stage Atlas burn and the first Centaur burn. 2 more remaining Centaur burns this evening. The next one scheduled for about 6:04 p.m. Eastern Time. I'm sorry, 7:04 p.m. Eastern Time.
And we now have the MECO 1 plus 3 second open, comparing the actual parameters against the pre-flight nominal, shows good performance. Centaur is where we expected. Currently coasting at an altitude of 125 miles, downrange distance is 2,910 miles. Current velocity 17,614 miles per hour. Centaur fuel tank has been vented down again as expected. Pressures are now stable. Centaur still settling with 4S motors. Tank pressures are stable. Storage bottle pressures look good. And Centaur has begun to ramp to a 60% 4S duty cycle. Signatures look good.
Just about 4 minutes away from the restart of the Centaur second stage engine. A burn known as MES2 for Centaur main engine start 2.
And Centaur has achieved 60% 4S duty cycle. Signatures look good.
Watching data-driven animation of the United Launch Alliance Centaur with NOAA's GOES-R spacecraft exposed to space now that the payload fairing has been jettisoned. Everything is proceeding normally. The Centaur is coasting along, expected to restart for the second of 3 burns.
Stable as we settle at a 60% duty cycle on the 4S motors, currently coasting at an altitude of 107 miles, downrange distance 428 miles, velocity, 4,298 miles, velocity 17,692. Centaur has now gone to full 100% 4S settling as we begin the Remes 2 start sequence. Tank pressures are being increased.
Just about a minute away from the Centaur second stage engine burn number 2. It'll be about a 5.5 minute burn.
We have fuel pre-start. We now have blocks pre-start. We have ignition and full thrust on the RL-10.
Everything proceeding normally with the second stage engine second burn.
Discharge and fuel venturi all look good. EU is requesting an oxidizer-rich condition. Hydrazine line temperatures are stable at bottle temperature. And Centaur PU has come off the MOX stop. Now controlling slightly oxidizer-rich, but more towards nominal. Current altitude, 102 miles. Downrange distance, 5,225 miles. Current velocity 18,362 miles per hour. Centaur body rates look good. Tank pressures, throttle pressures, and batteries are all stable. VIVO is now controlling at nominal MR. Engine response looks good. Continue to see our thermal conditioning firing on the RCS. Signatures are good. RL10 continues to perform well. Chamber pressures, lax pump discharge, and venturi all in expected bands for the set MR. RCS continues its thermal conditioning firings. Approximately 2 minutes remain in this second burn. All systems continue to look very good. RL10 is performing well. Fuse still burning off somewhat oxidizer rich. Body rates controlling down the middle. Tank pressures look good. Batteries do as well.
Everything going well with the second Centaur burn. We're expecting engine cutoff at about 7:09 p.m. Eastern Time, at which point the rocket and its NOAA GOES-R spacecraft will go into an extended coast phase with the next burn scheduled for 10:09 p.m. At the conclusion of this burn, we will be handing over NASA television coverage to cover the hatch opening ceremony aboard the International Space Station, and then we will rejoin our GOES-R launch coverage at 10 p.m. Eastern Time.
Performing well.
Everything's going well on the burn?
Being controlled near nominal.
About 30 seconds left in the Centaur main engine burn.
RL10 continues to perform well. Approximately 30 seconds to MECO. And we have MECO.
And with a successful main engine cutoff, we will turn over NASA television to the Johnson Space Center for coverage of activities aboard the International Space Station, and we will rejoin you at 10 p.m. Eastern Time.
This is Mission Control Koryov. For those just joining us on the public channel of NASA television, we have been reporting on the media channel for the past few minutes that the leak checks are continuing at the docking interface between the newly arrived Soyuz MSO-3 vehicle with Peggy Whitson, Oleg Novitsky, and Thomas Pesquet aboard. So far, so good with all of those leak checks. They're in the final stages of that activity. Then we'll see the pressurization of the passageway between the Soyuz and the International Space Station at that docking interface. That will be the precursor to the opening of the hatch between Soyuz and Rosviet, enabling Whitson, Pesquet, and Novitsky to enter their orbital home for the next several months. Mission Control Koryov, Peggy Whitson, Oleg Novitsky, and Thomas Pesquet are just minutes away from entering the International Space Station. With us in the early morning hours of Sunday morning here in Koryov. We're honored to be joined by NASA Administrator Charles Bolden, who was down in Baikonur 2 days ago for the launch of this crew, and who's with us this morning to watch them expand the Expedition 50 crew. Charlie, thanks for joining us with the docking having been completed and with this trio now preparing to enter the station on this, the 18th anniversary of the launch of the first module of the complex. How significant is that in your mind, and how far has the facility come in almost 2 decades?
I think it's an incredible accomplishment that's occurred over the last decade and a half plus, Rob. I think, as you know, it's 16 years running now of continuous occupancy of the International Space Station, which speaks volumes about the value of international cooperation, and it speaks volumes about our international partnerships that we have.
What do you think has been the major accomplishment of the International Space Station over the past 18 years? There have been many high marks, but in your mind, what is the major accomplishment?
I think the biggest thing is the principal accomplishment that causes me to always call for ISS to be considered for the Nobel Peace Prize, and that is the fact that we've demonstrated that international collaboration in people from various cultures and countries and ways of thinking focused on a single mission, what can be accomplished for the good of the world when that happens. I think we on the International Space Station are a model for the rest of the world to follow.
Where do you think we can take this bond, this international cooperation, in terms of future exploration?
You know, I think it's endless or boundless what we can do. And another example I'd give you, I was reviewing my last day and a half, 2 days, a successful Soyuz launch from Baikonur, carrying my dear friend Peggy Whitson. A Soyuz rendezvous and docking just minutes ago tonight. GOES-R launch for our partners NOAA from the Cape Canaveral Air Force Station, Kennedy Space Center Complex. All of that trying to do things that make life better for people here on this planet, while also helping us to chart our course to distances far away from low Earth orbit. I think that's all very, very important. If I want to point out a thing of value of international cooperation, I think it's the bonds of friendship that are formed by what we do. Just 23 years ago, this coming February, 3 people who never knew each other before, Peggy Whitson, Charlie Bolden, and Sergei Krikalev, came together as members of the team of STS-60, the first joint Russian-American shuttle mission. At that time, Peggy was one of our principal investigators, and when we launched, she witnessed Sergei and me burst into space. And I thought it was just phenomenal yesterday morning, for Sergey and me to be able to carry her or walk with her to the spacecraft, see her get aboard, and then see her lift off. And I'm just looking forward to having an opportunity to talk to her for a few minutes when the hatches open tonight. She is an absolutely incredible role model for women everywhere in the world, and I could not be more proud than to be able to call her a friend and colleague.
And Charlie, of course, she will break Jeff Williams' record for most days in space by a U.S. astronaut if all goes as planned on April 24th of next year. In the meantime, a lot of work lies ahead. What do you think about this time, one of the busiest periods in station history?
I tell you, there are a lot of challenges ahead. However, I could not feel more confident about the team that's in place that is carrying this out. If anybody ever wanted evidence of what can be done when people are focused on a single mission, and right now, that long-range mission is to get humans to Mars. There is a conglomeration of multiple nations in the world who have come together and have said the International Space Station is going to be our toehold on the rest of the universe, and that we're going to use it to the best of our ability, maximize its utilization, to learn as much as we can about the human body and about technologies necessary to get humans to Mars. And that's what we're doing. And I think as long as we stay focused as an international collaborative, the political and diplomatic changes and trauma that goes on down here on Earth, I think we can survive that, because as we have demonstrated, whether you're looking at incursions by one of our partners into other countries, that has not deterred or slowed the work that we've done on the International Space Station. And I look to that to be the case for years to come.
And finally, as we turn the page on this calendar year, how do we see the state of the agency as NASA prepares to enter a new era of human spaceflight, as well as an eye on breaking out of low Earth orbit to travel to deep space and beyond?
I have said to our employees a number of times, and when I talk about to our family, to the NASA family, which includes the contractors and our international partners, I've said it several times, and I'll say it here. The state of NASA today is strong. It's stronger than it's ever been, I believe, and I think it is that way because of the bonds and the partnerships that we form, not just with international partners, but now with entrepreneurial, academic, commercial partners, all of whom are pulling in the same direction with the goal of eventually getting humans to Mars. We're all necessary. It is going to be critical for our commercial partners to be able to step in and do the work of providing access to low Earth orbit, gradually helping with providing habitats and laboratory facilities in low Earth orbit. And then as we migrate out in the decade of the 20s to cislunar space and the proving ground as a next step to Mars, having the commercial and entrepreneurial partners come along behind us and help us to establish ways, I would hope, to get to the lunar surface while we're en route to Mars, because that's something that commercial and entrepreneurial entities have talked about for decades now. We have the capability to make them successful or to facilitate their success. I think it's now up to them to take advantage of the opportunity that we present and to actually begin to produce vehicles that will get humans to the lunar surface while we work with Orion and SLS and our other international partner vehicles to get humans to the surface of Mars.
NASA Administrator Charles Bolden with us this morning here at the Russian Mission Control Center. Charlie, thanks so much for joining us, and safe travels back to Washington.
Rob, thank you. And I will, since I'm talking about old friendships, you and I were just reminiscing. I remember the Rob Navias from UPI, who was a big friend of the space program and a fan, and then eventually became a member of the Prime family when you moved over and became a part of us as a NASA employee. So it's been my incredible pleasure to work with you from long, long days ago, and I look forward to many more days. Take care.
Back at you, Charlie. Thanks so much. It has been a wonderful journey and many more steps yet to come. Thanks so much.
Just like you were opening them the first time around, do you understand what I'm saying? Copy all. Copy and concur. We're on our way to open the hatch. You are go. No camera, though. Copy. No camera.
here at the Russian Mission Control Center. We are expecting the crew on the station side of the docking interface between the International Space Station and the Rosviet module to open their side of the hatch interface just a short time from now. And we'll stand by, of course, for the opening of the Soyuz hatch. We hope that will occur once we have acquired our downlink television capability through the tracking and data relay satellite system about 14 minutes from now. So we'll keep you posted as we go along. The leak checks are now complete. The vestibule has been pressurized between Rosviet and the International Space Station. And again, we're standing by for the opening of the station hatch on the station side of the docking interface.
Понял.
МТС по Москве, ВСГ-2 для Андрея или Сергея. Station Moscow, space to ground 1, space to ground 2 for Andrei or Sergey. Go ahead.
Сергей, я немного
Hey, Sergey.
054 это конец.
I was wrong.
029.
0029 is the is when we're going to get stable comm. 0054 is when we're going to go LOS. So by half past the hour, you should be ready for the TV or the PO event, basically. Copy. Yeah, 54 is when we're going to go LOS, actually. So I misspoke entirely during a previous call. Copy all.
This is Mission Control Korolov as you look at a view from the balcony camera overlooking the cavernous flight control room, and now an external view from cameras on the International Space Station. We're standing by for the opening of the hatches between the two vehicles.
Station Moscow, space to ground 2, regarding the hatch opening steps. Go ahead. Sergey, can you status us on the hatch opening procedure? Hatch is open. Oh, hatch is open then. You bet.
Guys back, in Moscow.
Copy.
Go ahead.
Well, in that case, we're just standing by for the
Oleg.
Soyuz
We have
side
only
hatches to be open. Well, there's
3
about
minutes.
4 minutes remaining on the clock.
Actually,
Yeah, they're finishing their
already
equalization steps.
the hatch on their side.
Don't
so
turn
you
anything
should
on by way of
proceed with
cameras. Just
with
wait
your
for
steps for
a
our
final
go.
go on that. You bet. Standing by. Not doing anything.
And you are listening to that conversation between Russian flight controllers here in Korolyov and the crew inside the International Space Station, most notably Andrei Borisenko, as we are standing by for the final few steps of the pressure equalization in the small passageway between the two craft, the Soyuz, that arrived for a docking at 3:58 p.m. Central Time, 4:58 p.m. Eastern Time. Within minutes after that, hooks closed from the Soyuz on the Rossviet module's docking system to form a hard mate. The past couple of hours or so have been spent with leak checks to make sure we have an airtight seal between the two vehicles. That has been completed, and we're just waiting for our downlink video and audio capability from the station to lock up before we see the opening of the hatch and the arrival on board the station of Peggy Whitson, Oleg Novitsky, and Toma Pesquet.
1 minute. You should deactivate the hard line,
Я понял. Спасибо.
the relay com, and you translate into the station. Guys, since we won't get a chance to talk after the hatches are open, I just wanted to tell you what you're supposed to do after the hatches are open. All right? I am ready. And I'm ready to write it down. All right, so after you open the hatches, please deactivate all com assets in the Soyuz. The page is page 96 in the final approach book. So you have to deactivate the duplex radio.
As we listen to the instructions about the post-hatch opening deconfiguration and shutdown of the Soyuz systems once it is placed on International Space Station power for the duration of its stay at the Rossviet module, you're looking at a great picture of the orbital ATK Cygnus cargo craft that arrived on the station about 4 weeks ago, delivering several tons of supplies and experiments to the crew members on the station. You can see the Canadarm2 robotic arm grappled onto the grapple fixture on the Cygnus. It will be detached from the Earth-facing port of the Unity module of the International Space Station early Monday morning, and then with Shane Kimbrough at the controls of the station's robotic arm from the cupola, backed up by European Space Agency astronaut Thomas Pesquet, they are going to release the Cygnus from the grasp of the Canadarm2 at 7:20 a.m. Central Time Monday morning. It will drift to a distance away from the International Space Station for its deorbit and entry back into the Earth's atmosphere on November 27th, where it will burn up harmlessly over the Pacific Ocean. And now you can see the passageway in the Rossviet module looking at the hatch of the Soyuz MSO-3 as we stand by for Andrei Borisenko and his crewmates, Shane Kimbrough, the station commander, and Sergei Ryzhikov to begin the process of standing by as the Soyuz hatch is open from the inside of the spacecraft that docked to the International Space Station, an automated docking that occurred perfectly without any issues whatsoever at 3:58 p.m. Central Time, 4:58 p.m. Eastern Time.
We need to move
As we said before, Andrew, on multiple occasions, that's exactly the expectation. Have you already downlinked the docking video? Yeah, we already put that on OC.
Check the MV once again.
Okay, excellent.
How is it going?
795,
and it is slowly...
Hey, Vladimir, should we rotate the camera by 90 degrees, or is this good? Okay, please don't. Just leave it as is. It's good. Yeah, with the... with the deck being, you know, down below and the overhead being up where the ceiling should be, please don't change that.
We've been huffing and puffing in here.
Балкон весь полный, так что сейчас картинка будет на большом экране уже.
Right, the folks on the balcony are jumping at the bit. You know, the balcony is full, so everybody's excited. Please don't move the camera. Not moving the camera.
Чуть-чуть есть. А так больше нигде нету. Нигде, да?
Nowhere.
Везде сухо.
Dry everywhere. It's good.
On the Soyuz side of that hatch, just behind that hatch, Oleg Novitsky is in the final few steps of preparing for the opening of that hatch. That will enable he, Peggy Whitson, and Thomas Pesquet to float inside the International Space Station. Once inside, they will move to the Zvezda service module in the familiar setting, along with Kimbrough, Ryzhikov, and Borisenko, to accept congratulatory calls from VIPs, friends and family members gathered on the balcony here in the Russian Mission Control Center. We're just minutes away from the opening of the hatch.
Олег, подскажи давление
Oleg, what's the current pressure on the MP? We're just being very curious.
777.
777.
Неплохо.
Not too bad.
Наверное.
I guess so.
Мы тебя видим уже на большом экране изображение. Помахай.
Yeah, we can see you on the big screen. Please wave back.
Надо было помахать?
Did you need me to wave?
Да ладно, ну уже ушел с кадра.
It's too late now that you're out of the frame. Don't bother waving.
И балкон.
Yeah, it's because all the folks on the balcony are watching the big screen and you on the big screen, so we wanted you to wave. Don't have to bother with that now. Mission Control Korolyov standing by for the three crew members who have been aboard the International Space Station for the past month, that being Shane Kimbrough, the station commander from NASA, along with his Russian cosmonaut colleagues Sergei Ryzhikov and Andrei Borisenko. They'll be right at that hatchway, standing by for the opening of the hatch by Oleg Novitsky, who is just completing a few steps before he opens the hatch to allow him, as well as his crewmates Peggy Whitson and Thomas Pesquet from the European Space Agency, to float inside to be greeted and then to move in the passageway to the Zvezda service module to accept congratulatory calls from a crowd that is gathered on the balcony of the Russian Mission Control Center.
And you can see on the balcony here in the Russian Mission Control Center, in the middle of your screen, NASA Administrator Charles Bolden in the tan jacket, and to the left is Sergei Krikalev, the famed Russian cosmonaut who flew with Bolden in 1994 on the STS-60 mission, which Bolden commanded, a shuttle mission that featured one of the first times that a Russian cosmonaut flew on the shuttle as a precursor to activity involved with the Shuttle Mir program that segued into the International Space Station program. Also on the balcony is David Parker from the European Space Agency, their head of human spaceflight. They'll all be getting on the phone to greet the crew members who will arrive on board the International Space Station just momentarily once the hatches are open.
Station Moscow, space to ground 2. Go ahead.
What it does.
Hey, Andrew, they're at 770 for pressure. I believe they're about to start opening the hatch. Expecting your assistance with that. Not now.
Well, it's going down
Just
a little
give you a heads up.
It's 770
Okay.
sharp.
Stand by for now.
Well, so we're standing by. We are.
Вы считали, сколько раз вода сработала за
Guys, have you counted how many times you got the water
Сначала считали, потом сбились.
alarm
Срабатываться, не знаю.
go off? Well,
Может, вы какой-нибудь рекорд?
we've been counting at first, but then we just lost count.
Я думал,
I guess you set a record for like water alarm activation.
Сейчас вот нашел
Right.
капельку на КР-1.
That's interesting because we found a tiny drop on KR-1. But when we checked KR-1 during orbital flight, we did not see any water. It was dry.
Или вся батарея внутри.
Well, maybe something with a gas analyzer.
Так, ну вот минута
All right.
прошла, 770 стоит.
6
Я засекал.
770. 1 minute down. It's still 770. I was watching the clock.
Go ahead.
All right.
Space to ground 2, Andre.
After we hit 0339,
Hey,
close
Nikolai.
the KKT, open
Are you getting the audio from the camera mic?
So I
No, not
have
yet,
literally
not
half a minute
yet.
to say goodbye to you.
Copy.
Guys, I am so happy that you got
You should be
station
soon.
safe and sound. It was
As
a
long as you go
successful
space to
flight.
ground 1.
Well, we are.
Yep, we
Even
understand that
more
we're going to be
glad.
space to ground 1 for the
And
actual.
guys, it's been a pleasure to be working with you. Everything went nominally, and let's hope it stays this way for the rest of your mission.
В этом твоя заслуга.
Well, it's all,
Самую малость разве что. Так, и напомни,
we can blame you for that.
УПЛ на планшет.
Right, on the,
Здорово. Такого еще не было, будет любопытно посмотреть.
just,
Если вам удобно, Николай.
could you please check the PPL on the tablets, but if it's too much to ask, guys, don't worry.
Заканчиваем. Да, закончил.
Toma, don't forget, I won't.
Да, 39 минут.
39 minutes. The pressure is
770 ровно стоит на месте.
770.
Закрываем ККТ.
We're closing the KKT.
Закрыт.
Closed.
Закрываем КВД.
Closing KVD.
Закрыт.
Closed.
Принял.
This is Mission Control Korolyov. You just heard a brief conversation between the off-going Soyuz shift flight director here at the Russian Control Center, saying words of congratulations to the Soyuz commander, Oleg Novitsky, who was in the center seat in the descent module of the Soyuz, watching over all of the automated engine firings and the approach of the Soyuz for its docking to the Rossviet module that occurred not quite 3 hours ago. And now we see Andrei Borisenko of the Expedition 50 crew as we are standing by for hatch opening.
О,
There you go.
командира.
There we go.
And the Soyuz hatches opened at 6:40 p.m. Central Time, 7:40 p.m. Eastern Time, standing by for the entrance, for the newly arrived crew members into the International Space Station. Oleg Novitsky, the Soyuz commander, first inside on this, the 18th anniversary of the launching of the first element, the Zarya module of the International Space Station. Thomas Pesquet of the European Space Agency now inside, being greeted by his new crewmates. And Peggy Whitson beginning her third long duration stay on board the International Outpost.
MRM1 up, move on to MRM2, meaning Space Service Module.
The crew members now will make their way into the Zvezda Service Module. Again, all the crew members are now on board. Expedition 50 is a 6-person crew.
Shut down the cameras and move on to the Service Module. We'll take care of all the switching that is required to be done, and we'll pick it up in the Service Module by the time you guys have gathered there, and all our steps are complete. Copy, on our way.
Now inside the Zvezda Service Module, Oleg Novitsky and Thomas Pesquet awaiting the other crew members to gather into their positions. They'll don headsets and will accept the congratulatory calls from the dignitaries gathered on the balcony here in the Russian Mission Control Center. Again, the hatch opening occurring at 6:40 p.m. Central Time, 7:40 p.m. Eastern Time.
One thing though, guys, can you tilt the camera down just a tad? Or leave it like that, whatever.
Руководство по Москве. Андрей.
SMCC Moscow, Andrei.
Вот так достаточно.
Yes, I think this looks good.
Да, хорошо, принято.
Okay, copy.
Все уже зажали.
Сейчас мы...
Everybody's waiting.
Да,
You can
понятно.
start.
Сейчас у нас
Okay,
все члены
understand.
экипажа подойдут, и мы
We're
начнем.
waiting for all the crew members to join us, and then we can start.
Я понял. Ждем всех членов.
Understand, we're going to wait for all crew members.
As the crew members continue to gather in the Zvezda service module, they'll all be there just a moment or two from now. Once again, leaning over the balcony for a closer look, Sergei Krikalev, sitting next to his former shuttle commander, Charlie Bolden, the NASA administrator, here on the balcony of the Russian Mission Control Center, as we stand by for congratulatory calls from them, as well as family and friends who are gathered here in the early morning hours of this Sunday morning.
That's sufficient. MCC Moscow, we're ready. Let's proceed.
Ребята, как нас слышите?
Guys, how do you read us?
Хорошо слышал.
We read you loud and clear. How else?
Хорошо слышим.
We read you loud and clear, and we can see you. Please have a good video. Guys, this is Sergei Krikalev speaking. I'm glad to see you in good health and in a good mood. Congratulations to the arriving crew. First part of your flight has gone well. Good docking, and you're on board of the station. And congratulations to the guys who were waiting for you, who you're joining now. We're wishing you to complete good work, and I'm going to pass the microphone to the next speaker.
This is Charlie Bolden from NASA, and I just joined Sergei and all the crew here, and congratulating you on finally being there on station. I know it's really special. Tomorrow you've got a huge crowd down here, so don't screw it up. And Peggy, I just wanted to say one thing special to you. You know, as you reminded us, 23 years ago in February, as my mentor, you watched this guy sitting next to me, Sergei Krikalev, and me go off into space, and we wanted to do well for you. We were very proud to be in Baikonur, walk you to the vehicle, and then watch you go off into space. And now watching you, we could not be more proud. So all three of you, all six of you actually, have a great time in the months ahead. We're all proud of you.
Hello, everyone.
Thanks so much, Charlie. We're really happy to be here.
Félicitations à vous, Thomas. I convey the congratulations and the greetings of Jan Werner, the Director General of the European Space Agency. He is watching you from Paris. You're the first ESA astronaut, French nationality, to go to the ISS since 2008. You're the first to do it in the era of Twitter, and I know you're going to excite and inspire many young people, so good luck with your work, good luck with the science, and I'd love to know what the flight was like compared to your expectations, compared to flying on Air France.
Thanks, Dave. We'll do our best to get a lot more done. And
Peggy, congratulations, Lionel. Congratulations, Peggy. Thomas, quelques mots en français, c'est Lionel qui te parle. Bonjour. Je sais qu'il y a eu de très nombreux Français qui ont assisté à votre magnifique lancement. C'était magnifique. Partout dans la France, des gens sont mobilisés pour voir ce lancement. C'était superbe. Pour sûr, ils sont encore très nombreux ce soir à regarder votre arrivée dans la station. Et c'est en leur nom à tous que je veux tout simplement te souhaiter une excellente mission, un bon vol. Et profitez-en bien. Tu sais que le CNES et le CADMOS est avec toi et derrière toi. Bon vol.
merci Lionel, merci à tous les gens qui ont regardé, merci au CNES, au CADMOS, et puis on va faire de notre mieux pour avoir le plus de résultats possible en 6 mois.
Oleg, well, tell us how you were flying, how you were docking, what are your impressions after the long absence on board of the station? We're very happy. Well, the entire process of the approach at the in close range, yes, we were nervous. Yes, we saw this process. We'll look at what was going on, but the automatics worked well, so we're very happy for you. Peggy, congratulations to you on your one more stay on board of the station. Previous flight of mine was right after your increment, and I'm very glad to see that you keep flying and you continue to make your contribution to the development of space exploration. Thank you. We would like to give an opportunity to the families to talk to you. They're here with us in Mission Control. They're glad to see you, and I'm going to give the microphone to your families. Thank you. Hello? Oleg, dear, hello, this is Julia. Hi. Hello. Peggy and Tamar, hello. Hello to everyone. Hello, Julia. How was your flight? Oleg? Oleg, do you hear me? I hear you now. We don't have the video. We'll get it in about 20 seconds.
This is a brief handover between satellites on the tracking and data relay satellite system. We'll be reacquiring communications just a few seconds from now.
Moscow? Do you hear us? Yes, we hear you. Oleg, how was your flight? It was pretty good. Just 2 days of a flight, and then we are on board the station. We're here. There are a lot of people here. We were watching your docking live. Rita fell asleep about 3 hours ago, and she was also waiting for you to dock. Poor child. All friends and family members are asking, where is your toy set of crew members? Why didn't we see it? It's guarding our vehicle while we're here. All the cargo items are still in there. Okay, I'm going to let Yana talk to you now. Hello. Hello, Dad. How are you? How are you? Did you cry much? No crying at all. Well, I was hoping someone would cry. Well, we were all worried, of course, but we were being brave. Good job. That's why everything worked out very well. Well, you see, you all look much better than the first time around. Well, this time I'm used to it, you see. Did you fly well? Was everything okay? Yes, everything was well. It was great. We're in the large volume compartment, and so we're stretching our legs. Well, we're missing you already. Well, now you have to wait. Okay, will do. I'll let Grandma talk to you. Okay, let's talk to Grandma. Dear grandson, hello. Hello, my dear. Hello, Grandma. We're congratulating you and your entire crew with the launch, with docking, and everything went nominal. We're very glad. You have a wonderful crew. We were listening to the press conference. Answers to questions were great. And we, the Earthlings, need to follow your example. We need to all love each other. God give you good health to you and your crew and your colleagues. We're hoping you will always be so such a well-built crew, friends to each other. Every success, and we're wishing you to accomplish all the goals that were set for your crew. We have a lot of people waiting for their turn here, so I'm going to pass the mic to someone. And we love you very much, and we already started countdown to your return. Thank you very much from the entire crew.
Hello Thomas, c'est Anne. On est tous là avec les amis et la famille. J'ai du mal à croire que je te parle et que tu es en orbite à la station. C'est super de vous voir tous enfin arriver. On a vécu un moment incroyable au moment du décollage, c'était magnifique. On est tous très heureux de te voir et on espère que c'était pas trop long. Pour moi, 2 jours, c'était très long avant de pouvoir te parler et on espère que tu vas bien.
Ouais, ça va très bien. Le décollage, ça a dû être spectaculaire pour vous. C'était spectaculaire pour nous aussi, mais un peu moins, parce que de l'intérieur, ça ressemble plus à ce qu'on a vécu au simulateur. 2 jours, non, c'est passé super vite. On a eu beaucoup de boulot. On a aussi pas mal dormi, parce qu'on était fatigués. Et puis, tout s'enchaînait très vite. Les manœuvres orbitales, la phase de rendez-vous. Et puis voilà, on y arrive. J'ai un peu du mal à y croire moi-même, mais apparemment, c'est pour du vrai. Donc on a hâte de se mettre au travail. Et puis on est super contents.
Allô Thomas, c'est maman. Je suis très fière de te savoir là-bas. Je suis très heureuse de vous voir tous. Je vous souhaite un bon séjour là-haut. de belles expériences, que tout se passe très bien pour vous. Ça a été un spectacle inoubliable de vous voir décoller l'autre jour à Baïkonour. Et j'ai de très belles pensées pour vous tous les 6 que je vois en ce moment à l'écran.
Merci maman, on a une super équipe, tout va bien se passer, faut pas s'inquiéter et puis voilà, je donnerai des nouvelles régulièrement et puis dans 6 mois l'atterrissage on le fera moins spectaculaire mais aussi efficace.
Et bon, c'est ton papa. Donc aujourd'hui, en attendant le docking, on a visité Moscou avec une Nathalie comme dans la chanson de Gilbert Bécaud. C'était Anne et elle a assuré comme d'habitude. On a eu aussi 2 autres Nathalie pour visiter le musée des cosmonautes. Antoine s'est débrouillé comme un chef pour nous guider dans le métro. Et Aurélien s'est éclaté devant tous les satellites. Ça lui a rappelé l'époque de Super-Héros où vous faisiez les conférences et les visites dans la Cité de l'Espace. Je terminerai par une question. Je voulais juste savoir si tout ce qui s'est passé depuis 2 jours correspond à ce que tu as appris dans les entraînements. Est-ce qu'il y a eu des sensations nouvelles? Est-ce que quelque chose t'a étonné depuis le départ?
Non, mais je suis content que tout se passe bien pour vous. Non, ça ressemble beaucoup à ce qu'on a fait à l'entraînement, et c'est en ça que l'entraînement est bien fait. La seule chose, c'est que ça dure plus longtemps, ça dure 2 jours, et puis quand on regarde par la fenêtre, le paysage est magnifique. Même si on a une petite fenêtre dans le Soyuz, j'ai essayé d'en profiter, on est passé au sud Pacifique, j'ai vu des îles que j'ai essayé de dessiner sur ma documentation pour m'en rappeler, pour les retrouver plus tard, donc j'en ai déjà pris plein les yeux. On a volé comme ça, sortir de la nuit pour aller vers le lever de soleil, qu'on prend plein dans les fenêtres du Soyuz, puis on voit la Terre se dessiner, donc ça c'est la vraie grosse différence, c'est que techniquement le travail c'est ce qu'on a appris depuis 7 ans, mais l'environnement il est complètement différent, parce que là on est dans l'espace pour du vrai, et ça c'est irremplaçable, ça met les étoiles dans les yeux.
Allô, Major Tom, c'est Baptiste. Bon, écoute, je voulais juste te dire qu'on a vécu des choses extraordinaires ces derniers jours en assistant à tout ça. Je sais aussi qu'en France, il y a plein de gens qui ont vécu à peu près les mêmes choses, les mêmes émotions. En ce moment, tu fais rêver plein de gens. Et je sais que tu vas continuer à les faire rêver pendant ta mission et ensuite. Donc je voulais juste te dire que j'étais vraiment très fier de mon petit frère. Et je te souhaite à toi ainsi qu'à tout l'équipage une très belle mission dans votre nouvelle maison.
Merci, c'est sympa, ça me touche beaucoup. On va faire de notre mieux, ouais, pour l'instant. C'est que le début, on est arrivé là, c'est déjà pas mal, mais il reste 6 mois de boulot, et là, les choses sérieuses commencent, en fait. Et on va s'y mettre tout de suite en arrivant, parce qu'il faut qu'on aille ranger notre Soyuz, et ensuite commencer à lancer dès le samedi soir, comme ça, au milieu de la nuit.
Peggy, this is John. I first want to tell you how great you look. You look like you're already having a great time. We are so proud of you, and we're so excited to be part of this great adventure. I want to wish you all the best from your extended family here in Moscow, and tell you that we're so excited that you're back at your home again, and that you are... we're just hoping that the tenants took good care of it for you before. We're wishing you all the best. We love you, and I'm turning it over to Sheila.
Okay, thanks, girlfriend.
Appreciate
this is Sheila.
Hey, Sheila. Hey, how did the launch look?
Beautiful, absolutely beautiful, breathtaking. We were so proud and so happy of you, and like Clarence cheered when you guys launched, you go, girl! So, all the best on a wonderful mission, and thank you for all you do, for all of us, all of moving mankind forward. We're proud of you. I love you. Here's Sandy.
Thanks.
I love you. Here's Sandy.
Love you too.
Hi, Peggy. This is Sandy. I just wanted to tell you how proud that we are of you and how great you look. And I know you're excited about being there and all the projects that you're going to get done for them. I hope that they can keep you busy. Love you very much. Bye-bye. Love you very much. And here's Larry.
Love you too, Sandy.
Hey, Peggy. Hey, Peggy, this is Larry. Want to wish all you guys congratulations on a good flight. And everybody's pretty much said everything except I hope they do keep you busy. And we love you, and we're going to be thinking about you. And hope everything is very successful for you guys. Love you.
Thank you. Love you too.
Allô Thomas, c'est Laurent pour les Proximan. Écoute, on est super heureux de te voir là dans la station. On t'a vu sortir de l'île du Soyouz avec un grand sourire. On sait que là tu accomplis les choses, tu accomplis ton rêve. Et on t'a vu avec la grande banane. On t'a vu décoller, on a crié, on a fait des yé, on a fait des wouh, on a fait des go Thomas. Et on avait une question à te poser qui nous a quand même taraudé pendant ces 48 heures. Et tu connais notre esprit scientifique. À la conférence de presse, tu as dit que tu allais jouer au dé avec tes collègues et on s'est demandé comment on pouvait jouer au dé en apesanteur. Alors j'aimerais bien que tu nous répondes à cette question, s'il te plaît.
Alors si je me rappelle bien, j'ai dit que j'en allais jouer aux cartes, mais effectivement j'ai aussi un jeu de dés. Jouer aux cartes, on a essayé, c'est pas facile parce que ça vole partout, donc on peut les coller sous des petits élastiques. Les dés, ça marche carrément pas. J'ai pensé à mettre des petits coins de velcro sur les faces du dé, mais on voit plus quelle face du dé on a. Donc les dés, c'est un échec total pour l'instant. Les cartes, c'est une semi-réussite, mais j'ai 6 mois pour y bosser et je me laisserai pas arrêter par les lois de la physique.
Guys, I don't know if you heard the loud applause on the balcony. Here we have a lot of mass media representatives, a lot of guests, a representation from the French team, and Thomas, your team came to Star City for basic training, and now you're the final of your group. Your entire class has gone to space. And I wanted to remind you that today, on the 20th, many years ago, the first module of the station was launched, FGB was launched, and that's how the ISS started. And we started assembling it so we can celebrate the station's birthday today. And those who arrived for the first time and those who have been flying for a while and who have frequented the station before, we would like to wish you a good flight. Enjoy your work, and we'll continue working together. Good luck. Thank you very much. And thank you very much for all your support. Thank you, everyone.
This is Mission Control Korolyov with those final words by veteran Russian cosmonaut Sergei Krikalev to the crew on board the International Space Station, noting that the docking of the Soyuz MSO-3, bringing Oleg Novitsky, Peggy Whitson, and Thomas Pesquet to the station, occurring on this, the 18th anniversary of the launching of the first element of the station, the Zarya module, or FGB, which lifted off from the Baikonur Cosmodrome on November 20th, 1998, atop a Proton rocket to begin the era of the International Space Station. The 6 crew members now will set about to conduct a traditional safety briefing to ensure that they understand the passageways, evacuation routes to their respective Soyuz vehicles, as well as other safety procedures. The Soyuz systems will be deactivated with the Soyuz having been placed on International Space Station power for the duration of its stay, linked up to the Rassvet module of the International Space Station. To recap, the arrival of the new crew, which launched 2 days ago from the Baikonur Cosmodrome, Oleg Novitsky, Peggy Whitson, and Thomas Pesquet, with a flawless 34-orbit 2-day rendezvous that brought them to a docking to the Rassvet module of the station at 3:58 p.m. Central Time on Saturday, 4:58 p.m. Eastern Time. About 3 hours later, the hatches opened between the Rassvet module and the International Space Station, and the new trio floated on board to join Station Commander Shane Kimbrough and Russian cosmonauts Andrei Borisenko and Sergei Ryzhikov, who have been on board for the past month. So Expedition 50 is now rounded out to a 6-person crew. A busy, busy time ahead in the next few weeks over the holidays and into the new year for this 6-person crew, with the next major activity just 48 hours away, that being the detachment and release of the orbital ATK Cygnus cargo craft that arrived at the station last month. It is docked at the moment, berthed to the nadir or Earth-facing port of the Unity module of the International Space Station. It has been grappled by the station's Canadarm2 robotic arm. It will be detached early Monday morning and released by Shane Kimbrough, backed up by Thomas Pesquet from the station's cupola as they operate the station's robotic arm to release its grasp on the Cygnus cargo craft. Our coverage on Monday morning of the Cygnus departure will begin at 7 a.m. Central Time, 8 a.m. Eastern Time. The release itself scheduled at 7:20 a.m. Central, 8:20 a.m. Eastern Time on NASA television on Monday morning. Cygnus will drift to a safe distance away from the station for its deorbiting. That will be conducted by the orbital engineers based on the Orbital ATK Control Center in Dulles, Virginia. It will re-enter the Earth's atmosphere on November 27th and burn up harmlessly over the Pacific Ocean. So that'll be our next major activity for the International Space Station on NASA television. But for now, Expedition 50 rounded out, all 6 crew members safely on board, following a flawless rendezvous and docking of the Soyuz MSO-3, bringing Oleg Novitsky, Peggy Whitson, and Thomas Pesquet to the station to join their trio of counterparts, Shane Kimbrough, Andrei Borisenko, and Sergei Ryzhikov. With that, we'll complete our coverage of the arrival of the new crew members to the International Space Station. We thank you for joining us throughout the evening, and we wish you a good weekend, and we'll see you again on Monday morning for the release of the Orbital ATK Cygnus craft. For now, this is Mission Control Korolyov.
Good evening, this is Atlas Launch Control at a mission elapsed time of 2 hours, 18 minutes, and 15 seconds. The United Launch Alliance Centaur upper stage with the NOAA GOES-R satellite continue their trek away from the Earth, getting higher and higher with every minute during this 3-hour coast phase. Everything has gone very well so far. You can see that the spacecraft has made it over north of Australia. Launch today originally was targeted for 5:42 p.m. Eastern Time. However, a technical issue coupled with an issue that the Eastern Range was working pushed our launch window to the end. We had a 1-hour launch window, and at 6:42 p.m. Eastern Time, the Atlas booster with its 4 solid rocket motors lifted off. A beautiful launch, carrying the NOAA GOES-R satellite into space. The original Atlas liftoff was followed by 2 Centaur burns. The upper stage setting the course that you see on the screen now. A little bit later this evening, there will be 1 more Centaur burn. That's scheduled for 10:09 p.m. Eastern Time, and the burn will last about a minute and a half, setting the GOES-R payload in the proper location for spacecraft separation, which is scheduled for 10:13 and 55 seconds. So just about 10:14 this evening. After spacecraft sep, solar arrays are scheduled to deploy about 10:20 p.m. NASA television will carry a replay of the International Space Station Soyuz docking activities that occurred earlier this evening. That coverage will begin at 9:30 p.m. Eastern Time, and we'll rejoin for continuing coverage of the Atlas Centaur GOES-R trek into space and the final Centaur burn, spacecraft separation, and solar array deploy. Our coverage for those activities will begin on NASA television at 10 p.m. Eastern. At a mission elapsed time of 2 hours, 21 minutes and counting, this is Atlas Launch Control.
Speaking. Speaking, I'm glad to see you in good health and in a good mood. Congratulations to the arriving crew. First part of your flight has gone well, good docking, and you're on board of the station. And congratulations to the guys who were waiting for you, who you're joining now. We're wishing you to complete good work, and I'm going to pass the microphone to the next speaker.
This is Charlie Bolden from NASA, and I just joined Sergey and all the crew here and congratulating you on finally being there on station. I know it's really special. Tomas, you've got a huge crowd down here, so don't screw it up. And Peggy, I just wanted to say one thing special to you. You know, as you reminded us, 23 years ago in February, as my mentor, you watched this guy sitting next to me, Sergei Krikalev, and me go off into space, and we wanted to do well for you. We were very proud to be in Baikonur, walk you to the vehicle, and then watch you go off into space. And now watching you, we could not be more proud. So all three of you, all six of you actually, have a great time in the months ahead. We're all proud of you.
Hello, everyone. Thanks so much, Charlie. We're really happy to be here.
Félicitations à vous, Thomas. I convey the congratulations and the greetings of Jan Werner, the Director General of the European Space Agency. He is watching you from Paris. You're the first ESA astronaut, French nationality, to go to the ISS since 2008. You're the first to do it in the era of Twitter, and I know you're going to excite and inspire many young people. So good luck with your work, good luck with the science, and I'd love to know what the flight was like compared to your expectations, compared to flying on Air France.
Oleg, well, tell us how you were flying, how you were docking, what are your impressions after the long absence on board of the station? We're very happy. Well, the entire process of the approach at the in close range, yes, we were nervous. Yes, we saw this process. We'll look at what was going on, but the automatics worked well, so we're very happy for you. Peggy, congratulations to you on your one more stay on board of the station. Previous flight of mine was right after your increment, and I'm very glad to see that you keep flying and you continue to make your contribution to the development of space exploration. Thank you. Hello? Oleg, dear, hello, this is Julia. Hi. Hello. Peggy and Tamar, hello. Hello to everyone. Hello, Julia. How was your flight? It was pretty good. Just 2 days of flight, and then we are on board the station. All friends and family members are asking, where is your toy set of crew members? Why didn't we see it? It's guarding our vehicle over here. All the cargo items are still in there. Dear grandson, hello. Hello, my dear. Hello, Grandma. We're congratulating you and your entire crew with the launch, with docking, and everything went nominal. We're very glad. You have a wonderful crew. We were listening to the press conference. Answers to questions were great. And we, the Earthlings, need to follow your example. We need to all love each other God give you good health to you and your crew and your colleagues. We're hoping you will always be such a well-built crew, friends to each other, every success. And we're wishing you to accomplish all the goals that were set for your crew. We have a lot of people waiting for their turn here, so I'm going to pass the mic to someone. And we love you very much, and we already started countdown to your returns. Thank you very much from the entire crew.
Peggy, this is John. I first want to tell you how great you look. You look like you're already having a great time. We are so proud of you, and we're so excited to be part of this great adventure. I want to wish you all the best from your extended family here in Moscow, and tell you that we're so excited that you're back at your home again, and that you are... we're just hoping that the tenants took good care of it for you before. We're wishing you all the best. We love you, and I'm turning it over to Sheila.
Okay,
Hey, girlfriend.
Appreciate
This is Sheila.
being there. Hey, Sheila. Hey, well, how did the launch look?
Beautiful, absolutely beautiful, breathtaking. We were so proud and so happy of you, and like Clarence cheered when you guys launched, you go, girl. So, all the best on a wonderful mission, and thank you for all you do for all of us, all of moving mankind forward. We're proud of you. I love you. Here's Sandy.
Hey. I love you. Here's Sandy. Love you too.
Hi, Peggy. This is Sandy. I just wanted to tell you how proud that we are of you and how great you look. And I know you're excited about being there and all the projects that you're going to get done for them. I hope that they can keep you busy. Love you very much. Bye-bye.
Love you very much.
And here's Larry.
Love you too, Sandy.
Hey, Peggy. Hey, Peggy, this is Larry. Want to wish all you guys congratulations on a good flight. And everybody's pretty much said everything except I hope they do keep you busy. And we love you, and we're going to be thinking about you. And hope everything is very successful for you guys. Love you.
Thank you. Love you too.
Guys, I don't know if you heard the loud applause on the balcony. Here we have a lot of mass media representatives, a lot of guests, a representation from the French team, and Thomas, your team came to Star City for basic training, and now you're the final of your group. Your entire class has gone to space. And I wanted to remind you that today, on the 20th, many years ago, the first module of the station was launched, FGB was launched, and that's how the ISS started. And we started assembling it so we can celebrate the station's birthday today. And those who arrived for the first time, those who have been flying for a while and who have frequented the station before, we would like to wish you a good flight. Enjoy your work, and we'll continue working together. Good luck. Thank you very much. And thank you very much for all your support. Thank you, everyone.
Here's some of the stories trending this week at NASA. The Expedition 5051 crew, including NASA astronaut Peggy Whitson, launched aboard a Soyuz spacecraft from the Baikonur Cosmodrome in Kazakhstan November 17th Eastern Time to begin a 2-day flight to the International Space Station. Whitson, Oleg Novitsky of the Russian space agency Roscosmos, and Thomas Pesquet of ESA are scheduled to join Expedition 50 commander Shane
degrees west longitude, where GOES-R and the instruments will go through post-launch checkout for about 6 months. And after that, the satellite will remain at a checkout location for an additional 6 months for an extended validation phase. However, during this time, weather forecasters will have access to GOES-R data for testing and verification. Once it goes operational, GOES-R will be renamed GOES-16 and will be operational in late 2017. This satellite will provide 5 times faster weather coverage, better data for hurricane tracking and intensity forecasts, real-time mapping of total lightning for improved severe weather forecasts, advanced warning of space weather hazards, and improved transportation safety, all from one satellite. It will significantly improve weather forecasting and severe weather prediction. Seeing from the coast of West Africa all the way across to Guam and everything in between, NOAA's geostationary satellites provide vital data and information for meteorologists and academics throughout the Americas, Europe, Asia, and Africa. And carrying the most advanced sensors of their kind, this NOAA GOES-R satellite will fly more than 22,000 miles above Earth and offer weather forecasters an unblinking eye on conditions on the planet below. The GOES-R ground system, which will process the data, is located in 2 primary locations: the NOAA Satellite Operations Facility in Suitland, Maryland, and the Wallops Command Data Acquisition Center at Wallops, Virginia. There is a 3rd operations facility in Fairmont, West Virginia, which will serve as a backup location in the event of a communications issue at either Suitland or Wallops. Everything remains on track. We'll be standing by for that Centaur 3rd main engine start at 10:09 and 32 seconds p.m. Eastern Time. Right now, though, we'd like to show a video for you that expounds upon the capabilities of the GOES-R satellite.
Weather is always changing, and the better we can predict what's coming, the better we can prepare. The GOES-R series, NOAA's next-generation geostationary weather satellites, will be a game changer for weather forecasting. For the first time, GOES-R, which will be called GOES-16 once it's operational in space, will be able to monitor the Earth in near real time. Using a powerful new instrument called the Advanced Baseline Imager, GOES-R gathers data and imagery about weather over the Western Hemisphere as frequently as every 30 seconds. This enables NOAA to gather data with 3 times more channels, 4 times better resolution, 5 times faster than before. Faster, more accurate data means better observations of phenomena like severe storms, fire, smoke, aerosols, and volcanic ash. But this is not the only new instrument aboard the satellite. GOES-R is flying another powerful technology called the Geostationary Lightning Mapper. This instrument can not only measure when lightning strikes the ground, but also lightning activity in the clouds that is charging the atmosphere. Researchers have found that an increase in lightning activity may be a sign that tornadoes will form. GLM will change the way forecasters look at severe weather to provide faster and more accurate warnings. All of this new technology means forecasters at NOAA's National Weather Service will have valuable tools to improve predictions of severe weather events, like hurricanes, providing faster warnings to emergency managers to help save lives and protect communities. Space weather is serious business in the 21st century, as much of modern life relies on sophisticated electronic systems. Working with other NOAA satellites, GOES-R will observe space weather with a suite of instruments that collect information about radiation hazards from the sun, Space weather can interfere with communications and navigation systems, damage satellite electrical systems, cause risks to astronauts, and threaten power utilities. NOAA launched its first geostationary satellite more than 40 years ago. Since then, the invaluable data from GOES satellites has been essential to countless industries like aviation, sea transport, and communications that rely on weather data. Sitting 22,300 miles above the Earth, the advanced technologies flying on the GOES-R series of satellites take weather forecasting to new heights.
After a spectacular liftoff at 6:42 p.m. Eastern Time atop an Atlas V rocket, as the Centaur second stage engine, NOAA's GOES-R satellite is poised for its flight into space just minutes away. We're a little bit under 4 minutes from the Centaur third main engine start. We'll be listening to the voice of Marty Malinowski from United Launch Alliance, who will be providing engineering data and information on the burn. Centaur has been in a coast phase for nearly 3 hours after the successful second Centaur main engine burn. Everything continues to go well. This is Atlas Launch Control.
Planned third burn is for 93 seconds. Tank pressurization is underway in the LOX tank.
About a minute and a half away from the Centaur third main engine start.
Centaur fuel tank is being pressurized.
One minute away from the burn.
We have LO2 pre-start. We have LH2 pre-start.
Standing by now for the Centaur third main engine start. This will be a short burn of only about 1.5 minutes. 10 seconds.
And we have ignition and full thrust on the RL-10. Centaur PU is being commanded at fixed angles and has now gone to active control.
The burn is underway and everything is going well.
Chamber pressure, LOX pump discharge, and venturi pressures all look good for the nominal MR set. Mass error is basically zero. Engine burn is progressing well. All levels look good.
Standing by for Centaur main engine cutoff.
Continue to burn well. And we have MECO. Engine shutdown looks good. We've gone to forest settling.
MECO, main engine cutoff. Everything went well on the burn. Spacecraft separation is planned for...
Centaur fuel tank has been vented down. Pressures are now stable. Million bottles are stable as well. Batteries look good.
Spacecraft separation planned for about 10:14 p.m.
We have begun the turn to spacecraft separation attitude.
We will not see live video of the separation. However, we are expecting to receive a video playback about 12 minutes afterward, around 10:26 p.m.
Center's gone to 50% settling on the forest motors.
Centaur moving to the deploy attitude.
Centaur fuel tank is being vented down again. Pressures are now stable. Centaur has completed the turn to spacecraft separation attitude.
Just about a minute away from spacecraft separation. Standing by for spacecraft setup.
And we have indication of spacecraft separation.
And applause here in the Atlas Spaceflight Operations Center, Mission Director Center, as we see spacecraft separation. Spacecraft separation at 10:14 and 4 seconds p.m. Eastern Time, as the spacecraft soared high above the Java Sea, west of Indonesia. NASA's GOES-R flies free for the first time in an elliptical orbit whose apogee is close to its final geosynchronous altitude. Next major milestone, the GOES-R solar array deploy, scheduled 5 minutes and 50 seconds after spacecraft separation. So at about 10:20 p.m.,
systems continue to look very good.
The 5 panels will be extended out looking at the sun in step 1 of the deploy. The second deploy step, lifting the yoke and 2 solar instruments off the body of the satellite, is scheduled about 10 days from now. The launch team here at Cape Canaveral Air Force Station celebrating. The Atlas Centaur rocket did its job once again, delivering a spacecraft to the perfect location in space, as the Atlas V has had a 100% success rate.
Actual position versus pre-flight predictions is in excellent agreement with very small deltas. With that, this concludes the plus count broadcast of the GOES-R AB-69 mission.
Marty Malinowski from United Launch Alliance signing off after a successful Atlas mission, delivering the NOAA GOES-R satellite to space. This is Atlas Launch Control at a mission elapsed time of 3 hours, 35 minutes, and 48 seconds. It's been a long day. It's been a long day here in the Atlas Spacecraft Operations Center for the launch team, and we're pleased at this point to be joined by the NASA Launch Manager and from NASA's Launch Services Program here at Kennedy Space Center, Omar Baez. Good evening, Omar.
Thank you, Mike.
We thought maybe we would have you about an hour earlier than we do at this point, but it turned out to be kind of a longer day than you anticipated. Can you tell us a little bit about that?
Sure. It's been a long 2 days. You know, we start this at L-2 days, or we started yesterday with rolling the vehicle out, and it took us a long time. We had a traction device that was supposed to help 2 other of the traction devices, and this one was stubborn and wouldn't start. And so it just snowballed from there. And so the guys really worked hard through the day yesterday and into the night. Came back early this morning, and we were behind by quite a bit, and were able to catch up. And work through some issues, not only on the range, but with some of the GSC, and then
ground support equipment.
Yep. And then we're even affected by something that was going on one of the other pads at the very end there. So it was like doing one of our dress rehearsals. We just went through about everything you could imagine, except for actual problems with the flight hardware. The flight hardware performed beautifully throughout the count, and the weather was perfect. But although the culmination of all those low-level issues caused us to consume most of the hour window that we had. In fact, all of it. So once we targeted the end of the window, we were able to hit it. A couple of minutes ago here, you probably heard some shouting and so forth, and it was just congratulatory. You know, the spacecraft separated. Quite a long mission from the time of launch to separation, 3.5 hours. That's unusual for our normal NASA missions, which are usually about an hour and a half between the time we launch to the time we actually separate the spacecraft. But all is going well.
It was a beautiful launch, and it looked like everything went well. The Atlas booster performed perfectly, and the Centaur completed 3 perfect burns. And it sounds like from what Marty Malinowski was saying that the spacecraft is nearly exactly where it's supposed to be in space.
Yeah, the numbers that I saw on the orbits were down to the 2 decimal level, which was awesome, considering how far away from the Earth this satellite's at right now.
And this is continuing the trend of a 100% success rate for the Atlas V launch vehicle.
Yeah, we say that, but it's always one at a time. And this one was certainly up to its challenges. And hopefully 9 months from now, we'll have an asset up in space that will help our weather forecasters and what they do on a daily basis and bring them up to the 20th century as far as almost having closed circuit TV up on what the weather's doing from that high up. So it's fantastic.
Well, this is the start of its long mission. Possibly up to 20 years of providing color, high-speed imagery and data back to folks on the Earth to help save lives. So thank you for getting us off the ground today, and thank you once again for your time, Omar.
Thank you, Mike.
This is Atlas Launch Control. We're at a mission elapsed time of 3 hours, 46 minutes, and 21 seconds. We're still waiting for confirmation of solar array deploy on the GOES-R satellite. As soon as we have confirmation, we will pass it on to you. This is Atlas Launch Control. We have confirmation that the solar array deploy has begun. Looking now at a replay of the GOES-R separation from the Centaur upper stage. This was recorded at the moment of separation, and it's being played back to all users at this time. This is from the forward-looking camera on the Centaur upper stage. Once again, a replay of the earlier spacecraft deploy, separation of the NOAA GOES-R satellite from the United Launch Alliance Centaur upper stage as viewed from the forward-looking camera on the Centaur. Separation occurred at about 10:14 p.m. This is Atlas Launch Control. Mission elapsed time of 3 hours, 56 minutes and counting. The NOAA GOES-R satellite has reached its temporary place in space. The solar array deploy is still underway, and we expect to receive confirmation of full deployment within the next several minutes, which we will pass on to you. This is Atlas Launch Control. A little bit more than 4 hours since the launch of NOAA's GOES-R satellite. The spacecraft was deployed about 10:14 p.m. Eastern Time. The solar array have been in the process of being deployed, and we're standing by for final confirmation. This is Atlas Launch Control. We've been experiencing a wonderful day following the liftoff of the Atlas V rocket and deploy of NOAA's GOES-R satellite. And at this time, we're very pleased to be joined by Pam Sullivan, NOAA GOES-R Mission Director and Flight Project Manager. And I think that you have some good news for us.
Yes, we do. It looks like we have our solar array deploy. At least the early indications are we've got power, and the rates were as expected for a positive array deployment. We've got a little more data to look like, but everything looks very, very good right now.
Excellent. That's good news.
Yes.
This has been a long time coming. You and your teams have been working for many, many years getting the satellite ready to go. How long has it been?
The first records I can find of anything on GOES-R was actually 1999, so 17 years or more in the planning and the building and the testing, and yeah, for really big effort to put together this satellite. So.
And the satellite life duration is somewhere in that neck of the woods too, is it not?
It is. The planned on-orbit life is 10 years of operation and 5 years of on-orbit storage, since often the satellites go into storage while they're waiting to be used on orbit.
Well, the simulations and the animation that we've been able to look at is just remarkable. The technology that you've infused into the satellite, and it's just amazing the quantum leap that everyone is going to benefit from.
Yeah, the instruments, the new cameras that we're putting on board are really revolutionary. The Advanced Baseline Imager, which is our primary instrument, is going to be able to take pictures so much faster than the current ones, because the detector arrays on this instrument are so much larger, and that really will enable us almost to go from like still photos to video. It's just we'll be able to take images so much faster, and do a refresh of the storms so much faster. We currently, with the GOES, the older generation that we're actually using right now, that took pictures of severe storms about once every 30 minutes. With the GOES-R, we're going to be able to do that once every 30 seconds, so a remarkable increase there.
We've had a group of TV meteorologists here at Kennedy from a group called Storm Center that have been so excited about this, and have been having meetings and gathering at the press site at Kennedy Space Center, and they've had some wonderful stories to tell about already benefiting from and learning how to use this from the simulations that you've been providing.
Yes. So yeah, the excitement from the community is really something, and gratifying for all the folks that put their hard work into this over so many years. They're very excited to know that people are excited to use it and are going to get this great benefit from it.
When will they get the first? I know that you're going through a phase of checkout, but when will they get their very first image, do you think?
Our first picture that we're actually going to take is probably in January. It probably will take us another month or so to do sort of what we call the calibration and then the navigation of the image before it's actually good enough to be released. So I think about 3 months from today is approximately when we'll be able to get something out to the public.
And when does NASA officially turn the keys over to NOAA and it becomes GOES 16?
The plan is it becomes GOES 16 as soon as it gets to geostationary orbit. Okay. So that'll be about 19 days from now if all goes according to plan. But then we do another 5+ months of checkout. And so at about the 6-month point from now is when we'll hand it over to NOAA for operations.
And are there tussles underway as to whether this will become GOES West or GOES East?
I get lobbied, but luckily I have nothing to do with that decision, so I can just ask them to talk to other folks. But yeah, it's such a great capability. Everybody wants it, understandably. So all I can say is we hope to be here with GOES S in about 16 months, and once we get that one up, then we don't have to fight over who gets the new capability.
That's a perfect response and a great way to end the day. And I really want to thank you for taking the time after such a long day to come over and talk to us.
Oh, my pleasure.
Thank you. And after a successful liftoff at 6:42 p.m. Eastern Time and the delivery of NOAA's GOES-R spacecraft to its orbit in space and the successful solar array deploy, this concludes our coverage of the launch of NOAA's GOES-R, the next generation weather satellite on its mission to provide better, faster, more reliable weather data to the Western Hemisphere. This is Atlas Launch Control.
We're here with Dan, a plasma scientist on the magnetospheric multiscale mission. And Dan, I understand that you came on board with MMS just before launch. What exactly are you doing with MMS? And tell us a little bit about your journey so far.
Yeah, so I came onto the mission maybe a year or so before launch. We were really trying to get sort of the data pipeline system going and trying to really take everything we learned from laboratory calibration of our instruments to be ready to correct the data to get sort of physical units out of the data once it came down.
So once the spacecraft launched and everything came on and was working, tell me a little bit about the process of how you calibrate these instruments that are now flying in space.
The really wonderful thing about MMS that's very different from a lot of previous missions is that we have very similar instrumentation. So fundamentally we have particle instruments, we have electromagnetic field instruments, but the fact that we have 4 spacecraft so close together and sort of very fast measurements and really high quality measurements means that there's a lot of different ways to actually check your answer on orbit. And so every instrument sort of has its role to play in measuring a certain quantity, but what we can actually do is certain instruments in the configuration that we're flying can measure the same thing. And so a lot of the calibration process, it really involved comparing data from multiple instruments to try to converge to see what we got as the right answer.
And how long did this calibration process take in the mission before you could actually get out there and start to get real data?
So we commissioned effectively over the summer 2015. And so we had a few months, got our first data down. It started to trickle down as instruments started to turn on, and we got data from one spacecraft at a time. And so as soon as we started getting data from one of the spacecraft, we started trying to take everything we saw coming down from the spacecraft and make sure that it was consistent with things we learned in the laboratory and what was different, and tried to reconcile that. And as we got data from other instruments, tried to compare with those as well. And so commissioning lasts effectively over the summer. And once we got into regular orbit operations in the fall, in September, we were ready to go. And really the big data delivery came this past March, where we really delivered what we thought were almost publication-ready data to the public for the first 6 months of the mission. And so it was a really fast turnaround, but we're quite happy with the way it turned out.
Well, I mean, that's interesting to think of. I mean, I hear about all this data that you've sent down, but what does that actual data look like? I mean, you just get numbers and zeros, and if so, how do you turn that into information about magnetic reconnection?
So I work for the Fast Plasma Investigation, which is effectively 64 different sensors looking off in different directions spread across the 4 spacecraft. 32 of those measure ions, what direction particles are coming from and at what energies, and 32 of them measure electrons. And so the data we get down is effectively an angular map. It has look directions and energies, and we get the number of particles that hit our detector. And so it is our job to take those numbers and take everything we know about the sensitivity of the instruments and how they may change on orbit, and convert that into physical units that then scientists, including myself, can actually analyze and convert into things like number density, temperature, and pressure.
À la gauche, oui. Ça va? Super, merci.
Today is the
Дорогие друзья, Божье благословение вам на ваше
Dear
служение.
friends, may
Хочу
God
пожелать,
bless
Христос
you on your
вернуться,
journey.
призывал вас своим амофором, и ангел-хранитель помогал вам в всех ваших
May He help you in all of your efforts and all of your work.
Бога.
May God bless you. May God bless you.
Так, налево, Олег.
Выставили, Саня зашел, увидел и сразу это.
Сказать, что широкий, ну нормально.
Что такое? Что такое? Подольше, да?
So are we hot mic as well? Can you hear us? You can hear us?
How's it feel? You look good. You look dancing. You look good. You look except for when you're full of hair.
Take care of us. I've had
You'll be our eyes and our ears, and you'll be everyone else wants to do it. So hopefully you'll have just an incredible time.
Thank you, Charlie, and we'll do our best. I know that we've got a great crew here, and we're going to work really hard and just show for the top.
I know you're stoked and ready to go. I guess you must be the first person from Normandy to go into space. So that makes you the first Norman to conquer space. Thank you.
Are you all ready? Ready to go? Okay, may everything go as planned.
Миш, чуть-чуть.
1, 2, 3, 4.
Come forward, turn around.
Order sequence initiated. Oxygen. Sensitivity tower separates. Engine turbo pumps at flight speed. Engine at maximum thrust. Fueling tower separation. Confirmed. Everything's nominal, and the thrusters are working nominally. Copy, and we can hear you 5 by 5. Copy.
NASA Administrator Charles Bolden. Charlie, a thunderous start to this flight for Whitson, Pesquet, and Novitsky. Your thoughts on all of this that has come about over the past few weeks, 2 launches and a landing, and the whole theme of international cooperation at this point?
I think this was a perfect evening. When we talk about the journey to Mars and the way we're bringing nations of the world together, this is the epitome of that. As you have said, it shows how we, through cooperation, international cooperation, we're able to do things that sometimes people might think is next to impossible to get done. So it's a great night. A great victory for the International Space Station in getting 3 more crew members up there, and they're ready to go. They're pumped.
This docking of this crew will occur on the 18th anniversary of the first Element launch of the station. How far has this complex come from fledgling modules to where it is today?
Well, I think if you look back, and you and I were there, so you were in the media at the time, but you will remember people said this couldn't be done, that it was too EVA intensive, it was just too much work. And over the 10 years that it took us to complete station, I think it says what again, an international team that's set on a mission can do when they focus on that mission, and when they get the kind of support that we've gotten through the years. This is the 16th year now for people living and working off this planet. No matter what's going on down here, the crews and the flight control teams manage to focus on their tasks and get everything done, and we live in a totally different world when we're on the International Space Station.
Kirk Shireman, ISS Program Manager. Kirk, quite a start to the expansion of the station crew back to 6 people. Your thoughts on the significance of this launch and what has been accomplished in support of station operations over the past 4 weeks?
First of all, it's a beautiful launch tonight. Very, very clear skies. We can see the vehicle all the way through into the 3rd stage. It's one of the best I've ever seen. So very exciting. We're looking forward to having Peggy, Thomas, and Oleg back up on the space station. Lots of work to be done. We'll be undocking a Cygnus here just in a few days, and then a Progress will launch from the same Cosmodrome here on December 1st. So lots of work to be done. And the amazing thing is all the work that's been done just in the past few days. We've had a landing, we've had Shane and his crew went up to ISS, so a tremendous number of vehicles coming and going to the ISS, and lots of work for this crew to do.
How about the significance of the pace of the work and what is being accomplished up on station during this busy time?
What's amazing to me is that in the midst of all these vehicles coming and going, doing some major repairs on the space station. We just had an oxygen system that was recovered by Shane on orbit. We're still doing a tremendous amount of research. This last crew averaged over 45 hours a week of research, and this crew has over 304 investigations to do, 89 of which have never been done on space station. So in the midst of vehicles coming and going, a tremendous amount of research still going on.
This is the 6th astronaut of the class of 2009 now in space. What does it mean for you as a ESA director for human spaceflight?
Well, the first thing is we've just witnessed an amazing night launch taking Thomas Pesquet up towards the International Space Station. We'll dock very shortly. But it's really important because it's the end of the first set of flights for this set of 6 astronauts, but the beginning of the next period of science and technology aboard the space station that will really bring knowledge and skills back to planet Earth, but also prepare us for going back into deep space, taking us on a journey towards the planets. And that combination of science and technology is what's so exciting about human spaceflight.
With Thomas now in space and Paolo Nespoli, also of ESA, going to space in 6 months, that's the beginning of 1 year of presence of ESA on board the International Space Station. What does it mean for ESA and its ambitious exploration program?
It's really important to develop all the skills and knowledge to prepare us for our long-term vision of space exploration. We're going to stay in low Earth orbit doing science and technology, but the preparation that we need to go further out. So it's the skills we'll gain, it's the experience, and also the excitement I think we'll bring back to Europe.
Да, это все в одном месте, да. Спасибо, Давид.
Ума?
Да, я так хочу. Пришла, если мы Шавили возьмем. Я хочу в рабочий стол.
Телефон не берет, да? Нет.
Стреляют.
Да. Как это?
На море.
Какой еще дорогие? Нам уже ничего не надо, мы в счастье.
Да, что-то надо, они прям четко на Луну. Да,
Я считаю, пуск уже можно не снимать.
Я посмотрели, точка была хорошая, прям по центру ракеты.
Сейчас облака еще загорятся. Все удовольствие.
Ой, ну вот отсюда просто шикарно. Да. Вообще просто. Хочешь попробовать свои мыльницы? Это даже не мой супер, это даже не мыльница, это Peer Review, Карл Сейсман, и там все остальные, там шикарное название.
Спасибо, Захаров. Это он мастер сегодня.
Change sort of was to fly this Air Force experience.
I'm sorry, I remember you better. Let's see what's going on. Yeah, Jeff, they were
À la gauche. Oui. Super, merci. Top.
Today is the
Дорогие друзья, Божье благословение вам на ваши
Dear
труды.
friends, may
Хочу
God
пожелать, чтобы
bless
Христос,
you on your
говорится,
journey.
покрывал вас своим амофором, и ангел-хранитель помогал вам в всех ваших
May He help you in all of your efforts and all of your work.
Бога.
May God bless you. May God bless you.
Так, налево, Олег. Молодцы.
Там выставили, Саня зашел, увидел и сразу.
Сказать, что широкий, ну нормально было. Понятно.
Что такое? Что такое? Подольше, да?
So are we on mic as well? Can you hear us?
You can hear us?
C'est tout à fait
How's it feel? You look good. You look dancing. You look good. You look except for when you're full of hair.
Take care of us.
Look close to you.
I've had
You'll be our eyes and our ears, and you'll be everyone else wants to hear. So hopefully you'll have just an incredible time.
Thank you, Charlie, and we'll do our best. I know that we're going to be here and we're going to work really hard. show from the top.
I know you're stoked and ready to go. I guess you must be the first person from Normandy to go into space. So that makes you the first Norman to conquer space. Thank you.
Are you all ready? Ready to go? Okay, may everything go as planned.
Миш, чуть-чуть.
1, 2, 3, 4. Come forward, turn around.
Order sequence initiated. Oxygen. Center umbilical tower separates. Engine turbopumps at flight speed. Engines at maximum thrust. Fuel in tower separation. Confirmed. Everything's nominal, and the thrusters are working nominally. Copy, and we can hear you 5 by 5. Copy.
NASA Administrator Charles Bolden. Charlie, a thunderous start to this flight for Whitson, Pesquet, and Novitsky. Your thoughts on all of this that has come about over the past few weeks, 2 launches and a landing, and the whole theme of international cooperation at this point?
I think this was a perfect evening. When we talk about the journey to Mars and the way we're bringing nations of the world together, this is the epitome of that. As you have said, it shows how we, through cooperation, international cooperation, we're able to do things that sometimes people might think is next to impossible to get done. So it's a great night. A great victory for the International Space Station in getting 3 more crew members up there, and they're ready to go. They're pumped.
This docking of this crew will occur on the 18th anniversary of the first Element launch of the station. How far has this complex come from fledgling modules to where it is today?
Well, I think if you look back, and you and I were there, so you were in the media at the time, but you will remember people said this couldn't be done. that it was too EVA intensive. It was just too much work. And over the 10 years that it took us to complete station, I think it says what again, an international team that's set on a mission can do when they focus on that mission and when they get the kind of support that we've gotten through the years. This is the 16th year now for people living and working off this planet. No matter what's going on down here, the crews and the flight control teams manage to focus on their tasks and get everything done, and we live in a totally different world when we're on the International Space Station.
Kirk Shireman, ISS Program Manager. Kirk, quite a start to the expansion of the station crew back to 6 people. Your thoughts on the significance of this launch and what has been accomplished in support of station operations over the past 4 weeks?
First of all, it's a beautiful launch tonight. Very, very clear skies. We could see the vehicle all the way through into the 3rd stage. It's one of the best I've ever seen. So very exciting. We're looking forward to having Peggy, Thomas, and Oleg back up on the space station. Lots of work to be done. We'll be undocking a Cygnus here just in a few days, and then a Progress will launch from the same Cosmodrome here on December 1st. So lots of work to be done. And the amazing thing is all the work that's been done just in the past few days. We've had a landing, we've had Shane and his crew went up to ISS, so a tremendous number of vehicles coming and going to the ISS, and lots of work for this crew to do.
How about the significance of the pace of the work and what is being accomplished up on station during this busy time?
What's amazing to me is that in the midst of all these vehicles coming and going, doing some major repairs on the space station. We just had an oxygen system that was recovered by Shane on orbit. We're still doing a tremendous amount of research. This last crew averaged over 45 hours a week of research, and this crew has over 304 investigations to do, 89 of which have never been done on space station. So in the midst of vehicles coming and going, a tremendous amount of research still going on.
This is the 6th astronaut of the class of 2009 now in space. What does it mean for you as a ESA Director for Human Spaceflight?
Well, the first thing is we've just witnessed an amazing night launch taking Thomas Pesquet up towards the International Space Station. We'll dock very shortly. But it's really important because it's the end of the first set of flights for this set of 6 astronauts, but the beginning of the next period of science and technology aboard the space station that will really bring knowledge and skills back to planet Earth, but also prepare us for going back into deep space, taking us on a journey towards the planets. And that combination of science and technology is what's so exciting about human spaceflight.
With Thomas now in space and Paolo Nespoli, also of ESA, going to space in 6 months, that's the beginning of 1 year of presence of ESA on board the International Space Station. What does it mean for ESA and its ambitious exploration program?
It's really important to develop all the skills and knowledge to prepare us for our long-term vision of space exploration. We're going to stay in low Earth orbit doing science and technology, but the preparation that we need to go further out. So it's the skills we'll gain, it's the experience, and also the excitement I think we'll bring back to Europe.
Да, это все в одном месте, да. Спасибо за это.
Thomas.
Да, я так хочу. Ничего, я снимал фамилию возьму. Я хочу в рабочий стол.
Nicole,
телефон не берет, да?
Нет.
Стреляют. Да. Как это? На море.
Ой, еще дорогие.
Нам уже ничего не надо, мы в счастье.
Да, вот это надо, они прям четко на луну. Да, да. Вот спокойно, может стать случайно, да.
Я считаю, пуск уже можно не снимать.
Нет, посмотрели, видите, точка была хорошая, прям по центру ракеты.
Сейчас облака еще загорятся. Все удовольствие.
Да.
Какая пара? Какая пара?
Change sort of was to fly this Air Force experiment.
I'm sorry, I remember you better. Let's see what's going on. Yeah, Jeff was able to meet at the shop.
Vers la gauche. Super, merci. Parfait.
Today is the 11th.
Дорогие друзья, Божье благословение вам на вашу
Dear
жизнь.
friends, may
Хочу
God
пожелать, чтобы
bless
Христос,
you on your
говорится,
journey.
покрывал вас своим амофором, и ангел-хранитель помогал вам в всех ваших трудах.
May He help you in all of your efforts and all of your work.
Бога.
May God bless you. May God bless you.
Так, налево, Олег.
Молодцы.
Там выставили, Саня зашел, увидел и сразу.
Сказать, что широкий, ну нормально было. Понятно.
Что такое? Что такое? Подольше, да?
Проходи вперед, развернитесь.
Come forward, turn around.
Order sequence initiated. Oxygen. Center umbilical tower separates. Engine turbopumps at flight speed. Engines at maximum thrust. Fuel tower separation. Confirmed. Everything's nominal, and the thrusters are working nominally. Copy, and we can hear you 5 by 5. Copy.
NASA Administrator Charles Bolden. Charlie, a thunderous start to this flight for Whitson, Pesquet, and Novitsky. Your thoughts on all of this that has come about over the past few weeks, 2 launches and a landing, and the whole theme of international cooperation at this point?
I think this was a perfect evening. When we talk about the journey to Mars and the way we're bringing nations of the world together, this is the epitome of that. As you have said, it shows how we, through cooperation, international cooperation, we're able to do things that sometimes people might think is next to impossible to get done. So it's a great night. A great victory for the International Space Station in getting 3 more crew members up there, and they're ready to go. They're pumped.
This docking of this crew will occur on the 18th anniversary of the first Element launch of the station. How far has this complex come from fledgling modules to where it is today?
Well, I think if you look back, and you and I were there, so you were in the media at the time, but you will remember people said this couldn't be done, that it was too EVA intensive, it was just too much work. And over the 10 years that it took us to complete station, I think it says what again, an international team that's set on a mission can do when they focus on that mission, and when they get the kind of support that we've gotten through the years. This is the 16th year now for people living and working off this planet. No matter what's going on down here, the crews and the flight control teams manage to focus on their task and get everything done, and we live in a totally different world when we're on the International Space Station.
Kirk Shireman, ISS Program Manager. Kirk, quite a start to the expansion of the station crew, back to 6 people. Your thoughts on the significance of this launch and what has been accomplished in support of station operations over the past 4 weeks?
First of all, it's a beautiful launch tonight, very, very clear skies. We can see the vehicle all the way through into the 3rd stage. It's one of the best I've ever seen, so very exciting. We're looking forward to having Peggy, Thomas, and Oleg back up on the space station. Lots of work to be done. We'll be undocking a Cygnus here just in a few days, and then a Progress will launch from the same Cosmodrome here on December 1st. So lots of work to be done. And the amazing thing is all the work that's been done just in the past few days. We've had a landing, we've had Shane and his crew went up to ISS, so a tremendous number of vehicles coming, going to the ISS, and lots of work for this crew to do.
How about the significance of the pace of the work and what is being accomplished up on station during this busy time?
What's amazing to me is that in the midst of all these vehicles coming and going, doing some major repairs on the space station. We just had an oxygen system that was recovered by Shane on orbit. We're still doing a tremendous amount of research. This last crew averaged over 45 hours a week of research, and this crew has over 304 investigations to do, 89 of which have never been done on space station. So in the midst of vehicles coming and going, a tremendous amount of research still going on.
This is the 6th astronaut of the class of 2009 now in space. What does it mean for you as a ESA director for human spaceflight?
Well, the first thing is we've just witnessed an amazing night launch taking Thomas Pesquet up towards the International Space Station. We'll dock very shortly. But it's really important because it's the end of the first set of flights for this set of 6 astronauts, but the beginning of the next period of science and technology aboard the space station that will really bring knowledge and skills back to planet Earth, but also prepare us for going back into deep space, taking us on a journey towards the planets. And that combination of science and technology is what's so exciting about human spaceflight.
With Thomas now in space and Paolo Nespoli, also of ESA, going to space in 6 months, that's the beginning of 1 year of presence of ESA on board the International Space Station. What does it mean for ESA and its ambitious exploration program?
It's really important to develop all the skills and knowledge to prepare us for our long-term vision of space exploration. We're going to stay in low Earth orbit doing science and technology, but the preparation that we need to go further out. So it's the skills we'll gain, it's the experience, and also the excitement I think we'll bring back to Europe.
Vers la gauche, oui. Super, merci. Parfait.
Today is the
Дорогие друзья, Божье благословение вам на ваши
Dear
труды.
friends, may
Хочу
God
пожелать,
bless
чтобы
you on your
вернуться,
journey.
пожелал вас своим амофором, и ангел-хранитель помогал вам в всех ваших трудах.
May He help you in all of your efforts and all of your work.
Богом.
May God bless you. May God bless you.
Так, налево, Олег.
I'm Ian Ziering, and you're watching NASA Television.
Vers la gauche.
Tamam.
Super, merci. Parfait.
Today is the
Дорогие друзья, Божье благословение вам на ваше
Dear
служение.
friends, may
Хочу
God
сказать, что
bless
Христос
you on your
говорится,
journey.
призывал вас своим амофором, и ангел-хранитель помогал вам в всех ваших
May He help you in all of your efforts and all of your work.
Богом.
May God bless you. May God bless you.
Так, налево, Олег.
Молодцы.
Там выставили, Саня зашел, увидел и сразу.
Сказать, что широкий, ну нормально было. Понятно.
Что такое? Подольше, да?